Shivaya, am I audible?
Yes.
Yes, you are audible.
Namshivaya. Welcome to everyone present here. We will be beginning in few minutes. Thank you. Namshivaya. New day, new beginning, new learnings. Good morning, good afternoon, and good evening to everyone from different parts of the world present here. Let me extend a warm welcome to the newbies here from all the members of Amrita Center for Wireless Networks and Applications, Amrita Vishwa, and to those who us in the exciting journey through knowledge. Before beginning, let's upgrade our using our eyes and looking within ourselves for thanking the energy guiding us. So I request all of you to join with me for the prayer. ध्यायामो धवलावगुण्ठनवती तेजोमयीं नैष्टकीं स्निग्धाङ्गविलोकिनीं भगवती मन्दस्मितश्रीमुखी वात्सल्यामृतवर्षिणीं सुमधुरं सङ्कीर्तनालापिनी श्यामाङ्गीं मधुसिक्तसूक्तिम् अमृतात्मिका ईश। We are going to start the third workshop of our workshop series, and this is based on machine learning. You will be also getting hands-on learning for the subject. Participants are requested to give your actual name for the Zoom meeting, as a certificate of participation will be offered in that name. You will be guided by Dr. Ram and Ms. Durga throughout the session. So before handing over all of you to the mentors of this workshop, let me give you a small tip for the day. The key to success for machine learning is data. I to take over the session from me. Thank you.
Thank you, Deepthi, for that introduction. Good morning to all of you present for this workshop. I hope you are able to see me and also hear me properly. Am I audible? Okay, great. Thank you. So first of all, good morning and good afternoon to our participants from various parts of the world. I am Rahul Krishnan. I'm a faculty at the Center for Wireless Networks at Amrita Vishwavidyapeetham, and I'll be guiding you through this workshop on machine learning. Let me share my screen. Okay. All right. So I hope my screen is pretty visible, and then all of you are able to see what's going on my screen as well. Let me pull this to the side. All right. Okay, so today's workshop is the third workshop series in the International Symposium on IoT and ML for ecosystem restoration and multi-hazard resilience. And most of you who have registered, yesterday was another few workshop series on Python and IoT. And today we'll be dealing with ML for ecosystem restoration. We are from the Amrita Vishwavidyapeetham Amritapuri campus. As some of you may already know, we have a healthcare campus at Cochin. We have the Coimbatore, beautiful campus in Coimbatore, Chennai, Mysore, and Bangalore. And specifically, I am from the Center for Wireless Networks and Application, and we basically are a research center, working on pursuing international caliber research and developing solutions to solve challenging societal problems, and also applying state-of-art technologies to enable these changes. So as an interdisciplinary center, we have research and education going hand in hand. The workshop team that will be helping all the so many participants would be myself, Rahul, Durga, Hemlata, Divya, Parvati, Tom, Dr. Denya, Dr. Alka, who are in the advisory roles, Sai, Shibu, Lakshmi, Vidya, and Anand. So let us start by taking up a very preliminary introduction to machine learning through very popular applications that you may already have heard of, you may already know about, etc. So especially when it comes to machine learning, some of the popular applications are related to machine vision. So for example, the Pragyan rover that was sent to the moon was having a specific machine vision program developed by IIT Kanpur. You would also have read about or heard about robot guidance and automatic inspection systems in industries, identification and sorting of objects. So for example, a robot tries to sort different objects based on the colors, finding and assessing faults in silicon wafers in large fabrication units using convolutional neural network, which is a kind of AI algorithm, and 360-degree vision-based system for autonomous drones. So drones are becoming very popular these days. So there are a lot of ML algorithms going into that in order to guide it and place it in the proper place. Another very famous example is the autonomous cars. Probably most of you have read about it, heard about it. That is almost a lot, a big part of it is driven by ML and AI algorithms, deep learning networks, etc. Another one is what we have here, which is a watch bot, which uses laser pointer to target the object as a reminder. So if we keep a milk can outside and not inside the fridge, it'll basically point a laser to that and then say that, okay, there is, I have not seen this for a long time here. It should not be here. So it'll basically remind us to keep things back in fridge, etc. In terms of autonomous vehicles, identification of vegetations or forest and the road path, the rough terrain, etc., are some of the applications of machine learning and deep learning. Another major area of application is in healthcare, where machine learning has been tremendously used for what is called as decision support systems. So it basically helps the doctors spot certain tumors and cancers, etc., in images, which may have missed the doctor's attention while doing a scanning. And very recently, ML has been used for pandemic progression modeling in understanding how the COVID pandemic has been progressing across different geographies. Early detection of various diseases, such as risk of developing long-term complications, such as blood pressure, diabetes, retinopathic diseases, etc. This has been studied using AI. So according to the current state of art, the AI is able to do most of these tasks as good as humans. So if you give the same data to a human and to a machine learning program, the ML would be able to perform as good as the human involved in this task. Another one is fatal event detection from wearable devices. Again, a lot of people are using wearable devices like Fitbits and Apple Watches, and more kind of watches are coming up. In order to detect certain fatal events ahead of time, like atrial fibrillation, you may have read about news about Apple Watch able to predict certain events much ahead of time. And all of you are using smartphones, and you would have either used OK Google, which is a Google smart assistant, or Hey Siri, which is the Apple counterpart to this. So in that, in the smartphone, the autocorrect, auto suggestions, etc., uses machine learning. Speech to text, for example, we speak and then it's translated into text, that uses machine learning. Smart assistants such as OK Google or Hey Siri, that basically we can just tell the phone, set an alarm, set a reminder, set a calendar event, call this person, text this person, etc. So all these are made possible using machine learning algorithms. When you go to any movie or shopping sites, you would know that it automatically pops up some recommendations. You have shopped for this item, probably this may be of interest to you. So that is also involving machine learning. And targeted advertisements, ads that you see all over the web is now behind the scenes powered by machine learning. So now basically I gave you a very broad overview of some of the applications of ML in popular parlance, popular use, which basically means that every single day you would have used machine learning for something or the other, either knowingly or unknowingly. Now let us come to the section on machine learning for ecosystem restoration. So I am assuming that many of you are interested in have various interests. It could range from different domains. But as part of this symposium, we are also trying to focus on climate change and ecosystem restoration. So this symposium itself was started on the World Environment Day on June 5th. So the major goal is to help you understand what are the major climatic issues and how can we use various technologies in order to solve that. And ML is one of those technologies. In terms of ecosystem restoration and climate change, let us take a look at what are the different opportunities for you to apply machine learning. So I'm quite sure that from the participant file, I am made aware that I come to know that many of you are UG students, many of you are postgraduate students, some of you are PhDs, many of you working in CS, EC, electrical, various different geosciences, MSc, BSc, etc. So all of you have various interests. Now, through this workshop, we also want to help you understand some of the, or help you give pointers towards some of the problems that it may be of interest for you to work on. So these are all open challenges, open problems. So it could form your final year BTech theses, final year BTech projects, final year master's projects, theses, and some of them are actually contributing to hundreds of PhDs every single year across the globe. So that's why I wanted to give you an overview of where all machine learning algorithms and models have already been applied, and there is a lot of opportunity for different kinds of applications in these domains. So let us start this particular discussion on machine learning for ecosystem restoration. In terms of mountainous environment and ecosystems, some of the major challenge has been glacial retreat, avalanches, melting ice, ice melting, etc. So machine learning has been used to model these, to predict how far the glacial retreat is going to be in the coming decades. What is its effect on the downstream rivers? Can we predict avalanches ahead of time, etc.? When it comes to forest ecosystems, forests, as you know, are the lungs of the world. So monitoring forests and wetlands are having a huge importance. So machine learning has been used in understanding how forest fires affect the forest cover or predict the forest fires, how wetland ecosystems can be modeled using machine learning and predict the health of wetland ecosystem using machine learning. When it comes to agriculture, which is very important, both as an occupation and as an industry, it is both highly important. Precision agriculture, irrigation, and produce management are some of the major areas in which the ML application has been used. In terms of industries, all of us know that there are supply chain issues or supply chain pipelining that needs to be focused on in all industries. So for example, during lockdown, we saw that there was a lot of disruptions in the supply chain. For example, you might have read, I don't know, you may have already known this, that because of the change in the production of silicon wafers or small chips, ICs, because of the lack of production in that affected the car production and many other equipment production, and Ford and GE had to shut down many plants because of this. So because of the importance, such huge importance, that even such small incidents, for example, the effect of COVID on the manufacturing of chips has finally led to shutting down of a lot of car factories. So how can machine learning model help in predicting that or understanding it ahead of time? Then emission modeling is another major issue. How can we optimize the emissions so that we are releasing emissions into the atmosphere only at the right time, and it does not affect the climate much. In terms of urban planning and modeling, future cities, optimizing usage of electricity, reducing transport activity, efficient mobility, I'm going to come into details of that. This is the largest solar power park in the world, which is getting built in India. So how to optimize solar power generation and its distribution. And finally, climate modeling and prediction. So these are some of the major broad areas in which machine learning has already been applied to some extent, but there is a huge, it's like a huge mine, huge gold mine of problems and challenges that is awaiting, which can form part of your thesis work, your project work, etc. So now let us take some very specific example. I wanted to give you a very broad overview of where all machine learning can be applied in terms of ecosystem restoration. So in terms of electricity systems, forecasting supply, the sun is always there, especially in the tropical areas. 300 days we get sunlight. So how can we forecast supply of sun energy, accelerating fusion science, detecting methane leakages in coal mines? And when it comes to power transmission, there has been huge amount of work in this one. Even now, many of the models are actually using, many of the power transmission companies are using ML algorithms to optimize their transmission. And how can we forecast demand? In the evenings we have higher demands, or some festivals we have higher demands. So can we forecast the demand so that we can balance the load across different energy sources? So from sun to the small bulb in our house, we are applying, and we are going to apply ML in many of these aspects. Now, in terms of in terms of transportation, how can we reduce the transportation activity? As all of you know, transportation contributes a lot to global warming. So analyzing data, remote sensing, forecasting, freight, consolidation, alternatives to transport are all different aspects that research is going on. Model shifting, how can we identify consumer choices ahead of time? So we want to predict, are the people going to use Uber in the next 1 year more than their personal cars? So we want to predict that, we want to understand that. So all these machine learning are used. Even you may already know this, most of these ride hailing services such as Uber or Ola, etc. They use ML algorithms to optimize the distribution of cars, the selection of drivers, etc. So this has already been used, but there is huge opportunity. And in terms of vehicle efficiency, alternative fuels and electric vehicles, there is another major area of work that's going on. Now, in terms of urban infrastructure, modeling energy across different buildings, the new buildings and the old buildings, how can we model the energy cycles, and optimizing heating, ventilation, and AC in huge buildings, data for smart cities, efficient sensing, and targeted retrofitting strategies. Even in old building, how can we retrofit the systems, HVAC systems, so as to enable higher utilization of available resources. In terms of manufacturing industries, I'm not going through the entire thing. Preventive maintenance, identifying if the machines are going to have issues ahead of time. Then optimizing shipping routes and preventing overstocking. That's a huge area of work. For example, Flipkart, Amazon, and all, they use such AI algorithms. And almost all the distribution companies like Delivery, Blue Dot, etc., they use AI through their supply chains in order to optimize this. And when it comes to agriculture, again, huge opportunities. Precision agriculture. How can we, use the available resources of water and fertilizers such that we get more yield with the existing resources itself? So that's an AI. That's a huge challenge now currently being addressed by AI also. And monitoring peatlands. Peatland is like a wetland. So wetland ecosystems are extremely important for the maintenance of harmony in the nature. So again, that is another area where monitoring is going on. Estimating carbon stock. Some of you are aware of carbon stocking. They would know what are the different challenges. Automating afforestation. Can we predict and model afforestation such that we come to a very optimized use of existing afforestation techniques? And finally, managing forest fires and reducing deforestation through AI. So what I wanted to give you is an understanding about the entire broad spectrum of opportunities available for you to apply ML. And finally, in climatic models, ice melting, learning ice reflectivity, making high resolution forecasting of storms, hails, cyclones, classifying land use as how is the urbanization going to affect the forest cover in particular cities, and then tracking storms, simulating ocean mixing, etc. So in all these different areas, there are huge opportunities. So that kind of wraps up my brief session to give you an introduction to various domains in which you can work, especially in ecosystem restoration. This is a seminal paper in this area, tackling climate change with machine learning. You can access it from here. We'll be uploading the materials. We'll give you the site link for this workshop very soon, where all these PDFs of the presentation and the code, etc., are already uploaded. But that can wait for some more time. So in this, as you can see here, they have listed various machine learning algorithms and techniques. And on this axis is all the different domains, subdomain areas, etc. As you can see, for example, computer vision is being used in many of them. Reinforcement learning and control theory is used in many. Time series analysis, another machine learning technique. Unsupervised learning. So these are all used in all these various domains that I just talked to you about just now. Now, how did we at Amrita use this ML over the past many years? Our center, Amrita Center for Wireless Networks and Applications, developed the world's first wireless sensor network system for detection and early warning of landslides. So as most of you know, landslides caused due to rainfalls, heavy rainfalls, and various other reasons cause more than 56,000 deaths per year. Now, we developed sensors which are deep deep earth probes, which go into the deep earth layers and give us the data from different sensors, like IoT sensors. And from these sensors, whatever data we get, we use it to build machine learning models to predict such landslide ahead of time. And we got a lot of support from the European Commission and the Indian government to deploy our system. And as of today, we have 2 active deployments. First in the Western Ghats, which was probably a decade back, we had deployed in Munnar. This is the picture. And more recently, we had also been asked to deploy it in northeastern Himalayas in Sikkim. Again, we have had a very successful deployment. And using this AI and ML along with the data from the IoT sensors, the Amrita's early warning system has issued warnings in 2009, 11, 13, 18, and 19. And that has helped to evacuate people from these regions well ahead of time. If you are aware of some of the news during a 2019 floods, I think, if I'm not wrong, in Kerala, in India, we had already issued some warnings ahead of time, and we noticed that a mountain nearby to this mountain had actually caused there was landslide in that particular mountain. So our system gives early warnings to the rural population, and this is a typical example of the impact that you can make by developing such systems, combining various disciplines, sensors, IoT, communication, networks, machine learning, and finally deploying it. So because of our work, we were awarded the NABARD Award for Rural Innovation 2012. And very recently in 2018 or 19, our Prime Minister, Sri Narendra Modi ji, had mentioned this innovation as one of the top innovations in the Indian Science Congress in Bangalore. So that is the impact that you can make. So with that introduction to machine learning and its application in ecosystem restoration, I will leave you with this small thought. Basically, our university, Amrita Vishwavidyapitham, is highly focused on what we call as compassion-driven research, which is actually a fundamental change in the research perspective. What is the motivation for the research that we are doing? So that motivation comes from our Chancellor Amma, and in her address at the Stanford University during conversation on compassion, I will quote Amma in this one, because it's one of my favorite quotes. Compassion is the most important factor in life. Compassion is the first step to be taken. And if we take that step courageously without fear, then everything else will follow spontaneously. So, because climate change is such a huge issue, and it is going to affect all of us in the future, and it's already affecting us currently. As you can see, the pandemic caused by huge deforestation, huge climate change. So the effect of climate change is already we are under it. So what is the route to escape it, to solve this issue, is ecosystem restoration. And in order to achieve that goal, all of us have to definitely come together and put in all our efforts in terms of research, developing systems, etc. And machine learning is just one small piece of that that we wanted to take a workshop on, so that all of you are getting some at least a basic idea about what machine learning is about, and how can you apply it in different areas. So this is only going to trigger some interest in you, and then we hope that you take this small spark and keep it burning, and then also make sure that you learn machine learning much more than what is covered in the workshop. So with that, I would like to welcome all of you to the machine learning workshop. And this is the plan for today. So initially, we have had this introduction to machine learning. We will go through the rest of the part after a short break of 10 minutes. Now it is 10:35, so we'll break at 10:40. And after that, we will cover these topics. I'll be covering the basics of machine learning so that all of you know. Then we have a session on data analysis and hands-on demo and explanation. So you'll be doing it along with Durga, who will be guiding the lab session. We'll start at 11:40. And then break for lunch. And then we have a very interesting talk on geospatial modeling and ML by Dr. Sushila from IISc Bangalore. And then we'll continue after the talk. And then we'll take up one more small machine learning module. And so by the end of this whole workshop, by around 4:30, we hope that you get an overview of all the machine learning ideas, and at the same time have hands-on experience and develop at least, let's say 10% skill in machine learning, at least in one particular module. So that's the goal of this entire workshop. So with that, we will go for a break for 10 minutes. Now it is 10:30, so we'll 10:40. We'll reconvene at 10:50. Okay, so all of you are free to stay online. Please stay online itself. You can take a break, and then we will join back at 10:40. Thank you all for joining. We'll meet at 10:40. Thank you.
Thank you, Rahul sir. So guys, so before you go for break, I would like to make a small announcement for you. So as Sir Rahul sir explained, like you have seen a lot of real world problems related to ecosystem restoration and multi-hazard resilience, and you may be thinking about a lot of other problems. You all know we are facing a lot of problems, and you will be having some ideas to solve, like how can we solve this problem. You would like to make your own contribution, and you will be thinking, but how can you do it alone? So here we have come up with a wonderful opportunity for you guys. We have arranged a hackathon, and we started the hackathon by this 5th, and this hackathon runs in different phases. So I hope most of you are aware of it. Those who have attended our symposium and yesterday's workshop are aware of this. So for those who are not aware of this, we are just making this announcement. So you can check the details, more details about this hackathon in our web page. We'll be posting appropriate links here. So if you have some idea, the hackathon runs in different ways. So you're welcome to submit your ideas. And if your idea gets selected, you will be you can move to the next phase. But for working in the next phase, you will get a lot of support. We will give you mentors, and we will give you industry experts to guide you for making your solution workable. And we have a lot of exciting prizes also. For winners, you will get cash prize and incubation also. So the first prize is our first prize for this hackathon is 50K in cash, and you will get a incubation worth of 25K from our Amrita TBI. So the first 3 winning teams will get the incubation support and cash prize of 50K, 25K, and 10K. And we have other complementary prizes also. You will get internship opportunities at industry and our Amrita Center for Wireless Networks and Applications. So I encourage all the participants to take part in the hackathon also. So if you are if you feel like you are the only one, you don't have a team member to join you, don't worry. We will support you to connect with the like-minded people. So you can register in our website. So we will give you all the links in the chat. Please do visit the website and do register for the hackathon. Thank you all. I hope you all are staying safe and healthy. Thank you for joining the workshop. Thank you.
Center for Wireless Networks and Applications, a cutting-edge research center at Amrita Vishwa Vidyapeetham, offers MTech and PhD programs. The center has the following state-of-art laboratories for researchers and students. India's first landslide simulation laboratory, and our contributions have resulted in the design, development, and deployment of the world's first wireless sensor network system for landslide monitoring and early warning. This lab serves as a test bed for developing and varying the conditions of the systems that we intend to deploy in the landslide-prone areas. These are the advanced equipments we use for testing soil and rock samples brought from the field. Their geotechnical properties are tested based on international standards. Keysight Technologies, a global leader in electronic measurement equipment and design tools, have collaborated to establish a state-of-the-art advanced wireless communications lab. This is one among the very few such labs found in Indian universities and has equipment valued at several crores of rupees. Smart Grid Lab targets distributed multi-scale smart networks which facilitate the integration of low-cost real-time monitoring and control devices into the grid. The lab serves as a test bed for students and researchers where they can plug in their modules and validate using the real-time data visualization tool. The lab also supports validation of renewable energy systems that are developed for rural electrification projects. This lab provides an experimentation platform for developing low-cost educational technology platforms. This lab hosts a variety of tools, including a host of specialized depth detection, PTZ leap motion devices. A perfect platform for architecting a next-generation classroom system using computer vision algorithms such as gesture detection, participant localization, etc. This lab will provide students practical experience in designing, deploying, and implementing wireless sensor networks in both indoor and outdoor conditions. Remote users will have a permanent test bed for development and testing of concepts. This lab includes 12 experiments demonstrating these concepts by providing study materials, animations, interactive simulations, and a remote panel. Hardware Lab of Amrita WNA serves the students and staff for their research and development. The lab has various types of tools from Weller, Taperia, Fluke, Freeman's, Dremel, Bosch, Mecco, etc. Nearly 50 different tools can be found here. Our MTech programs.
Amrita is now among the top 100 universities in the world and the first in India in the Times Higher Education Impact Rankings 2021. THE Impact Rankings is the only rankings to rate universities around the world on United Nations 17 Sustainable Development Goals. This feat is a testament to our Chancellor Amma's vision and leadership.
100 യൂണിവേഴ്സിറ്റിയുടെയും കണക്കുകൾ നോക്കുന്ന അവരുടെ റിസർച്ചുകൾ, അവർ കൊണ്ടുവന്ന ഫണ്ടുകൾ, അവരുടെ ബുദ്ധിപരമായ കാര്യങ്ങളൊക്കെയാണ്. അപ്പം അങ്ങനെ വെച്ചിട്ടാണ് പ്രൊമോഷൻ വലുപ്പം നീങ്ങുന്നത്. ഒറ്റ ഒരു അപേക്ഷ, ഈ നമ്മൾ കൊണ്ടുവന്ന് നടത്തിയ റിസർച്ചിൽ അല്ലെങ്കിൽ നമ്മൾ ചെയ്തത് സമൂഹത്തിന് എത്ര കണ്ട് ഉപകരിച്ചു, അല്ലെങ്കിൽ എത്ര കണ്ട് നമുക്ക് സഹായിക്കാൻ പറ്റി എന്നുകൂടി ഒരു ഭാവം നമ്മൾ ഉണർത്തിയെടുക്കുകയാണെങ്കിൽ അതൊരു സ്വർണ്ണത്തിന് പരിമണം എന്ന പോലെ ആയിരിക്കും.
Now ranked 5th in the world for quality education. Eighth in the world for gender equality. 37th in the world for good health and well-being. 52nd in the world for clean water and sanitation. Top 200 in the world for industry, innovation and infrastructure. Top 200 in the world for partnerships for the goals. We thank our students, faculty, staff, alumni, and partners who are influencing change both nationally and globally as we build for the future.
Hey guys, are you still searching for the right master's courses? Then stop. Your search ends here. Center for Wireless Network and Application, Amrita Vishwavidyapeetham has opened its admission. You can be eligible for scholarship also. If interested, you can apply using the link in the description box.
Welcome back, all of you. I hope all of you took a short break. Okay. I just got a question: how climate change and ecological restoration correlate with each other? Whether climate change is unidirectional or bidirectional phenomenon, ecological restoration is applicable in all over the biosphere. Thank you, Ajay and KV, for asking that question. I'm basically a machine learning and AI domain person, and I'd be happy to direct this question to some of the domain experts in our team. So probably later after this workshop, we'll be happy to answer that. Anyways, thank you for asking this question. the announcement for rest of all of you who are participating in this. So if you look at it, there is a Q&A option instead of chat option. Please post it in the Q&A option so that we can systematically understand the questions and try to answer them. So thank you all for following that norm. All right, so I hope to start now. Now, in the previous session, we saw various applications, broad applications of machine learning, where it is used, etc. And we also saw some of the major areas in which ML has been used in ecosystem restoration and climate change. So now let us take our first step to understand what is this machine learning. It's like a buzzword for many of you. It's everywhere, and a lot of people are doing a lot of things about it. So this workshop is primarily focused on people who are looking at machine learning for the first time, or probably if you have already taken a course, that's also fine, because we'll be covering machine learning from the perspective of ecology and climate change as application areas. And machine learning can be taught in various different ways. So this is slightly modified approach based on our experience of teaching ML for the past 5-6 years. So let's start the first step on understanding what is this machine learning. Now, the machine learning term by itself was coined way back in 1960s. Before that, Herbert Alexander Simon defined that learning is any process by which a system would improve performance from experience. Now we will take a look at what it actually means. Now he also quoted saying that machine learning is concerned with computer programs that automatically improve their performance through experience. Now let us look at it more formally. A more formal definition was given by Herbert Simon. Now learning is equal to improving with experience at some task. So to give it a more formal idea, let us say I want to improve over a task T, and with respect to a performance measure P based on some experience E. Let us take some very concrete examples. When we were very small babies or kids, we were shown different apples and oranges and told that, okay, this is apple, this is orange, like that. Now these are all the different types of apples. Some of them are from India, some are from US, some are from Latin America, some from Europe, some from Kashmir, some from Assam, some from Gujarat. So all varieties of apples are there. Now there are a lot of oranges also. So when we were small babies and kids, how did we actually learn this? So let us correlate that learning to this particular formal definition. So what do we want to improve? So what is the task that we want to improve upon? We want to identify apples and oranges. So that is the task. And what is the performance measure? So how can we say that, okay, this kid has performed really nicely in this task? So the performance measure is, for example, the percentage of times the kid was able to identify apples from oranges. So when they were given multiple apples and oranges, different varieties, percentage of time that the kid was able to differentiate it or segregate it. And based on experience, what is the experience when we were small kids? How do we practice? The teachers and our parents would again and again ask us the same question and give us slightly different inputs. So for example, one day they will show us an apple from US, or one day they will show us a photo of apple from India, and another kind of apple, Fiji apple, like that. So they will give you different images or actual samples, and then tell us, okay, this is apple, this is orange, like that. So that is the way by which we actually learned. So very similar to that, we can use the same example as an analogy to understand this definition of machine learning. So machine learning is a way to improve over some task T with respect to some performance measure P based on an experience. Let us take one more example. When we grew up a little bit more, when we were, probably when we were 10 years old or 12 years old, etc., our parents would just go out and then get the clothes from outside, and they know that it's going to rain. How do they know it's going to rain? Did they already know it when they were, small kids? No. So when you're just born, you don't actually know whether it's going to rain or it's going to be sunny today. So it's based on experience. So you see that there are clouds. When there are dark clouds, it means it may rain. When it's sunny outside, very less chance of raining. So again, the task here is to say if it's going to rain or not. So there are two decisions, rain or not. And how can we evaluate someone's prediction? Again, percentage of times he was right, percentage of time he was wrong, etc. And this performance can be increased, performance can be improved as you have more and more experience. So that is the idea behind machine learning. You give the machine more and more experience, which is called as data or data sets. As and when you give machine learning more and more data, you are asking the machine to perform the same task again and again, and we also measure its performance. So if the machine is able to improve its performance based on more and more data, that comes under machine learning algorithms. Okay, now when we grew up much more, when we are in our 30s, late 40s, we don't know, or even 20s, late 20s, when we put up a little bit weight, we want to reduce our weight. So the task is to reduce the weight. Now, and how do we measure the output of this task? It is by basically measuring your weight. Now, what all things do you do to reduce your weight? You basically go for exercise, make sure you are eating healthy instead of junk food, and you are having a very good lifestyle, etc. So the task, that the task is to lose weight. And how do you measure that? By, of course, looking at the mirror, and also by measuring your weight. And based on your experience, you can improve on this task. So for example, that if you exercise for half an hour every day and reduce your calorie by 200 reduce your calorie intake by 200, you can reduce the weight by, let's say, 10 kg in the next 4 weeks. So the experience here is that all the experience of a lot of different people who have tried out a lot of different things to lose weight. So that is the experience, the data set of experiences. And then you are using that data set of experiences to improve upon the task. Now, in the past few decades, the drug companies, which is pharmaceutical companies, has been using machine learning to identify what is a good dosage to get a cure. So for example, should you take a 500 mg pill or a 1000 mg pill, etc. So how do you understand which is the best dosage for a given group of patient? So the task there is that the patient is getting cured. The performance measure is, you can measure it, for example, is it a percentage of people who are getting cured versus not getting cured? And what is the experience? You're going to experiment and give different dosages of medicine to different sets of people and see how they are performing. Now, few more examples, let's take. So as to concretize this idea, how we can formally define machine learning in terms of improving our task with respect to P based on experience. If you ask a farmer, when he's going to sow his seeds, not somebody who has learned agriculture in an agriculture university, but who is actually a farmer, he knows that, okay, in this season it's going to rain, or looking at the clouds, he knows when it's going to start raining. And just looking at the climate, he is able to understand that. So the task is to decide when to sow the seeds. And the performance measure is that, was he successful in reaping good crop at the end of 3 months or not? And experience is all the, let's say, 30, 40 years of his own experience and the experience of all his ancestors, through which the knowledge was given to the generations. So based on that experience, he is able to predict what is the right time to sow the seed. Another example is nowadays farmers, using the help of AI, machine learning techniques, are able to forecast the demand for certain food grains ahead of time, so that they know, okay, this season, maybe it's better to sow pulses and not grains. Better it is to sow soybean instead of some other crop. So the forecasting of demand is used to decide what he's going to cultivate in this season. So again, the task is to increase your income. So there the task is not to say if you're successful or not. Let us say you want to increase your income. How do you perform? How do you measure that performance? By measuring the amount of income that you get. So instead of, let's say, in one season one farmer got 3 lakh rupees for a hectare, another farmer got 2 lakh rupees for a hectare. So we know that the first farmer performed better than the second farmer based on the different experiences. Experiences here is climate, demand, etc. In stock market, another example, nowadays, if you look at the mutual funds and all the stock marketing companies, they use machine learning in order to improve their performance. So what is their performance? It is profit, or getting more profit from the stock. So that is the performance measure, and the task is to improve this profit from stock trading. And experience is how did the stock market grow up, down, etc. in the past many years, and when the pandemic was there, how was it doing? And when people stopped shopping, for example, during pandemic, they stopped shopping and conserved money. So how does it affect the stock market? So all these are the experience that stock market analysts and experts use in order to predict their output. Predict the output. Here, output is basically the profit they can get from the stocks. So that gave you a very broad overview of the formal, in informal way, how can we define machine learning? Now, I assume that at least a large majority of you have had experience programming, or building small programs. Let's say with some if-else statements. If input is 1, you print hello. If input is 2, you print bye, and things like that. Small programs. So I have seen all these applications. I just heard about the formal definition of machine learning. But how is machine learning different from programming the computers to do what we tell it to do? Let's take a small example to clarify this point. How is machine learning different from usual computer programs? Now, let us say you want to write a program so that when a person enters, "How are you?" to the computer has to reply back saying, "I am good." Okay. So that's like an if-else statement. If input is "How are you?" you have to print "I am good." Now, somebody may ask the computer, instead of "How are you?" he may just ask, "How's the day?" Like in Texas, howdy. So people can use different kind of ways to ask, "How are you?" "How's the day?" "How are you doing?" like that. But everything means the same. So again, the computer has to say, "I'm good," or a slight modification of that. Another question could be, how's everything? Again, the computer has to say, I'm good, because all the questions mean the same. It means the same. It may be phrased differently. And the reply can be, the reply has to also mean the same. So now the issue here is that the programs would become extremely complex where there are unexpected inputs. So if a programmer were to use if-else statements like this, in order to create a very smart computer program, and it's a very simplistic model, then the programmer will have to type out, let's say, hundreds of different combinations or permutations of such inputs. So programming becomes very complex when there are such unexpected inputs. So it is just easier to let the computer learn how to respond rather than humans specifying it every single time, like this example. And for this, we need large data sets. So in the previous examples, like identifying, just like a kid can differentiate between apples and oranges, can we train computers to do the same, apples and oranges? And can we get the computers to differentiate when it is going to rain and when it is not going to rain? Can we ask the computers to predict what will be my profit if I'm going to sow the seeds now? So all these applications have a lot of data, which is experience. And we can just put the data to the computer and tell the computer, okay, you let the computer learn what is the pattern, and let it build its own response to the inputs. So that takes us to the close of this session on what is machine learning. I hope you understood at least some basics regarding this. And in the next session, I'm going to start covering the fundamentals of machine learning. Is there any questions from your side till now? If you have any questions, please. Okay, I have a question. What is the difference between digital logic and machine learning? So Anish, thank you for asking that question. So digital logic is more or less like what the program that I explained. For example, if I'm assuming it correctly, you are asking about gates, etc. So that will function according to some preset conditions. So it'll only it'll say yes or no, etc., or change the output based on the input. So it's like programming if-else statements. So the programmer has to tell exactly what is expected as input, isn't it? So programmer every time will have to say what is expected as the input, and then the digital gate will give its own output. Digital logic will give its own output. But now in machine learning, it's few layers up, not at the hardware level or even at the firmware level. It's few more levels up where you are training the computers to figure out what is the pattern by itself and not depend upon the programmer. So there is no role for programmer in understanding the data and outputting answers. It is only the computer by itself doing this. I hope I answered your question to some extent, but I'm quite sure it will become clearer when we do the hands-on exercises. So I hope if it's not yet clear, even after the exercises, please feel free to ask me, okay? Okay, so now let us learn more about some of the machine learning basics. In the previous two slides, we saw the applications, the popular applications in ecosystem restoration. And then we learned about what is machine learning, what is the formal definition of that? Improving over a task T with respect to a performance measure P using some experience E. We saw many different life examples. Let's get a little bit more deeper into machine learning basics. So machine learning as a whole, as a topic, is divided into three major areas. Now it's going on evolving, but this is broadly speaking. One is the area of supervised machine learning. The second one is the unsupervised machine learning, and the third is reinforcement learning. These three sections of machine learning are have some very stark differences. Although there are similarities, there is some very stark differences. That's why it's classified into these three. Now let us start to look at one by one. Now let's cover what is a supervised learning. What is called as a supervised learning. The goal of now, you are seeing some mathematical formulations and some graphs. Don't get, I hope you don't get intimidated by such formalism. I hope, I'm quite sure I'm quite confident that you'll be able to understand this once I explain this. And as you move on through this workshop, when you do hands-on coding, you will appreciate this much more. So even if you don't understand this 100%, that's okay. As we go through the workshop, you will definitely have a better hold on top of this. So what is the goal of supervised learning? Okay. So in supervised learning, the goal is to learn a mapping from inputs X to output Y, given a labeled set of input-output pairs, which is represented as D in braces xi, yi, I equal to 1 to n. I'm quite sure most of you don't understand this notation. Let me try to explain this. So here in this graph, I hope all of you are able to see this graph. Give me a few seconds. I just want to take a short break. Okay, sorry for that. So in this graph, on the x-axis is the rainfall, and on the y-axis is the deviation, normalized deviation of the crop production. This is for rice, this is for wheat. So as the total or the average rainfall across India changed from, let's say, 600 millimeters to 1200 millimeters, how did the rice cultivation crop production change as a difference from a baseline? So let's say baseline was, let's say, 35 million metric ton or something like that. And how much variation did it have? So, what this helps is, for the government, it knows that, or for even companies, they know that if the rainfall prediction is, let's say, normal for this year, I can expect the rice production to be this much. So because I can expect the rice production to be this much, I know that the prices will be this much. And because of that, I can plan ahead of time. So if I have this data of rainfall versus production of rice or rainfall versus production of wheat, then I want the machine itself, the computer itself, to learn what is the relationship between rainfall, which is the X. So the input is X here. So rainfall is X with respect to the output Y. Okay. Y is basically the production of rice, or the normalized production of rice. Given a labeled data set of input pairs X, Y. So what is this labeled set x comma y? It is the data of rainfall and the production for all the years. Let's say if I want to predict how is the production going to look like in 2021, I will take all the data from, let's say, 1947 up till 2020. So your input output pair is what is the X for 1983? What is the Y for 1983? Which means what is the rainfall in 1983? What is the crop output in 1983? And so the set of all such inputs across all the years. So here I is equal to 1 to n means it is from 19, let's say 47 till 2020. So all the 70 odd years of data. So where D is the training set and N is the number of training examples. So here we are introduced to two different technical terms. One is the training set. Training set means all the data that the machine learning algorithm is going to use in order to learn. Learn means to identify what is the relationship. We'll get to that a little later. And N is the number of training examples. Training examples, again, it means the entire set of the rainfall and production data across different years. Now, one such supervised learning algorithm is called regression. One such supervised learning algorithm is called regression, another technical term. So in regression, you have, the inputs to a regression algorithm or a machine learning is d-dimensional vectors. D-dimension means it can be 1 dimension, 2 dimension, etc. For example, in our previous example of rain and rainfall and crop production, there was only one input variable, which is rainfall. So it is a 1-dimensional vector. This is also called as feature or attributes. So our rainfall is also called as feature or attribute. Few technical terms. So you'll keep on hearing this as you progress on your machine learning journey. Now, what is the output or the response variable? Those will be real valued numbers. So if the output variables are real valued numbers, it's called as regression or forecasting, are two examples. So in stock market, as the months change or as the GDP changes, GDP is the gross domestic product. So as the growth of the country changes, how does the stock market change? So that is a forecasting. Again, regression problem is the previous slide. This is a regression problem because you're trying to predict real valued numbers here. What is real valued numbers? The production of rice. Okay, and the input is rainfall. So this is also called as an attribute or a feature. This is called output variable, which is the crop production. And since the output is real valued numbers, we call this as a regression problem. Now, in supervised learning, there is another set of problem which is called as classification problem. So that is the inside supervised learning itself, there is regression problem and classification problem. Now in regression problem, if you look at this, if you notice this, it's the same thing. There are some X, there are some Y's, and there is some data D, and we have to learn some mapping between X and Y. Now all of you would be able to understand the example of spam filtering. So in your Gmail accounts or Yahoo accounts or Hotmail accounts, you will have a spam section, right? So how does the machine understand what is spam and what is not spam? You cannot expect a programmer to mark each and every single email as spam or non-spam. That's not possible. You cannot expect the user, for example, me or you, to also mark each email as spam and non-spam, because spammers will find their own ways to improvise and fool the system. That is where the role of machine learning comes, because we have to depend upon the machine itself to understand what is a pattern and then classify emails as spam or non-spam. So let's take this example. So here, the email type is your Y, which is the target variable, what you want to predict. It can be good or spam, okay? And what are the input features? So you go to an email, you find out the number of recipients, number of email attachments, and the country from which the email originated. So for example, so this is a data set, okay? This is called as a data set. Till here it is a data set, the first 4 rows, which means this is experience, we already know. So some programmer, some people have already labeled some emails as spam or good. So based on that, the machine learns, and then it can predict in future whether it's good or bad. So for example, if there is 4 recipients, 2 email attachments, and if the country of origin is Germany, it's good. Similarly, if it's 1 for India, it's good. If 5 to China, it is spam. If it's 2 for Russia, it is spam, etc. So now the machine is given only this data, this input data, along with the label. Now, when a new email comes to the inbox, the machine looks at number of recipients, email attachments, and country of origin, and it tries to predict if it is spam or not. So that is called as a supervised classification problem. Why is it called as supervised? Because you are already giving a data set that has been labeled. Labeled means it is already knowing what is the Y value. So here, good or spam. Similarly, for regression, we took the data from 1980 or 1947 till 2000 to predict the food prices or food production. So I hope the difference between classification and prediction is kind of clear. In classification, there are only very finite set of outputs, which are called as categorical, either spam, non-spam. I'll give you another really interesting example. So for example, when you write digits on the phone, for example, there is a way to write alphabets, digits, etc. It automatically converts the alphabets or digits into proper fonts. So how is it done? It's using machine learning classification. So for example, here if you look, this is a very famous data set containing, I think, 10,000 different handwritten digits from different people. And we train the machine learning to predict if the handwritten digits are 0 to 9, any of those digits. So there are only finite outputs. What are the finite outputs? The digit can only be 0 to 9 and nothing else. So it's a classification problem and not a regression problem. If it's a regression problem, it can take any real value number. Now, let us take this second example. There are machine learning algorithms that can detect animal faces or animals. It can detect a horse from a donkey and a monkey, etc., dog, etc. So again, there is a finite number of possible solutions. So that's why it's called as classification. This example is with respect to fruits. Machine learning algorithms can detect what is apple, differentiate it with orange, etc. And different objects in the house. So pattern recognition or classification are part of supervised learning classification algorithms. So now you learned two different approaches, two different techniques in supervised learning. One is regression, one is classification. So the first one is a regression problem. So what is the basic idea of supervised learning? We use the training data to learn some kind of link, some kind of pattern between the input and the output. So in this MNIST data set, we are giving 10,000 such data points to the machine learning. It is already labeled, okay? So along with the digit, handwritten digit, some user has already told it is 1 or 0 or 9, etc. So that's why it's supervised. And here also, for the machine learning to train, we give a lot of data, let's say 1 million images, and it trains on that data. And when you give a new data, it is able to classify. So use the training data to learn a link between the input and outputs. And the basic assumption is that the training data can be generalized and that the model can be used on new data with some kind of accuracy. So the hope, the expectation of using a supervised learning machine learning model is that you give the machine learning a lot of variety of data so that we can generalize it. What do you mean by generalization? If you give a lot of varieties of different handwritten digits, probably any new data that comes can be mapped to one of these. So the machine would have already seen, let's say, 10,000 different kinds of zeros and ones and nines. So there is very high chance that any new person who writes something and puts it input, that will be they'll be able to learn that. Now, I'm going to mention some of the major supervised learning algorithms that you will start to hear about once you start learning machine learning. Probably you have already heard about this earlier also. So linear and polynomial regression is one such regression machine learning supervised learning algorithm. Another one is called as logistic regression. Another one is called as support vector machines, naive Bayes, neural network. Neural network probably most of you have heard. Neural network and deep neural networks, etc. Deep learning, that all comes as an extension of this. There is something called as gradient boosting and decision trees and random forest, etc. So these are the different types of supervised learning algorithms. Now, for in terms of unsupervised learning algorithms, I'm just going to skim through this because anyways we are not going to use this during the workshop. So in unsupervised learning algorithms, the goal is to find interesting patterns from the data where only inputs are given. So only the X values are given. For example, you are given the sales figure, the number of shirts that were sold corresponding to each size. So there were, let's say, different kinds of sizes, and then those were sold in the market, and you get the data of only the sales data. What is the size of shirt? What is the number of sales? So for example, size on the x-axis and sales on the y-axis. This is the only data you have. Now you use a k-means algorithm, which is one of the unsupervised learning. K-means will tell you that there are three very different clusters. Now, how will it help you as a company making shirts? It'll help you because it'll tell you that, okay, most of the people, the sizes can be clubbed together. For example, let's say this is size 26 to, let's say 28. And all the sizes, the sales are clustering around that, which means I can, club those sizes into, let's say, small. And similarly for large and a few other sizes. So this will help you to understand what is the pattern available in the data set. This is also called as knowledge discovery. And finally, there is something called as reinforcement learning. Again, we are not going to cover this in the workshop. So in the interest of time, I'm just going to skim through it. This is basically useful for learning how to act or behave when given occasional reward or punishment signals. So this is like a it's a machine learning algorithm in which when it makes a mistake, the system basically gives it a punishment. Punishment means punishment can be of different forms. It's not like human punishment, and sometimes it will be rewarded. So reward and punishment both are in terms of what is called as cost. We'll discuss that later in our detailed discussion. So this basically gave you a very broad overview about machine learning, and especially about three classifications: supervised and unsupervised and reinforcement learning. And inside supervised learning, we gave you an overview about inside supervised. We covered two different topics. One is regression, one is classification. And for this workshop, we are going to primarily focus on linear and polynomial regression. So with that, I would like to conclude this session. And in 5 minutes, we'll take a short 5-minute break. I know online learning is not very easy if you're just going to sit in front of the laptop for a long time. So please take a 5-minute break. You can post any Q&A, question answers, questions. If you have any questions, please post it. So we'll try to answer that. So please take a 5-minute break. And after the, by 11:35, we'll come back and discuss more about linear and polynomial regression. Okay, there is a question that what is the difference between AI, machine learning, big data, and data visualization? Are they interrelated? As this seems confusing, and I'm a civil engineering student. Thank you, Ramaswamy, for asking this question. Very relevant question because these terms are, heard every now and then in papers, everywhere it's told. So there are different ways to understand this or explained. AI and machine learning are like AI is the superset and machine learning is the subset of that. Artificial intelligence has a lot more things, and machine learning is just a part of AI. Deep learning is also considered another part of AI, although there is some overlap with machine learning. Now, big data refers to the phenomenon of as more and more sensors, more and more IoT devices came up, a lot of data is being generated. So as and when such huge data, so for example, as of now, it is said that there is more than 1 billion connected devices. Connected devices means IoT devices. So the data that comes from that, for example, wearable devices, the number of steps you took, how many hours you slept. When you drive a car, it automatically sends the information, how much fuel it consumed, how many times you applied the brakes. When you go to a mall, it automatically senses how many people are coming. In an industry, it senses what is the temperature across the different. So it is generating huge data. So that is, as a totality, it is called as big data. Now, data visualization is a method, as the name suggests. How can you visualize data for taking actions on that or to analyze it? We will cover the data analysis part, data visualization and analysis during our machine learning lab. I hope that's clear.
Sir, there are a few more questions.
Yes, I'm going to take those questions also. Vipina Valsan asks, for ecosystem restoration application, which type of ML is commonly used, supervised, unsupervised reinforcement? Actually, I'm aware that all three of them are used. So it depends upon what kind of applications you are looking at. As we have seen, ecosystem restoration, climate change, there are like, hundreds of different types of problems and challenges. Each one of them uses different varieties. Thank you, Vipina Valsan, for asking that question. Ramaswamy, again, with a question, can you share how you started predicting landslides and how many years of data were used? I'll keep it aside because we'll cover the entire machine learning portion and then come to it. Sir, Anish Rajendran, sir, what do you mean by data mining? Yes, so Anish, data mining is to understand data, figure out what are the patterns from that data. So for example, in K-means clustering, we were telling that you have just the data about the sales data of t-shirts and their sizes. So we want to see what is the preference. We want to see what is the, is there a set of consumers who prefer a certain category of shirts? Let's say the sales data is with respect to the cost of the shirt and the number of sales. So we want to identify what are the different clusters so that we can make decision. Should we stop selling this, etc. Data mining in warehouses. How can we, we have the data about how many items are ordered on a particular day across different years. So you want to see when the demand goes up, you want to ensure that enough stock is there in the warehouses. So that is the idea about data mining. Okay, Anish, your next question, I'll take it offline because it's very specific. It may confuse a lot of people, but we'll be happy to answer that offline. Okay, thank you, Anish, for asking that. Because the primary, I'm just clarifying, the primary aim of this ML workshop is to, the audience is having a varied experience, and most of them are new to ML. So I wouldn't want to confuse everybody by discussing various technical terms. But towards the end, we'll be able to answer this, Anish. Thank you for asking. Okay, so we will meet in 3 minutes time. Now it is 11:37, so we'll take a short 3-minute break. All of you, please get up from your systems and take a short walk, because we are going to learn a little bit more about machine learning, what is linear and polynomial regression, and so that'll involve you to have a fresh brain. Please take a short break, and then we'll meet at 11:40 exactly. Question is, would the contents be shared? Yes, definitely. The contents will be shared shortly. We have a website for that. We'll share that after my presentation is done. Welcome back, all of you. Welcome back, all of you. I hope you're able to see my screen. And I hope you took a short break away from the system. Okay, so now we will go through a little bit of theory on linear and polynomial regression. And so the broad flow of the workshop till now has been popular applications, ecosystem restoration applications. What is machine learning? We saw how machine learning can be modeled as improvement over a task T with respect to some performance P, using some experience E. We saw some very basic examples, differentiating between apples, oranges, predicting rainfall, predicting the crop production when you know rainfall, etc. And within machine learning itself, we saw there is something called as supervised learning algorithm, in which you are providing a lot of data with labels. Labels means what is already known. And we tell the machine to understand something from the data so that any new data comes up, you are able to predict what is the output. In terms of supervised learning itself, you saw there are two different things. One is called regression problems. One is called classification problems. And we saw both examples. As the rainfall increases, how is the crop production going to be affected is a regression problem. Classification is email spam classification, whether it's good or bad. How computer identifies digits, handwritten digits. So for this workshop, we want you to develop a taste for machine learning, a hands-on taste for machine learning by actually doing one very simple machine learning model. And so that what we are going to cover is called as linear regression, and an extension of that called as polynomial regression. So that is what our the next session will cover. I will go through the theory part for the next 20 minutes. And then my colleague Durga will help you to do your first machine learning program if you have not already done that before. So that is the plan for the next 1 hour or so, and we'll break for lunch by 1 o'clock. So if you have any questions, please post it in the Q&A. Right after this session on linear polynomial regression, I'll try to answer them, and then we'll start the actual labs. Okay. Thank you for staying with us and keeping your interest in machine learning. Again, don't get disheartened or intimidated by the various graphs, etc. We will explain each of them. We will go through it together. We'll try to understand it, and we'll together learn what's machine learning. Okay. Now, in order to understand linear regression, okay, in order to understand linear regression, let us first take up a problem, an application problem, and then try to use that as our running example throughout this workshop. So now we are into the actual workshop session. Okay. Now, what is the task at hand? Now, all of us have heard that, or probably you may have heard, that CO2 concentration, carbon dioxide concentration in the atmosphere, has a direct relationship with the temperature, with the atmospheric temperature. So this graph shows in the past 8 million years, how CO2 concentration and temperature has changed. Okay, so temperature change from the present. Now, in the past means pre-industrial age, which is before 1900s. The relationship was that the temperature used to increase and the CO2 later increased, and then it automatically, the atmosphere, the environment tried to adjust it through various means, and then it brought down the temperature, and the CO2 also reduced. Now, this is a very well studied topic. So the relationship was that the temperature increased because of various reasons, and the CO2 also increased because of that effect, and then it brought down. So different various glacial ages, 8 million, 6 million years ago, like that, this kept on changing. But now what is happening is that the CO2 concentration is increasing because of industrialization, because of industrial activities, because of pollution. CO2 and various greenhouse gases are increasing. And because of this increase, the temperature is increasing. So the current phenomenon that we are seeing is not what we observed in the past 8 million, 10 million years back. Now, the CO2 is pushing the temperature, and the effect of such a change in CO2 on the temperatures are not observed before. So we do not actually know what is the relationship, what is the effect of that, what is the final impact of that on the environment. So this is broadly the discussion of climate change. Climate change has a lot of different aspects, has a varied set of analysis. It's a very highly discussed topic, research topic. But for the purpose of this particular machine learning workshop, we are going to focus on one very simple task. Okay, so that task is, can we use machine learning to model the trajectory means the path of temperature change with respect to CO2 concentrations in the post-industrial world. So we are only looking at the data after 1980s or after 1960s. Can we try to model the change, the relationship between CO2 concentration and temperature? Can we try to model means we are trying to figure out what is the relationship. Okay, so this is a graph that shows carbon dioxide concentration in parts per million volume, and the temperature change, the change in temperature with respect to 1960 temperatures. So there was a baseline temperature, which is the 1960-70 temperature. And after that, how has the temperature changed when the CO2 concentration has changed? Now, some of you asked the question, are we going to share this material? Yes, definitely. The PPTs section-wise is already posted in the website. We'll share the link to the website very soon. And the videos also, recorded videos, will be posted later for your reference. Now, this is the task that we are going to solve, that we are going to use for this machine learning workshop. So I hope you appreciate, you understand the problem that we are going to take up as part of this workshop. Now, how do we find a relationship between the x-axis variable, which is the CO2 concentration, and the y-axis variable, which is the temperature change? Now, the x-axis variable is independent, is called as an independent variable here, because the y basically depends upon the CO2 concentration. Y is the temperature. Now, how can we model this? Now, modeling means we are going to approximate it. As you see, there are a lot of data points, right? So, for example, these data points come from 1980 to 2008. This is the entire data set. Now, this is every year there are 12 measurements. There are 12 measurements. So that is why there are so many points. So every month they measure the CO2 concentration and the temperature. So that is why each star, each black dot, for example, let's take this black dot here. This means that when the CO2 concentration was 360 ppm, the temperature change in that month was 0.4 degrees Celsius with respect to the baseline. Now you see that there is a lot of spread of this data. We get a lot of data, but how can we approximate it? So approximation means there is a model. Okay. Now, what is a very simplistic model? Simplistic model is a line. Line means we can express that model as an equation. Y is equal to mx plus c. So every y has some relationship with x. So the line is y is equal to 0 into x plus 0, which means y is always going to remain 0. So that's the equation of a line. So can this line be an approximate measure or approximate model that can represent this particular set of data? Doesn't look like, but let's try one more line. We push the line a little bit up, which means we added a term m as 0.002 into x plus 0. So the last variable c, which is called as y-intercept, I'm keeping it as 0 to make discussion easier. I'm just trying another line. Can this line represent this entire data? Well, it doesn't look pretty good. Now we can draw many lines like that by changing the m value. M is the slope value of a line, by changing different m values, 0.02, 0.01, 0.005, etc. So we are basically pushing this line up and down like this, So we can try out various lines. How many lines can you try on this data? Infinite numbers, because there are infinite number of real valued numbers between this. Now, the one way is to you try different lines and see which is fitting. So probably this violet line is fitting this, or this blue line is fitting this data very nicely. Fitting means it is able to represent this entire data, which means you take any point here, 360, and then you see the point in the line, the purple line here. What is the corresponding temperature? Temperature change 0.018 probably. So it means that if instead of this entire black dots, I'm going to represent this entire black dots using just this purple line, then for every CO2 concentration, I am able to figure out what is the corresponding temperature change. Now it looks like a good model here, good approximation. But how do we decide which is the best line? So there are 4 lines here, right? Now, how do we decide which is the best line out of this? For that, we will have to compute the error. So what do you mean by an error? An error is also called as a cost function. So these are all new technical terms. I know some of you would find it very difficult because there's a lot of information overload probably. But you can refer to this material later on. But you can also, we'll try to describe what is a cost function also. So even if you are bombarded with different technical terms, you need not worry about it. You need not understand it fully here. We will explain. You try to understand it. If you're not able to understand, you can go back to this material again and figure out. Now we will give you an intuitive idea about what is a cost. Okay. Now here we will define a cost function, or what is called as an error. And the cost will be difference between the actuals and the predicted, which means y value and the predicted y value. What do you mean by this? We'll see that in the next slide. I am selecting only very few black dots from this because just to make our discussion very clear. Now let us assume our model is this particular line, this orange line. Okay, y is equal to mx plus c. One of those lines are here. Now, what do we mean by cost? Cost is the difference between the y values and the predicted y values, okay? Now, what is the y value here? Let us take an example. Let us say when the concentration of CO2 is 370, we observed in the year 1995 that the temperature change was 0.3, approximately 0.3 degrees Celsius. However, our model, which is this line, if we are depending upon this model, it will predict that if the CO2 concentration is 370, it will predict that the change in temperature is approximately 0.01 or something like that, or less than that. Okay, so there is a difference between what is predicted by the model and what is actual. The black is actual, the red is the predicted. So that is called as the error or the cost. Now, we can compute such cost for all the data points in this training set, what is called as a training set. So we take the data from 1980 to 2008, and we assume that y equal to mx plus c is the model, which is this orange line is the model. And then we compute the errors across all these data points. Now, if you sum up all the errors, okay, if you just sum up all the errors, you will get a cost function or a cost of this line. Now, since the difference or the error could be negative numbers also. So here we see that there is a negative number here. So instead of taking actual errors, we take the squared errors. So it's called as a squared error function or a squared cost function. So that's why this 0.1 squared, so that everything is in squared terms. You can also take absolute values also, that's also another option. Now, how do we decide which is the best line that can properly capture the relationship between x and y variables? So we draw many of these lines and then compute cost for all of these lines. Okay, so let's say there are 4 lines. So we'll compute the total cost for all the 4 lines. And we will try to select the particular line, that particular line, which will minimize this cost. That is very logical. You have a lot of lines, you have a lot of cost for each of those lines. So for example, for this orange line, let us say my total cost was 1 lakh. But for this purple line, it is more or less fitting the entire data. So cost was, let's say, 1000. Cost means error in this case, okay? Error and cost are same in our discussion. So the goal of machine learning algorithm is to minimize this cost. So how do we do this? So this is my last slide on, last but one slide on this topic. So you have a lot of data, okay? You can follow my discussion, need not be distracted by these graphics here. We'll discuss that. So you have a lot of data, which are black dots. And now you're trying to fit it with different lines, orange, purple, etc. How do we find out which is the best line? We figure out what is the cost or the error. Okay, we sum up all the errors. And the goal of machine learning is to minimize the above cost. Okay, so now how do you minimize this above cost? Is by trying out different lines, okay, different lines and figuring out what is the cost. How do we try out different lines? The line equation is y is equal to mx plus c. So that variables that you can actually have control is, you actually have control over is m and c, right? M is the slope, c is the intercept. Now I want you to look at this particular graphic on your left hand side. Just focus on this one. Here, the dots are all the data points. The blue line is actually changing. If you see, it is changing from some intercept to the other intercept. Now, how does it change? You just change different m and c values. So different slopes means the slopes are changing if you change the m value, and different y intercept, which means here we had only 0 intercept. Every line was going through 0. But here it's not like that. Some of the lines are going to 0.2. Now you change this line by changing the slope. So now every time you change the slope, every time you take a step, you compute the cost. Okay. Now I want you to take a look at this graphics here. I hope you're able to see the second one, the second GIF. I want you to look at this red slope and nothing else. Okay, don't be distracted about the line. So this red slope and the black dots here are basically the total cost. You see here the cost. The y-axis is the cost. Okay. Now what it does is, as the line takes one step, okay, you fix the line at the first point, and what is the cost? Now machine learning algorithm, what it does is it tries to reduce the cost. How does it try to reduce the cost? It'll try to change the line a little bit. It'll try to change the line a little bit, change the M a little bit, so that, and it will again compute the cost. Now it found out that when it tried to slightly change the line, the cost suddenly decreased. Here it became this point, this black dot, the second black dot. And then now the machine learning knows that, okay, if I modified, now see, initially let us assume that M value was 0.1. Now I changed it to 0.2. So now when I changed it, suddenly the cost reduced. Now the machine learning knows that, okay, if I'm going to reduce M further, it may reduce, the cost may reduce. So again, it tries to reduce and reduce and reduce and change the M value such that the cost is minimum. Cost may not be 0, but cost is the minimum. How does it know it is minimum? It'll try out changing M value and C values little bit up and down, etc. and see what is the effect of cost. If the cost is increasing, then it'll come back. If the cost is decreasing, it will go in the same direction. So here, this procedure of minimizing the cost of a machine learning algorithm, of machine learning model, is achieved using various algorithms. One of them is called as gradient descent. We won't go into details of that. It's out of scope for this workshop. So I hope you got an overview of what is happening in linear regression. You have a lot of data. You assume that okay, so you assume that a line may be able to represent this entire data. It is still an approximation. So machine learning is basically an approximation of the entire data. How do you decide which is the best line? You figure out the cost, which is nothing but the error between what is on the line and what is actual. And then how do you reduce the cost? You use some function called as gradient descent to reduce the function. But we won't be, in this workshop, we are not bothered about how to minimize the cost, etc. But this is the entire picture of linear regression and machine learning, how to use machine learning using linear regression. So I hope all of you understood this part of machine learning. And now, instead of fitting a line, we can fit a curve. For example, we can fit a second order equation. For example, instead of saying y equal mx plus c, I can have y equal to a1x square plus a2x minus 1, something like that. Now, this equation represents a particular curve. So as you can appreciate from this graph, instead of a line, a curve is much more better to represent this particular data. The errors will be much more less. Errors will be much more less. So that is where the role of polynomial regression comes. So polynomial regression assumes there is a nonlinear relationship between x and y. So now till now we discussed about what is linear regression, how to model that, what is cost function, what are the different, what is the intuition behind changing the slope of line to reduce the cost? How do we select the best line by identifying what is the least cost, etc. So I hope you are able to appreciate what we discussed till now. I hope you're able to understand at least to some extent what we discussed. In the next session, Durga will be taking the lab and helping you, guiding you, hand-holding you to actually implement some of these algorithms and data analysis. Okay. So before I wrap up, I would take up some of the questions posted. Was the Selsha, sorry, I hope I pronounced your name properly, asked this question. Was there an error for the formula with the purple line? Was there too many zeros? Should it have been 0.0.05? Selsha, in the purple line that we showed in the graph, was there an error for the formula? Yes. What you told is what we discussed is a representative thing. I'm not, we are not interested in finding out what is the exact equation and what the exact line looks like. These are representative things. So it could have, the actual value in the equation could be different. Okay. What you told is right. Yeah. Pooja Soni asked, this is a curve fitting problem only, right? Yes, Pooja Soni, we are applying machine learning for this particular workshop. We are using this data set to demonstrate the use of linear and polynomial regression using a single variable. Okay, so we don't want you to get confused with a lot of different things. So we are using only a single variable, that is CO2 and its effect on temperature. But during the lab, you will see that we'll be used. There is application of various different parameters, various different features, not just CO2, CH2, CH4, CFCs, etc. So the problem of predicting temperature using carbon dioxide is a very simplistic problem. We are using that as a representational set in order to demonstrate a lot of different machine learning techniques, to introduce you to Python, scikit-learn, machine learning algorithms, train test splitting, various different ideas with respect to machine learning. So this is just a representative data set. But towards the end of the workshop, you will also be given some exercises where you'll be exploring much more than just a curve fitting or a linear fit on this. Yeah, thank you for that. Anish Rajendran, similar question, is this technique similar to curve fitting? Yes, I answered that question. Selsha, is there a value for the cost which can inform that a line graph is not suitable? Selsha, your question is very significant. We are not going to look at absolute values of the cost, whether it is suitable or not. That the machine learning algorithm can do it. It'll figure out what is the optimum value. So machine learning here, machine learning algorithm tries to optimize or minimize the cost. So that is the goal of machine learning algorithm. So we need not worry about what is the absolute value of cost. Is it suitable or not? That the machine learning will give that output to us. Danesh Raj asks, can you explain on square for the cost function and p parameter in the graph once more? In the cost function, we are using squared error because for multiple reasons. But the most simplistic reason is that when you add up all the errors, if there are negative errors, that will reduce the error, right? So for example, let's say one error was -100 and one was +100. If you add it up, the total error is 0 error, but that's not the case. So that's why we are squaring the errors. That is one reason. There is few more reasons for, in terms of machine learning and optimization algorithms, there are reasons we are using squared errors. Again, it's out of scope for this particular workshop. So I'm not, I can take it offline, Danesh. The P parameter in the graph, or that the graph, the final graph that I showed you here, the parameter P here is basically corresponds to M, the slope M. Thank you for pointing out that, Danish. Here the parameter P is M. So as you change the M, the cost also changes. So the red curve is basically parameter M. It should not be P, it should be M. I used an online graphic, that's why that came out like that. So as you change the parameter M, which is the slope of the line, how does the cost change? So if you change the parameter M, the slope M means you're changing the line. And as you change the line, what is the cost? Thank you, Danish, for pointing on that. A question from Anish. What is the term used to define squared sum of costs? What term did I use to define the squared sum? I don't remember if I used any technical terms other than errors and okay, I used a term called as mean squared error, or mean absolute error. Both of them can be used. You'll be using it during your lab actually. Yeah, so I think it's mean squared error and mean absolute error. You'll be using both of them during the lab. Okay, thank you for those questions. I hope you're all eagerly waiting to start the lab. So I hand over the session to Durga for the next session. Okay, thank you all. Thank you for being part of this. I really hope you have very good experience, and we will shortly share the website address right after this. Okay, thank you all. So I hand over the session to Durga. Durga, over to you.
Thank you, Rahul sir. Am I audible? Am I audible?
I think your voice is getting
Okay.
cut, so probably you can switch off the video if that helps.
Yes.
Yeah.
Okay, I hope this is better. Okay. So thank you, Namsha. Good morning to all. Welcome to the workshop again. So, before starting, so far we have seen what linear regression is, the theory part, the basic concepts are in machine learning, right? So now we'll just start with the coding of these parts. We'll just code the basics of machine learning and just form a full pipeline of how you will input the data, how the machine learns on the data, and how can you view the output. Okay. So first of all, before starting to code, let's just understand what our data set is about, how does it appear. Okay, let me just share my screen. So I hope this is visible. Okay. So here you can, this is the data set that we have. So this is actually a data set provided by MIT.
Durga,
so, yeah.
Durga, sorry for interrupting. Can you zoom it a little bit?
Okay. Is this better?
I don't see it as zoomed in. Yeah, it's better. It's better now.
Yeah. Okay. So this is the data set that we are going to work with, and here we can see that there are many rows and there are many columns. So we'll go through each one. So there is a total of 309 rows, including the header. There are 309 rows. That is a samples. There are 308 samples without the header, and you can also see the columns that specify each parameters. Okay. So here you can see that there is a year given and a month given. So this data set is of from the year 1983 to 2008. And starting from 1983, in the month of May, it considers every month, and it gives you the corresponding temperature and all the other parameters of that specific month in that specific year. Okay. So here you can see that there are parameters such as CO2, carbon dioxide, nitrous oxide, methane, CFC11, CFC12, TSI, which is total sun irradiance, solar irradiance. That is the rate of sun's energy deposited per unit area. Then there is aerosols, which affect on how much energy is reflected back into the space. So there are many parameters that you can see, which can contribute to the global temperature. So the temperature that you see over here is as it was explained before, this temperature is the global temperature difference with respect to the baseline. So this is the difference of the global temperature with respect to a baseline. Okay, so that's why it is in such small units. So what our problem is whether we can estimate the temperature value with respect to the other features or factors such as CO2, CH4, other atmospheric gas. Okay, so that's our problem. Can we estimate the temperature based on the other features? So here, what we call this temperature is, it is called a label. It's called a label, or it's called a target, or it's called an output variable. So this temperature becomes the output variable. Okay, and all the other columns are called features. So this is the terminologies that we use in machine learning. Okay, I hope that's clear so far. So here we have data of 308 rows and 10 columns. Okay. Okay, so now after understanding the data set, let's start with our demo coding part. So how we'll do this is, let me just share my screen, reshare it. Okay, so how we'll do this is, I will demo you the code in short sections. So I'll just do one part at a time. And then after that, I'll give you some time, 5 or 10 minutes for you to catch up with the coding. So you can, while demoing, you can concentrate on this. We'll give you time to work it on yourself and come up with the outputs. Okay, we'll provide you with the code. You can just copy paste each of the code and run it for yourself and see the output. Okay, so that's how we'll work. We'll get to that later when we give you time to actually work it out. First, we'll start with the demo. Okay, so first of all, we are using Collab to do our Python programming for machine learning. So when you start a new page in Collab, it will look something like
Durga,
yes.
Just one moment. Just
Yes.
to, I think many of them may be using Google Collab for the first time.
Yes.
In
So
case there is anybody, can you go to the
Yes.
Google Drive and show how to open a Google Collab file?
Yeah, sure. Okay. So
Or they can type collab.google.com, right?
yes, you can do that.
Collab.research.google.com.
Yeah. So if you go, just go to Google and just type Google Collaboratory, Lab or Collaborate, and you will get the first link from the Google. Welcome to Collaboratory. Just click on that. So if you go to that, you will see such a window. In there, in the last, you can see a new notebook in blue, a new notebook. So you can click on that, a new notebook, and you will be presented with a blank Collab file. I hope that's clear. So this Collab file, you can actually see this Collab file. Whatever you're doing in this Collab file, you'll be able to find this in your Google Drive. Okay, Google Drive related to your Google account. You can go there and see a new Collab folder would be there by now when you start a new collaboratory file, and you can access it, access whatever you have done through your Drive. Okay. Okay.
Durga,
So
I suggest that let them all start their own Google Collab files right now.
Sure.
In case, and then
Sure.
take it.
Okay.
So,
So
we'll give 2 minutes for all of you to create your own Google Collab files. And
please go to Google and just type out Google Collaboratory. and you can get the link directly from that. Please raise your hands within this Zoom itself. There would be an option to raise hand. Please do that and let us know if you are all able to do that. When most of you are done, we'll move on.
Yeah, we have posted the link to the Google Collab, collab.research.google.com. You can just copy paste that link in your browser and you should be taken to that web page.
Please put your questions if you have any in the Q&A window. Our team will be there to help you. If you have other doubts, you can also ask here. Okay, I can see 3 of hands raised. So are the others having any problem? Could you please raise your hand if you're done? Okay. So I can see many others done. So if you have any doubt, please ask in the Q&A. We'll just continue from here. Okay. So this is the window that you'll get when you pull up a new Google Collab file. So in this, what you see here is a block of code where you can print something. Like, let's say I'm going to print a message, welcome. So once you write your code, your piece of code over here, you can see a run button on the side of the block. You can just click on that. And you'll see your output in the console here, just below that. Okay, so I hope that's clear on how to open a Collab file and how to where to write a code and how to run it. Okay, so I'll just continue with the demo. Okay, so here what we have, so within our problem, what we have is we have a data set and we are going to code something where you are going to access that data set. So before the code can access the data set, it should be uploaded into the Google Colab file. And I am just going to show you how to upload that file into the Google Colab. So in here, in the left hand side of the screen, you can see some options, and there is an option called file, the fourth option. And there you can see an icon for upload. Okay, so here you can see an option for upload, and there just click on that upload. And once you have downloaded the data set from the link that's given to you, not now, when you're doing, once you have downloaded the data set, you can just click on the folder and select your data set and upload it into Google Collaboratory. Okay, so in the files, you go to the upload button and then upload your data set. Once it is completed, you can see the file appearing in your window. Okay. Okay, so that's what we do as the first step. We just upload whatever data set we are going to work with. Okay. Now let's go into the coding part. So it might
Durga,
be
just
yeah.
sorry to interrupt.
Yeah.
This step on data upload is just for demo, and then we will share the link of the data set and the website once she completes some part of this. Okay. And you will be given the same code also. So do not worry about that. Once she explains the first part, then all of you can do it yourself. And the dataset will also be shared. Yeah.
Yes, thank you. So just as he told, just go, let's just go together with the demo, and then we'll give you time later to do that. Okay. So as a first part, what you'll do is, so for any, if you have used any of the programming languages, you'll be familiar with libraries, right? So to access any predefined functions, you use some kind of libraries. And here we are just as a basic to start with, to begin with, we are using 3 libraries here. One is NumPy and another is Pandas. So both of these libraries, NumPy and Pandas, are used for data manipulations. Okay, so to work with data, that is regarding to the machine learning, to work with data, you use these 2 libraries for data manipulation, that is NumPy and Pandas. Okay, while you import, you use the call import, and then the name of the library that you want to import, NumPy. And by defining it as NP, you use wherever you want to call something from the library NumPy, you just substitute it with the NP. You'll see that in the when you do that. Okay, so here NumPy is imported as NP, then you import Pandas as PD, and then there is another library that's been imported, that is matplotlib.pyplot. So what this is used for is to make any plots, to draw any graphs, we'll use this library matplotlib. Okay, so these are the 3 libraries that we require for the first step. Okay, so after that, let's go into the so we have the data set uploaded. Now how does the file, how does the code access the file is the next step. So to load the file, what you do is you use Pandas library. So this is PD, that's Pandas library, and access the function called read_csv. So using this read_csv, we are able to access a file into the code. Okay, so you use pd.read_csv, and then you specify the path where the data set is located. Okay, so how you get this path is, you can see after the data set is uploaded, you can see a more option, 3 dots here. Just click on that, and you will find a copy path option. So in the data set, you click on the more options, the 3 dots on the right side, and you can see a copy path option. So just click on that copy path, and if you paste that somewhere, that path will be pasted there. Okay, so we access a folder. Sorry, we access a file using pd.read_csv and specifying the file that we want to locate. Okay. Okay, so we are reading the CSV file into the variable name dataset. Okay, so to make sure that the dataset is properly accessed, properly imported, we'll just print out the information of the dataset to make sure that the dataset is properly uploaded. Okay, so if we use the function dataset.info, so the function name is info. So this gives the information about the dataset. Okay, so if you print this, you will get this output. So what does this output say? So it says that it is of a pandas data frame, and it says that there is a range of 308 entries. That is, there are, so we saw the dataset earlier, and we saw that there are a total of 308 rows without the headers. So this is actually accessed with the indices. So Python is a zero indexed programming. That means whenever you start something, you start with the index of 0. So this 308 entries is indexed from 0 to 307. And now about the column, regarding the column, they give the information of what are the column names here. So they say that the first column is of year with the index 0. The second column is of month with the index 1. and so on and so forth till temperature, the 9th column, which is actually the 10th number. So 9th index is of the temperature. So we can see that the data set is loaded properly. We can also see that there are 308 rows for each of these columns. We can see that the data type is both integer data type is there, and as well as a floating point is there. So, and in the next sentence, they are also giving us the memory usage belonging to that of how much memory is consumed by just uploading that data set and other information. So this is the information that you get when you call dataset.info. Okay. Now, after just getting the information about the dataset, now we will just print the dataset. So we write the code print dataset. So when you do this, the dataset, a curated form, just a representation of that dataset is given here. So you can see that columns from year to the column temperature is given, and also the column from 0 to the total column of 308 is given. Okay. So from this, by doing this, we are sure that the data set is uploaded and everything is well, and we can move on. Okay. So that's about uploading the data set, loading the file. Okay. So now, what was the question that we are trying to solve? So we are trying to solve whether the temperature can be estimated using any of the parameters, any of the atmospheric gas or other parameters that is given in the data set, right? So this temperature, once again, this temperature becomes our output variable or label. Okay. So we are just going to keep aside this temperature, the output variable. We are just going to keep aside the temperature variable. Okay. So that's what we do in the next step. So we are assigning a variable named y, and we are assigning that temperature parameter from the data set into the variable y. Okay. So data set within square brackets, when you give the column name, that array or that parameter, all the rows of that parameter is going to be given to the variable y. Okay. So that is about y. So we have now got the we have now separated the output class or output variable from the data into y. Okay. Now we are just going to take the rest of the data from the data set and keep it into another variable called x. So we are just taking all the variable that will affect the temperature or affect the variable y into x. Okay. So here in the x, we take the data set, and here you can see that there is a function called drop. So what it does is, we are using drop, we can just avoid copying the specified columns into the variable x. So from dataset, when you're copying the variables from dataset to x, we are going to avoid copying the specified columns. So here, year, month. So you can say that, see here that year and month is not going to have any correlation with temperature, right? So in a specific year, you may have a temperature rise or temperature going down, but it's not actually affecting how a temperature is going to vary. It's other factors that's going to affect it. So we do not need a year and month to predict value of temperature. So for that, because of that, we are going to avoid year, month, and temperature, because that's output variable. We need not put it as input. It's output variable. So you are going to drop year, month, and temperature. Okay. And this axis equal to 1 means you are going to this name can be found in the column, in the axis of column, not in the row wise axis. It can be accessed in the column wise axis. That's what axis equal to 1 means. Okay. So I hope till now it's clear. So after we put x and y, we create the variables x and y. We are just going to print it out again to make sure our code is good, well and good. So we are going to print x, and you can see that here CO2 to aerosols are being printed. So the year, month, and temperature has been dropped, and only all the other variables are copied into x. And you can see that so x dot shape, what this shape is, the shape specify the size of x, what is the row and what is the column for the variable. So here you can see that x dot shape is going to give you 308 rows and 7 columns. So we are dropping the 3 columns from the entire data set. So we get the 7 columns in x and then 308 rows. So that's what dot shape gives us. Okay. So we have x and we saw what is the shape of x. And similarly, we are also going to print y and see if it is just the temperature, and you can see it is, and then y shape. Again, there are only 308 rows and just 1 column. Okay. So this is how we separated out the data into x and y, that is input variables and the output variable. Okay. Now, after seeing the input and output variables, now what do we want to do? So we have a data set. There are some numbers. So if you see the just see the features here, you can see that there are many numbers and there is a temperature that is related to it. But you cannot just by seeing, you're not able to understand how the CO2 is related to temperature, right? Or how CH4 is related to temperature. What you're able to see is just random numbers. This is 308. This is just 308 rows. Just think about if this is 1,000 or 2,000 rows of data. So to do that, we need something to visualize this, to understand how the parameter is going to affect, or how the parameters is working, how the relationship is of the parameter, the input parameter to the, or input feature to the output variable or the label. Okay. So for that, what we'll do is we'll plot the we'll take each feature and plot it to all other features. So first we'll take CO2 and then we'll plot it in relationship with CH4, then in relationship with CFC12, CFC11, TSI, aerosol, temperature, every other feature within that data set. Okay. Similarly, we'll do it with CH4. Similarly, we'll do with N2O, everything that's present in the data set, so that we can visualize how the data is related to one another. Okay. So that's what we are going to do with this command, with this next bit of code. So to do this, we need another library called Seaborn. Seaborn is a library that we use to plot this. And here you can see we are using Seaborn as SNS. So SNS dot pair plot. Pair plot is a function used to plot each pairwise relationship in a data set. If you just keep that cursor above the function, you will be able to see the description of the function here. So that will help you to understand what the function is. So if you just keep your cursor above the pair plot, you can see that what it does, it plot pairwise relationship in a data set. Okay. So here we'll plot this. And what is this this dataset.ilog over here? So here what we are doing is we are just taking the data starting from, so this column in the first says about the rows. So we saw that in shape or defining everything, we first define the rows and then define the column, right? So first when we define the row, you can see there is a column there. So what this column implies is we take every row given in the data set. So we are going to take every row given in the data set. And the second part says about the column. So what does it say? We are going to take from 2 till again another column, 2 till another column. That is 2 from 2, starting from 2, we will take every column. Okay. So what is this 2? So it is, again, remember that it is the index. It's not the number of the number on which you see the column. It's the index that you have to give. So what was the index 2? So the index 2 was corresponding to CO2. So we take from 2 till, then we see again a column. That means from 2, we will take the entire columns that is given. Okay. So that is what is meant by this command. I hope that is clear. So once that is given, you can see a pairwise plot. So let's see what the x-axis and y-axis of this plot is. Okay. So here, let me go down. Okay. So here, in the x-axis, you can see there is CO2, CH4, N2O, CFC11, CFC12, TSI, aerosol, and temperature, right? In the y-axis also, every of this, each and every one of these features is listed. So what happens here is, let's consider this graph. We are taking the temperature and plotting it against the value, we are taking CO2 and plotting it against the value of temperature. Okay, so we are taking each and every one of this column and plotting it with the rest of it. So CO2 is plotted against temperature, CH4 is plotted against temperature, N2O is plotted against temperature. Similarly, CO2 is plotted against aerosol. In the second last graph, CO2 is plotted against aerosol. Similarly, in each and every plot. So there you might see a histogram plot, right? You can see a histogram plot. So this is actually in the place where CO2 is plotted against CO2. So the first one is CO2, right? So when CO2 is plotted against CO2, you will see a bar graph. Whenever you have these diagonal elements, one plotted with itself, we are actually plotting a univariate graph, distribution graph. And what it says is how much it says about the distribution of the data, about its location, how much spread there is. So it's about that data. For now, we are not bothering much into that. We are just going to see a plot between two parameters. Okay. So here we can see that. Now let's just see what this graph is showing us. So there are a bunch of graphs. So what does it show? So in the CO2 versus temperature graph, you can see that most of the points show a linear trend, right? There is kind of a line that can be drawn till a point. Till some point, we are able to get a linear, kind of a linear trend. And after that, there is a slight downward slope. But majorly, it's a linear graph. Similarly, CH4, N2O, everything kind of shows a linear pattern. And there are also some other instances like CFC12 or TSI or aerosol, where this relationship might not be linear. It should be a non. I think we understand it to be a non-linear relation. Okay. So with this, we are able to see whether. So why we use this graph is, we are trying to understand when you get a new data set, you are going to try and understand how the data is related to one another, and whether there is a really identifiable graph or plot or a trend that you can get by plotting the features against one another. Okay, that's what we are aiming to do with this. So this is also a step in data analysis to understand how the data is related to one another. Okay. So now what we'll do is, till now, we'll just stop with this, and let's just, I'll give you time to run this problem on your own. Okay, so I think the data set is already shared.
Yeah, just now
Right? Yeah.
I posted it in the chat.
Okay.
Please visit that website. Durga, you may show that website also. It's
Yes.
open in your tab.
Yes. So let me just pull it up. Okay.
Yeah.
Yeah. Please continue.
Yeah. So this website has the has the presentations, but that you can refer to it later. Can you scroll down a little bit more? And the next one is a data set. So if you click on that data set, it'll open on the right hand side top corner. It'll open the data set for you, and then you can download it and then use it in Google Collab. If you scroll down a little bit more, you will see the part 1 data analysis code. Okay. So that's the entire Google Collaboratory IPython notebook. You click on that, you can download the IPython notebook, and then you can upload it into your drive and then use it. So this will have only the first part, whatever we had discussed till now. Okay. So what we can quickly do is, it's only 12:45. So we have 15 more minutes, and maybe it's a good idea, all of you please visit this site, download the data set and download the code. Please upload that code into your Google Drive, try to run it after uploading the data set, and hopefully before you break for lunch, you will all see that data analysis graph. So could you all do that now?
Just one more point I wanted to add. When you are downloading this data set, please, when you click on this, it will be a CSV file. Please make sure it's downloaded as CSV itself. Otherwise, you might see some error when you are trying to run the code that is given to you. This is already in CSV. Don't make any changes and download as it is.
Yeah, Durga, can you again pop out that data set? Yeah. So if you see that, there is an option to click on open with. Please don't do that. Please go to that 3 dots on the right hand side and click on download. Okay. So that will ensure that you are downloading it as CSV file only and not as an Excel file or things like that. Please go to the right hand side 3 dots and then click on download. Yeah.
Okay, so please visit the site and make yourself comfortable with the, just download the data set, go to that part 1 and try to run that. If you have any questions, please put that on Q&A.
Durga, there is a question asking to show the uploading of data again. Can you show that?
Yes, just one minute. Let me just share my screen. Okay, so those who have trouble with uploading the data set, after you have downloaded it into your local file, local folder, click on here. You can see a few icons on the left side, and there in the bottom corner, there is in the fourth, there is something called file. Click on that file, and there you can see something called upload to session storage. There is a top arrow icon there. So just click on that, upload, and then choose the file that you have, wherever you have saved. Go there and choose a file and open it. And within 1 or 2 seconds, it should be uploaded. If you have confusion into how to load the file, how to get this path, you can go, once you have uploaded the file, you can see 3 dots over there, a more option there. Click on that, and you can copy path. Here there is an option to copy path. Please click on that. And after you click it, just paste it over here, and that's how you get the path to that file location. I hope that's clear. So please, after you have completed till whatever we have discussed, once that is completed, please raise your hand so that we'll get to know if there is if you are getting stuck at some place. Please ask through Q&A, or you can ask online. And please raise your hands once you are done till that point. Okay.
Hello all. I'll also try to follow the steps that Durga told for demonstration, in case if you're having doubts. Let me share my screen. I hope my screen is visible to all of you. So what I'm going to do is I go to the website and then scroll down to the dataset part, and then click on this icon to pop out the dataset. And I'm working in incognito, so I'm not yet logged in. So just to make sure, just to replicate what you'll be seeing. So you can click on this download here. For some of you, it may come here. Some of you, it may be in these 3 dots. It differs, depending upon whether you're logged in or not. So I download this climate_change file. So I can close this. Then in the website, I have one more thing, part 1 data analysis. I open it in a new window. So that takes me to the Google Collaboratory website. Just loading. So, I see this entire code block here itself with the outputs and everything. Now I just need to click on file and say download, and say download IPYNB, so that I can download this entire code to my local machine. Okay, so that is one way to do it. Otherwise, you can create your own collaboratory file as Durga mentioned, and then copy paste each of these code blocks. For example, you take this code block and then copy it and then paste it in a new collaboratory file. That's also fine. But you can also download this IPYNB file. That's downloaded as a local file here. Now I go to my Google Drive. This is my Google Drive. Let's say I have a folder called as temp. I'm just demonstrating it for the purpose of those who are finding it difficult to do this. So I have a folder called as temp here, and then I click on that. It's an empty folder, and then I upload it. So I click on new, and then I say, oops, I'll open my downloads folder where I have my files already downloaded. So this is the file, ISIM-ML part 1. So I take that file and then I move it. I drag and drop into this drive. So now I have this IPYNB notebook file here in my drive. And when I double click that, it's taking some time. It would automatically open in the Google Collaboratory tool, online tool, okay? So I basically double click this and then it opened in Google Collab. Sometimes if that option is not available, you may be asked, so you right click that file. And then there's an option called as open with. And then it'll show you Google Collab if it's available. Otherwise, you'll have to click on connect more apps and then select Google Collab from that if you do not already have a Google Collab setup in your system. Okay, so I'm assuming you either already have Google Collab or you can just click on connect. Okay, so now I have this entire program. Okay, now if I just click run and say run all, it'll throw up error because I did not upload the climate change underscore CSV data file. So hopefully it should throw some error. It'll take some time because it says connecting here. And once it is connected only, it will start running, okay? So it started running and then this code block ran fine, but this code block will return you an error saying no such file or directory. So because I did not upload the file. So in order to upload the file, on the left-hand side, I go to the 4th button here, and then I see, an empty folder here. I can click on upload here and then select my climate change underscore CSV file from my local folder. So in my local folder, I have this climate change.csv. You click OK here for uploading it. And then once it's uploaded, you again run it. And then you should ideally see this output. And then you run the other code blocks also one by one. And then you will get the output as expected. Now, one of the questions that was asked in the Zoom meeting is that, we are giving this code, as it is, and we are quite sure that you will be able to get the output as expected. So one of you asked a very relevant question, that how do you train yourself to write such code? Okay, how do you train yourself to write your own code? by Pooja Soni, if I'm not wrong. So the only way is that our basic idea is that during this workshop, we'll be giving you sample code. And now you have the freedom to play around with it. For example, what happens if you don't drop year, month, etc., or you drop more columns and then try to plot, try to print. In the SNS pair plot also, now you are printing, only starting from CO2 onwards. One of you asked a very good question that what happens, he thinks that there is an influence of month on the temperature also because it's seasonal, right? Seasonal variations will be there. It's a very good point. So why don't you include month also? So instead of 2, you include the month column also, which is the month column. So you have to go up and see that month column is the first column. So instead of 2, you change that to 1 and then rerun the same plot and see what is the relationship between month and temperature. So this code is basically giving you a framework using which you can play around. You can play around a lot. And that is how you learn. There is absolutely no other way by which you can learn coding, just from nowhere. You start with some basic code, you play around with it, you plot different things here and there, see what is the difference. See, when I plotted month, a lot of things changed. So month versus temperature is here, and month versus the other parts is here. So try to interpret that. Month versus CH4 is also here. Try to interpret that. So that's how you play around. Once you play around with the code, that's how you learn it. So I just wanted to answer that question as well. Okay. All right. So I hope things are clearer. There is a few more questions which I would like to. Some of you asked, please show uploading of data again. I hope I covered that. Is it possible to access the data in row-wise? Some of you have answered that. Yes, you can access it. What is the difference between IPython notebook and Python? I hope you got the answer. Okay, great. Okay, thank you all for joining in for this part of the workshop. Durga, so shall we wrap up before the lunch, for the lunch?
Sure. We'll wrap up.
Okay, so thank you all for joining in. So after the lunch, we will meet again and then resume the workshop where we will deal with a little bit more of data analysis and then go into machine learning model. Okay, thank you all. Have a good break. Enjoy your lunch. Thank you for joining. We'll resume in the same Zoom call itself. Thank you.
കഴിഞ്ഞ വർഷം അനേക പ്രകൃതി ദുരന്തങ്ങൾക്കും സംഘർഷങ്ങൾക്കും ലോകം സാക്ഷ്യം വഹിച്ചു. പ്രളയം നമുക്കൊരു താക്കീതായിരുന്നു, സന്ദേശമായിരുന്നു. സ്വാർത്ഥമായ താൽക്കാലിക ലാഭങ്ങൾക്ക് വേണ്ടി പ്രകൃതി ചൂഷണം അതിൻ്റെ യുദ്ധഫലമാണ് നമ്മൾ കണ്ടത്. ഓരോ വൃക്ഷം വെട്ടുമ്പോഴും അത് നമുക്ക് ശവപ്പെട്ടി ഉണ്ടാക്കാൻ വെട്ടുന്ന വൃക്ഷം പോലായി തീർന്നിരിക്കുകയാണ്. അതുകൊണ്ടാണ് നമ്മൾ പറയുക പ്രപഞ്ചത്തിനൊരു താളമുണ്ട്. ഈ വിശുദ്ധം അതിൽ അകലജീവിയാണെങ്കിലും തമ്മിൽ അഭേദ്യമായ ബന്ധമുണ്ട്. പരസ്പരം ബന്ധപ്പെട്ട് കിടക്കുന്ന നെറ്റ്വർക്കുകളാണ് ഈ പ്രപഞ്ചം. 4 പേര് ചേർന്ന് പിടിച്ച് ഇവരുടെ ഫോണിൽ സ്ഥലമുണ്ടായാൽ അതെല്ലായിടവും പ്രതിഫലിക്കും. അതുപോലെ നാം അറിഞ്ഞോ അറിയാതെയോ ഒറ്റയായോ കൂട്ടമായോ ചെയ്യുന്ന എല്ലാ കർമ്മങ്ങളും പ്രപഞ്ചമാകുന്ന വരയുടെ ഫോണിൽ പ്രതിഫലിക്കുന്നുണ്ട്. അവർ മാറി നമ്മൾ മാറാൻ നടക്കില്ല. അവർ മാറില്ല, നമ്മൾ മാറിയാലും മാറ്റം കൊണ്ടുവരും. നമുക്ക് എന്ത് ചെയ്യാൻ പറ്റുമെന്ന് നോക്കണം. കൂടുതലായി നമ്മൾ ചിന്തിക്കേണ്ട ഒരു കാര്യമാണ് ഭാവിയിലേക്കുള്ള പ്രകൃതിയെ സംരക്ഷിക്കുന്നതിനെ പറ്റി.
Experience is the final evidence for knowing. Shraddhavan labde jnanam.
A university where future is driven by imagination. Experiential learning creates diverse opportunities, where industry exposure and international partnerships help you sail. Come, start your journey towards success with Amrita University.
Human settlements in rural areas have always enjoyed a direct link with the surrounding natural environment. However, with rapidly depleting resources, many villages in India have entered into sustained poverty. In 2013, Amrita Vishwa Vidyapeetham, guided by its Chancellor, Sri Mata Amritanandamayi Devi, launched the Live in Labs program.
We have made this program in such a manner that it has closely knitted the interdisciplinary domains together to bring in the solution. We give the students an opportunity to see the rural community, be in that environment, in the rural community, along with them, live with them. So automatically, compassion will be generated in their heart, which provides them an opportunity to find out what are the challenges they are facing and how their technical knowledge can be used to provide it as a solution.
The Live in Labs program continuously strives to achieve the UN Sustainable Development Goals by fostering self-reliant communities. Bachelor's, master's, and PhD students from all over the world can spend 2 weeks to 6 months working with Amrita faculty and students at one of the program sites. After a comprehensive orientation session and team formation, program participants will live in and explore the village to identify challenges and co-design a proposed solution. Implementation, evaluation, and making improvements will happen after testing the solution in the university's labs.
For any technological solution to be viable, to be sustained, you need to be with the community in designing the solution. That is one of the major things we train them in the whole process, where they'll work with them in coming up with the design. They look into it, what is their needs, so that they can come up with affordable, adaptable, sustainable solution, which will make sure that the technological solutions will become a success.
The program draws on principles of human-centered design for the development and deployment of sustainable solutions in the areas of energy and environment. By developing pathways to access renewable electrical energy, utilizing smart energy technology, and encouraging sustainable practices to protect the environment and conserve natural resources. Water and sanitation. By designing micro-water distribution and management systems, implementing water filtration systems, and fostering water-wise communities. These are joined by initiatives in rural sanitation, which develop sustainable models for toilet construction fostered through democratic participation. Health and hygiene. By implementing hygiene awareness programs to increase community health and well-being, developing low-cost technologies, diagnosis units, micro healthcare management devices, a rural health management system, and epidemic management and detection programs. Livelihood and skill development. By designing immersive training programs to acquire new skills, further developing existing skills, and identifying alternative and sustainable income generation avenues, ensuring long-term viability. Education and gender equality. By encouraging gender equality in education through immersive technologies for language training, vocational training, after-school assistance, and life skill training. Waste management and infrastructure. By exploring environmentally sustainable solutions for rural waste management, such as waste-to-wealth initiatives and alternative affordable construction techniques from natural resources. Agriculture and risk management. By designing innovative and smart technologies to promote efficient farming practices, developing techniques to enhance soil and crop quality, and implementing models and systems to map and identify environmental risks. Over the years, students from multiple universities around the world have come to Amrita to participate in various Live-in Labs projects. India's villages are her life force, and they need immediate care and attention. Societies are at their most resilient when knitted closely with threads of love and compassion. So join us and let us work together to develop self-reliant villages in India. Experience is the final evidence for knowing. Shraddhavan Labte Jnanam.
Center for Wireless Networks and Applications, a cutting-edge research center at Amrita Vishwavidyapeetham, offers MTech and PhD programs. The center has the following state-of-art laboratories for researchers and students. India's first landslide simulation laboratory, and our contributions have resulted in the design, development, and deployment of the world's first wireless sensor network system for landslide monitoring and early warning. This lab serves as a test bed for developing and varying the conditions of the systems that we intend to deploy in the landslide-prone areas. These are the advanced equipments we use for testing soil and rock samples brought from the field. Their geotechnical properties are tested based on international standards. Keysight Technologies, a global leader in electronic measurement equipment and design tools, have collaborated to establish a state-of-the-art advanced wireless communications lab. This is one among the very few such labs found in Indian universities and has equipment valued at several crores of rupees. Smart Grid Lab targets distributed multi-scale smart networks which facilitate the integration of low-cost real-time monitoring and control devices into the grid. The The lab serves as a test bed for students and researchers where they can plug in their modules and validate using the real-time data visualization tool. The lab also supports validation of renewable energy systems that are developed for rural electrification projects. This lab provides an experimentation platform for developing low-cost educational technology platforms. This lab hosts a variety of tools, including a host of specialized depth detection, PTZ leap motion devices. A perfect platform for architecting a next-generation classroom system using computer vision algorithms such as gesture detection, participant localization, etc. This lab will provide students practical experience in designing, deploying, and implementing wireless sensor networks in both indoor and outdoor conditions. Remote users will have a permanent test bed for development and testing of concepts. This lab includes 12 experiments demonstrating these concepts by providing study materials, animations, interactive simulations, and a remote panel. Hardware lab of Amrita WNA serves the students and staff for their research and development. The lab has various types of tools from Weller, Taperia, Fluke, Freeman's, Dremel, Bosch, Mecco, etc. Nearly 50 different tools can be found here. Our MTech programs.
ഒരപേക്ഷയുള്ളത് യൂണിവേഴ്സിറ്റിയിലെ കുഞ്ഞുങ്ങളെ പറ്റുന്ന രീതിയിൽ 2 മാസത്തേക്കെങ്കിലും ഗ്രാമങ്ങളിൽ ഇൻറ്റേൺഷിപ്പിനായിട്ട് അവർ അയക്കണം. അവിടെ പോകുമ്പം തീർച്ചയായിട്ടും പാവപ്പെട്ടവരെ കാണാനും അവരുടെ മനസ്സിലെ കാരുണ്യം ഉണരും. ഇങ്ങനെയുള്ളവർ ലോകത്തിലുണ്ടെന്ന് ചിന്ത കൂടി അവർക്ക് വരും. അതൊരു സൈക്കോളജിക്കലായിട്ട് നല്ലതാണ്. എല്ലാത്തിലും അടങ്ങിയിരിക്കുന്ന ആത്മാവ് എന്നാണ്. വലത് വെച്ചാൽ വെറുതെ തലോടുന്നത് പോലെ മറ്റുള്ളവരുടെ ദുഃഖം തൻ്റെ ദുഃഖമായും മറ്റുള്ള സന്തോഷം തൻ്റെ സന്തോഷമായി കണ്ട് അവരെ സേവിക്കാനുമുള്ള തത്വമാണ് നമ്മൾ ആധ്യാത്മികപ്പടി ഗ്രഹിക്കുന്നത്. നമുക്കിപ്പോൾ കുറച്ച് വെള്ളമെങ്കിലും ഉണ്ട്. നമ്മൾ പൈസ സമ്പാദിക്കുന്നു, കുട്ടികളെ സൃഷ്ടിക്കുന്നു. പക്ഷേ കുടിക്കാൻ വെള്ളമില്ലെങ്കിൽ എന്തായിരിക്കും? ഇതിൻ്റെ കൂട്ടത്തിൽ പണസമ്പാദനം കുട്ടികളെ സൃഷ്ടിക്കുന്നത് പോലെ തന്നെ അതിനേക്കാളും കൂടുതലായി നമ്മൾ ചിന്തിക്കേണ്ട ഒരു കാര്യമാണ് ഭാവിയിലേക്കുള്ള പ്രകൃതി സംരക്ഷിക്കുന്നതിനെ പറ്റി.
Experience is the final evidence for knowing. Shraddhavan labde jnanam.
Amrita is now among the top 100 universities in the world and the first in India in the Times Higher Education Impact Rankings 2021. THE Impact Rankings is the only rankings to rate universities around the world on United Nations 17 Sustainable Development Goals. This feat is a testament to our Chancellor Amma's vision and leadership.
100 യൂണിവേഴ്സിറ്റിയുടെയും കണക്കുകൾ നോക്കുന്ന അവരുടെ റിസർച്ചുകൾ, അവർ കൊണ്ടുവന്ന ഫണ്ടുകൾ, അവരുടെ ബുദ്ധിപരമായ കാര്യങ്ങളൊക്കെയാണ്. അപ്പം അങ്ങനെ വെച്ചിട്ടാണ് പ്രൊമോഷൻ വലുപ്പം നീന്ത്. ഒറ്റ ഒരു അപേക്ഷ, ഈ നമ്മൾ കൊണ്ടുവന്ന് നടത്തിയ റിസർച്ചിൽ അല്ലെങ്കിൽ നമ്മൾ ചെയ്തത് സമൂഹത്തിന് എത്ര കണ്ട് ഉപകരിച്ചു, അല്ല എത്ര കണ്ട് നമുക്ക് സഹായിക്കാൻ പറ്റി എന്നുകൂടി ഒരു ഭാവം നമ്മൾ ഉണർത്തിയെടുക്കുകയാണെങ്കിൽ അതൊരു സ്വർണ്ണത്തിന് പരിമണം വന്ന പോലെ ആയിരിക്കും.
Now ranked 5th in the world for quality education. Eighth in the world for gender equality. 37th in the world for good health and well-being. 52nd in the world for clean water and sanitation. Top 200 in the world for industry, innovation and infrastructure. Top 200 in the world for partnerships for the goals. We thank our students, faculty, staff, alumni, and partners who are influencing change both nationally and globally as we build for the future.
Hey guys, are you still searching for the right master's courses? Then stop. Your search ends here. Center for Wireless Network and Application, Amrita Vishwavidyapeetham has opened its admission. You can be eligible for scholarship also. If interested, you can apply using the link in the description box.
Marine fishermen along India's 7,517 kilometer coastline spend several days on the open seas as far away as 120 kilometers from the shore. They are completely isolated from their families and other service agencies on land during these days. They don't have a way to communicate during emergencies such as accidents, illnesses, vessel breakdown, etc. Also, there is no way to alert them about impending storms, potential collision with another vessel, potential fishing zones, etc. They cannot afford to use satellite phones because they're very expensive. So what they're looking for is a very low-cost solution that will enable them to communicate to the land. So the researchers at Amrita Center for Wireless Networks and Applications have developed and deployed a very low-cost communication infrastructure called OceanNet. It can provide connectivity up to 60 to 70 kilometers from the shore using a Wi-Fi network on the boat. Fishermen can connect to this network using the smartphones that they own already. This solution has been field tested 7 times so far using up to 4 trawlers, and it has also been permanently deployed on 9 trawlers already.
Hi, I am Akshay Sadesh, MTech Geoinformatics and Earth Observation student from Center for Wireless Networks and Application, Amrita Vishwavidyapitham. My research area is in the coastal change detection using satellite imagery. Recently, in one of the symposium organized by the center, I could meet up delegates of ISRI India and discuss my research work with them. They were interested in my work and offered me an internship. Now, I am working with ISRI on GIS and remote sensing to estimate the coastal erosion rate. I am happy that I am contributing to some of the UN Sustainable Development Goals. I thank my faculty and staff members at Amrita WNA for supporting me. Thank you.
Historically, India has been dependent on energy imports to meet its national energy requirements. However, the last few years has seen India make rapid strides in bridging the gap between available energy and energy demand. To sustain the progress achieved and to ensure reliability, the stakeholders are placing a lot of emphasis on energy efficiency and demand-side management. There is an immense need to move from traditional, centralized, static energy grid towards a decentralized and dynamic grid, which gives more freedom to producers, distributors, and consumers. Our research targets distributed multi-scale smart networks, which facilitate the integration of low-cost, real-time monitoring and control devices into the grid. This work integrates ICT techniques to empower power grids with the capability of real-time information and two-way energy flow. In this project, a campus-level smart distribution grid has been developed and deployed to demonstrate the capabilities to provide stable energy. The research outcomes from this project include a radial distribution grid testbed offering complete flexibility to sectionalize via remote operated switches, IoT-enabled smart metering and control architecture, wireless interoperable heterogeneous network, M2M ready and AI-based demand forecasting and fault prediction, line breakage detection, fault section isolation and automatic grid reconfiguration, power quality assessment and power theft detection using ICT, learning techniques and decision models, real-time and historical visualization of distributed system data, self-similar ICT systems architecture. ICT Gateway for Simulation platform offering co-simulation possibilities where systematic interactions can be studied effectively. These outcomes will aid stakeholders to analyze, decide, and reconfigure the grid in near real time in the event of any irregularity or fault. This will immensely help in improving fault management, energy wastage, and eliminate load shedding in case of glitches and irregularities. We hope that the results of this research will serve as a benchmark for stakeholders to adopt, demonstrate the benefits of smart grid systems, and pave the way for a reliable power system that meets the growing demands of the people.
Located in the Idukki district of Kerala, lies along the famous Western Ghats and has experienced multiple landslides in its history. Over the past several decades, many homes have been destroyed and many lives have been lost as a result of the rainfall-induced landslides. European partners of the Windsock project visited Amrita in June 2009. Amrita University's landslide detection system monitors 7 acres of unstable land and currently includes 20 sensor columns, 20 wireless network nodes, and around 150 sensors. The sensor columns are solar-powered and include many geotechnical sensors which are buried underneath the ground. The data from these sensor columns are aggregated and combined at the Field Management Center, which then transmits through the satellite network to Amrita University's Amritapuri campus. The data are then analyzed, stored, and streamed to the university's web server. The system has successfully given warnings 3 times. Amrita's wireless landslide detection system has also been featured in several leading Indian newspapers. The team is currently working on implementing a landslide detection system in the Himalayas. Based on the initial survey of population distribution and slope vulnerability, the Chandmari region in Sikkim was assessed to be the most needed area to install the detection system. The pilot phase of the project has been completed. The system will be fully deployed and operational by the end of 2017. Once completed, the system will be able to monitor landslides in an area of approximately 130 acres.
டைம்ல எங்களுக்கு ஒரு இன்ஃபர்மேஷன் கிடைச்சதுனால இங்குள்ள மக்களையும் வந்து ஒரு பாதுகாப்பா இருக்கிறதுக்கு முடிஞ்சிச்சு. அதனால இப்போ வந்து என்ன செய்யும் மக்கள் பயம் இல்லாம இருக்கறாங்க. இதனால இது வச்சதுனால அமிர்தானந்த அம்மாவுக்கு அவங்களோட இன்ஸ்டிடியூட்ல வேலை செய்த எல்லாருக்கும் ரொம்ப நன்றி.
நன்றி. அமிர்தா அம்மைக்கு வளர நன்றி. ഞങ്ങളുടെ നന്ദി ആശംസിക്കുന്നു.
ഞാൻ ജനിച്ച ഗ്രാമത്തിൽ ഒരു 90% ആൾക്കാർ അന്നന്ന് ജോലി ചെയ്ത് ജീവിക്കുന്നവരാണ്. അസുഖം വന്നാൽ അല്ല ഹാർട്ട് അറ്റാക്ക് വന്നാലോ വാൾ മേടിക്കാൻ പൈസയില്ല, അത് വെളി രാജ്യത്ത് നിന്ന് വരുത്തണം, അത് വലിയ തുകയാണ്. അപ്പോൾ ഇവരാരും ഓപ്പറേഷൻ ചെയ്യുകയോ വാൾ മാറ്റി വയ്ക്കുകയില്ല. 70 വയസ്സ് ജീവിക്കേണ്ടവൻ 40 വയസ്സ് 30 വയസ്സ് മരിച്ചു. അന്ന് ആ രാജ്യത്തിൽ ഉണ്ടാക്കിയിരുന്നെങ്കിൽ വളരെ വില കുറഞ്ഞ് കിട്ടിയേനെ, ഇവരൊക്കെ രക്ഷിക്കാനും പറ്റിയേനും. ആ സമയത്താണ് ഇഷ്ടം വരികയും റിസർച്ച് ഇങ്ങനെ സാധുക്കൾ കൂടെ സഹായിക്കുന്ന രീതിയിൽ ചെയ്യുന്നത് നല്ലതായിരിക്കുമെന്നൊരു മനോഭാവം മനസ്സിൽ ഉണരുകയും ചെയ്തു. ശിശുമരണം വന്നപ്പോൾ നമ്മൾ അന്വേഷിക്കാൻ അയച്ചു ഗ്രാമങ്ങളിൽ. ആ സമയത്ത് ചില സ്ത്രീകൾ പച്ചില കഴിക്കുകയാണ്. എന്തിനാണ് നിങ്ങൾ പച്ചില കഴിക്കുന്നതെന്ന് ചോദിച്ചപ്പോൾ മാസത്തിൽ 10 ദിവസമേ ഭർത്താക്കന്മാർ ജോലി കിട്ടുകയുള്ളൂ, അതുകൊണ്ടൊരു മാസം തികയ്ക്കണം, അപ്പോൾ കുറച്ച് ഭക്ഷണം കഴിക്കാൻ കിട്ടുകയുള്ളൂ. അപ്പോൾ ഈ ഒരു തരം വിലയുണ്ട്, അത് കഴിച്ചാൽ വിശപ്പറിയില്ല, അപ്പോൾ കുറച്ച് കഴിച്ചാൽ മതി, അപ്പോൾ വിശപ്പറിയാതിരിക്കാൻ വേണ്ടി കഴിക്കുകയാണ്. ഇങ്ങനെയുള്ളവർ പ്രസവിച്ചാൽ എങ്ങനെ പോഷകാംശമുള്ള കുട്ടികളെ പ്രസവിക്കാൻ സാധിക്കും? അപ്പോൾ തീർച്ചയായിട്ടും സ്ത്രീകളെയാണ്, അമ്മമാരെയാണ് ആദ്യം ശ്രദ്ധിക്കേണ്ടത്. അപ്പോൾ ഇതുപോലാണ് കണ്ടത്. വേറൊരു ഗ്രാമത്തിൽ ചെല്ലുമ്പോൾ അവർ ഭക്ഷണമുണ്ട്, പക്ഷെ ഭർത്താവ് കുടിച്ചിട്ട് വരുന്ന നമ്മൾ പിടിച്ച് തല്ലുകയും ബഹളം വയ്ക്കുകയും ചെയ്യും, ഉള്ളത് തന്നെ കഴിക്കാൻ പറ്റുന്നില്ല. അപ്പോൾ അവർ ജോലി തരുന്നതുകൊണ്ടല്ലേ, എന്ത് ചെയ്യാനാണ്, നമ്മൾ പഠിച്ചിട്ടില്ല. അപ്പോൾ ആ സമയത്ത് എനിക്ക് തോന്നി, കാരണം ഇവർക്കൊരു എന്തെങ്കിലും ഒരു തൊഴിൽ പഠിപ്പിച്ചു കൊടുത്താൽ ഇവർക്കൊരു സ്വയം പര്യാപ്തമാകാൻ പറ്റും. ഇങ്ങനെ ഇടികൊണ്ട് കഷ്ടപ്പെടേണ്ട ആവശ്യമില്ലല്ലോ. കാരണമെന്ന് വെച്ചിട്ടാണ് അങ്ങനെ തൊഴിൽ പഠിപ്പിക്കാൻ അമ്മ തുടങ്ങിയത്. വേറെ സ്ഥലത്ത് ചെന്നപ്പോൾ പറഞ്ഞു ഗവൺമെൻറ് ചില ആനുകൂല്യങ്ങൾ കിട്ടുന്ന അമ്മ, പക്ഷെ ഭർത്താവ് അത് ഒപ്പിട്ടിട്ട് ഞങ്ങളുടെ ഒപ്പുപോലിട്ടിട്ട് കൊണ്ട് പൈസ എടുത്ത് പോയി കുടിക്കുകയാണ്. പക്ഷെ അതുകൊണ്ട് അവരിങ്ങനെ കഷ്ടമായി. അപ്പോൾ അക്ഷരങ്ങൾ അവർക്ക് പഠിപ്പിച്ചു കൊടുക്കണമെന്ന് തോന്നി. അങ്ങനെ അക്ഷരങ്ങൾ പഠിപ്പിച്ചു കൊടുക്കാനുണ്ട്. അങ്ങനെ ഓരോരോ സന്ദർഭങ്ങൾ, ഓരോ അനുഭവത്തിൽ നിന്ന് പലരും പല കാര്യങ്ങൾ അങ്ങനെ ചെയ്യാൻ പറ്റി. അതുകൊണ്ട് ഒരപേക്ഷയുള്ളത്, യൂണിവേഴ്സിറ്റിയിലെ കുഞ്ഞുങ്ങളെ പറ്റുന്ന രീതിയിൽ 2 മാസത്തേക്കെങ്കിലും ഗ്രാമങ്ങളിൽ ഇൻറ്റേൺഷിപ്പിനായിട്ട് അവർ അയക്കണം. അവിടെ പോകുമ്പം തീർച്ചയായിട്ടും പാവപ്പെട്ടവരെ കാണാനും അവരുടെ മനസ്സിലെ കാരുണ്യം ഉണരും. ഇങ്ങനെയുള്ളവർ ലോകത്തിലുണ്ടെന്ന് ചിന്ത കൂടി അവർക്ക് വരും. അതൊരു സൈക്കോളജിക്കലായിട്ട് നല്ലതാണ്. എല്ലാത്തിലും അടങ്ങിയിരിക്കുന്ന ആത്മാവ് എന്നാണ്. വലത് വെച്ചാൽ വെറുതെ തലോടുന്നത് പോലെ മറ്റുള്ള ദുഃഖം തൻ്റെ ദുഃഖമായും മറ്റുള്ള സന്തോഷം തൻ്റെ സന്തോഷമായി കണ്ട് അവരെ സേവിക്കാനുമുള്ള തത്വമാണ് നമ്മൾ ആധ്യാത്മിക കൂടി ഗ്രഹിക്കുന്നത്. ലോകത്ത് 2 തരത്തിലുള്ള ദാരിദ്ര്യമുണ്ട്. ഒന്ന് ആഹാരവും ഭക്ഷണവും വസ്ത്രവും കിട്ടാതെ ദാരിദ്ര്യം അനുഭവിക്കും. 2 സ്നേഹവും കാരുണ്യവും കിട്ടാതെ ദാരിദ്ര്യം അനുഭവിക്കുന്നു. ഈ സ്നേഹവും കാരുണ്യം ഉണ്ടെങ്കിൽ ആഹാരവും വസ്ത്രവും കടപ്പാടവും കിട്ടാത്തവരെ സഹായിക്കാൻ സാധിക്കും എന്നുള്ള. ജീവിതമാകുന്ന വൃക്ഷം സ്നേഹമാകുന്ന മണ്ണിൽ ഉറച്ചു നിൽക്കട്ടെ. സൽക്കർമ്മമാകട്ടെ അതിൻ്റെ ഇലകൾ, അനുകമ്പപൂർണ്ണമായ വാക്കുകളാകട്ടെ അതിൻ്റെ പുഷ്പങ്ങൾ, ശാന്തിയാകട്ടെ അതിൻ്റെ ഫലങ്ങൾ. അങ്ങനെ സ്നേഹത്തിൽ ഒന്നായി ഒരു കുടുംബമായി വളർന്ന് വികസിക്കട്ടെ. അങ്ങനെ ശാന്തിയും സമാധാനവും കളിയാടുന്ന ഈ ലോകത്തിന് വേണ്ടി നമ്മൾ പ്രാർത്ഥിക്കാം.
Success. It's the buzzword today in all walks of life. In your journey towards success, the university you choose plays a major role. With top-class research infrastructure, PhD faculty, and high-quality education, Amrita plays a major role in its students' success stories. Come, join Amrita University, an institution of eminence by UGC, ranked as the top private university in India by Times Higher Education World University Rankings and the 4th best university in India by NIRF Rankings 2020. Through our specially designed Chancellor's Scholarship, we provide up to 100% fee waiver and help you learn from the best. Our dual degree program in association with top universities from US and Europe can get you ahead of the curve. Come, start your journey towards success. Visit www.amrita.edu. Success starts with Amrita.
The tribal village of Multihazard is nestled amidst the mesmerizing jungles of the Western Ghats, where the lemongrass plant grows in abundance. Located in the Wayanad district of Kerala, Multihazard is home to 70 families, approximately 300 people, where their main source of income comes from cutting and selling wood and lemongrass. The lemongrass is processed through a distillation unit which produces a valuable and multi-purpose oil. Villagers assist in the distillation process but are unable to own distillation units themselves due to the high cost. Over the past several years, the tribal community in Multihazard has faced economic instability as restrictions were placed on cutting trees. With the inability to collect and sell wood, which is burned in the distillation process that produces the lemongrass oil, villagers were forced to find work elsewhere. Many were unable to do so, which resulted in a sustained state of poverty for several families.
ആദ്യം പുല്ല് പറ്റിയായിരുന്നു ജീവിച്ചിരുന്നത്. പിന്നെ അതിനുശേഷം വിറക് ഇല്ലായ്മയായതുകൊണ്ട് പിന്നെ എല്ലാവരും പുറത്ത് പണിക്ക് പോകാനൊക്കെ തുടങ്ങി. പിന്നെ വീട്ടിലെ മക്കളെയൊക്കെ നോക്കണമെങ്കിലും പിന്നെ നോക്കാനുള്ള അവസരം ഇല്ലായിരുന്നു.
Recognizing the hardship of the villagers, students, faculty, and staff from the Amrita Department of Chemical Engineering and Material Sciences, the Amrita Center for Advanced Materials and Green Technologies, and the Amrita Center for International Programs collaborated with international students from Delft University of Technology, Netherlands, to design, develop, and deploy a solar thermal-based lemongrass distillation system. By using renewable energy resources, the system provides a low-cost and reliable avenue for income generation without harming the environment. Approximately 7,000 hours was invested in designing, developing, and implementing the lemongrass distillation system in Modakara.
The entire solar energy which is falling on this solar dish will be focused onto this focal point. So since that it is receiving the energy at a focal point, the temperature at this point will be very high. Water behind this plate will be heated and the steam will be produced. The steam produced will be collected in the steam drum at the top and will be used for distilling the lemongrass.
പഠിപ്പിക്കാനും അമ്മമാർക്ക് കുട്ടികളെ നോക്കാനോ ഒന്നും കഴിയുന്നില്ല. ഫോറസ്റ്റിൽ വിറക് എടുക്കാനോ ഒന്നിനും പറ്റുന്നില്ല. അതുകൊണ്ട് ഞങ്ങൾ അരിപ്രശ്നം തന്നെ മൂത്തിരിക്കുക. ഇപ്പോൾ അമ്മ വന്നതിന് ശേഷം മക്കൾക്ക് ഡ്രസ്സ് ഭക്ഷണമൊക്കെ ഞങ്ങൾക്ക് മെച്ചമുണ്ട്.
Before the new distillation unit was introduced, villagers had to burn 50 kilograms of wood for approximately 2 hours just to generate 100 to 150 milliliters of oil. The new distillation unit decreases both labor and time and enables villagers to produce and sell their own oil. Furthermore, as part of an effort towards women empowerment, the distillation system is fully operated by the ladies of Modakara village.
Education has the mighty power to move millions of minds, from darkness to light, from limitations to limitlessness, from finite to infinite. Our country is believed to have had a higher education system as early as 1000 BC. But today, only 26.3% of the total eligible population enroll for higher education. Only 8.15% of people are graduates. Amritam Kamea. Now is the time to revolutionize, rethink, redefine education. Fourth best university in India introduces new normal in delivering education to the masses. Amrita Ahead. Online degree programs. Unlimit yourself. Get ahead.
In rural areas of India, the water the villagers consume is often contaminated due to runoff from their fields, which carry a high concentration of chemical pesticides. Recognizing the need to address this challenge, the Amrita University team decided to work with the villagers to bring clean water to the settlement. In the village of Guptapada, located in Odisha, through MA Mart's Amrita Serve and Amrita University Live in Labs initiative, water is now distributed to 60 homes. Villagers are now able to receive water through a pipe system which connects to an overhead Syntex steel water tank that currently stores 5,000 litres of water. Many villagers express their gratitude to Amma because they no longer needed to make the strenuous trek to collect and carry water back to the village.
ଆମେ ତ ସବୁ ଦେଲେ ସବୁ ଇଆଡ଼େ କଳ ବସାଇଲେ ଆମ ଗାନ୍ଧୀ ଏଠି ପାଣି କହନ୍ତି ବଛର ଦେବେ ଆଉ ସବୁ ତ ଆମକୁ ଦେଲେ ଆଉ କ'ଣ ଆମର ଅସୁବିଧା କଲେ
ସବୁ ହେଲା ଲୋ ମାମା ଏଇଟା ସରକାରୀ କବଲରେ ଆମେ ଏଇ ଜାଗା କାଗଜପତ୍ର ହେଇନି ଯେହେତୁ ଆମେ ଗୋଟେ ଘରୁ ବାହାରିଲୁ ବଜାରକୁ ଯିବା ପାଇଁ ତେଲ ଗୋଡ଼ା ଧୁଆ ହେଇନୁ ଟିକେ ଧୁଆ ଦେଇଛୁ ସୁବିଧା ଆସିଲୁ ଶୋଷ ଲାଗିଲା ଏଠି ଟିକେ ପାଣି ପିଇଦୁ ବଜାରରୁ ଆସିଲୁ ସାଇକେଲ ଚଲେଇକିରି ଟିକେ ପାଣି ପିଇଦୁ ଖରାରେ ଆଉ ଆମର ଏଠି ଫୁଟବଲ ଖେଳ ହେଉଛି ଏଠି ଆମର ଷ୍ଟଲ୍ରେ ପାଣି ରହିବା ନିହାତି ଦରକାର ଷ୍ଟଲ୍ ପାଖରେ ବି ହେଇଛି ଏଠି ଆମେ ଷ୍ଟଲ୍ କରୁଛୁ ଫୁଟବଲ ଖେଳ ହେଉଛି ଆମର ମ୍ୟାଚ୍
ଆମ ଦେବାରୁ ଆମେ ବହୁତ ସୁବିଧାରେ ଅଛୁ।
There's a place where the best minds come together, work to end inequalities, work towards transforming lives. This is a place recognized as one of the world's best universities. This is Amrita, now ranked among the top 100 universities in the world and ranked number 1 in India. Amrita University.
കഴിഞ്ഞ വർഷം അനേക പ്രകൃതി ദുരന്തങ്ങൾക്കും സംഘർഷങ്ങൾക്കും ലോകം സാക്ഷ്യം വഹിച്ചു. പ്രളയം നമുക്കൊരു താക്കീതായിരുന്നു, സന്ദേശമായിരുന്നു. സ്വാർത്ഥമായ താൽക്കാലിക ലാഭങ്ങൾക്ക് വേണ്ടി പ്രകൃതി ചൂഷണം ചെയ്യാൻ തുടങ്ങിയിട്ട് കാലങ്ങൾ കുറേയായി. അതിൻ്റെ ദിഗ്ധഫലമാണ് നമ്മൾ കണ്ടത്. ഓരോ വൃക്ഷം വെട്ടുമ്പോഴും അത് നമുക്ക് ശവപ്പെട്ടി ഉണ്ടാക്കാൻ പറ്റുന്ന വൃക്ഷം പോലായി തീർന്നിരിക്കുകയാണ്. പ്രപഞ്ചത്തിനൊരു താളമുണ്ട്. ഈ വിശുദ്ധം അതിൽ അകലജീവിയാളും അഭേദ്യമായ ബന്ധമുണ്ട്. പരസ്പരം ബന്ധപ്പെട്ട് കിടക്കുന്ന നെറ്റ്വർക്കുകളാണ് ഈ പ്രപഞ്ചം. 4 പേര് ചേർന്ന് പിടിച്ച് ഇവരുടെ ഫോണിൽ സ്ഥലമുണ്ടായാൽ അതെല്ലായിടവും പ്രതിഫലിക്കും. അതുപോലെ നാം അറിഞ്ഞോ അറിയാതെയോ ഒറ്റയായോ കൂട്ടമായോ ചെയ്യുന്ന എല്ലാ കർമ്മങ്ങളും പ്രപഞ്ചമാകുന്ന അവരുടെ ഫോണിൽ പ്രതിഫലിക്കുന്നുണ്ട്. അവർ മാറി നമ്മൾ മാറാൻ നടക്കില്ല. അവർ മാറിയില്ല, നമ്മൾ മാറിയാലും മാറ്റം കൊണ്ടുവരും. നമുക്ക് എന്ത് ചെയ്യാൻ പറ്റുമെന്ന് നോക്കണം. കൂടുതലായി നമ്മൾ ചിന്തിക്കേണ്ട ഒരു കാര്യമാണ് ഭാവിയിലേക്കുള്ള പ്രകൃതിയെ സംരക്ഷിക്കുന്നതിനെ പറ്റി.
Experience is the final evidence for knowing. Shraddhavan labde jnanam.
Namshivaya. Welcome back to all the participants. So I hope you had a wonderful machine learning session. It will be continued. So before that, we have a wonderful talk by Dr. V. Sushila Devi, who is the principal research scientist from Department of Computer Science and Automation, IISc Bangalore. She has expertise in the field of pattern recognition, data mission. So she will be giving us a talk on geospatial modeling. So Dr. Sushila ma'am, we welcome you.
Thank you. So, am I audible?
Yes, ma'am, you're audible.
Okay. Yeah, I'll just share my screen.
Okay. Ma'am, but we can't see your face.
Okay. Yeah, I've actually put the video on. I don't.
Yes, ma'am. It's like we can just see your only the upper part of the head. Yeah, now it's clear. Thank you.
Yeah. Okay, so I am going to half an hour is fine, right?
Yes, ma'am, it's fine.
Going to give some aspects of spatial modeling as well as temporal modeling. So I have actually added the temporal modeling also, because in many cases where you have the spatial modeling, you also have to do the temporal modeling because they occur together in many places. So I'll just talk about both these aspects. So where is it that you find the spatio-temporal data? So spatio-temporal data should have at least one spatial and one temporal property. Then only you call it as the spatio-temporal data. And if it is spatial data, it should have at least one spatial data, right? So something to do with location and something to do with time. Both of them should be basically there. Okay. So we need to use the spatial and temporal aspects of the data to carry out any type of modeling. Okay, so the spatial properties include location and something about the geometry of objects or relationship between different objects. For example, if you have two objects, you can say one object is on top of another, or one is beside the spatial aspects. A particular variable may take a certain value at a certain point in time. Okay, so those are some things you need to take into account. And here are some examples. For example, transportation and meteorology, where you take the data, climate data, and you make the isobars and the temperature curves, etc. And climate, of course, where you have to see at different locations at different points in time. And vegetation changes. And things like natural disasters, where you have a process. Okay, so an event is something which happens at a particular point in time. So here you have a process. So how does that process unfold? Okay, so that goes into the natural disasters. And ecology, of course, you know, it's very important in ecology, species migration, vegetable change, etc. And economics, ownership, etc. So here is an example which is given where you have objects which are placed at different, which are there at different points in space, right? So the idea is to find the co-located events. or the objects. Okay, so the objects which are sort of located together. So that is an example of spatial modeling. And here are some examples of spatio-temporal data: forest fires, earthquake, hurricanes, accidents, traffic jams, all these things, right? Okay, so we have some spatio-temporal data which is available, right? So you'll find them on the internet, or it will be available, with some departments in government, etc. So what are these types of data we have? One is, of course, the climate data and things like storms and tornadoes, high pressure areas, etc. Okay, so this type of data is available. And biology data, for example, animal movement. So they move from one point to another depending on the season, and then mating behavior, etc. And medicine, of course, right? So cancer development in patients, then geophysics, earthquakes, volcanoes, about previous events of this type which have occurred and how you can predict. Ecology, okay, environmental changes, pollution, forestry, transportation. So all these are areas where you can have spatial data or even spatio-temporal type of data. Okay, so how do you sort of differentiate between the non-spatial and the spatial type in a spatial data set, right? So what is done is that the non-spatial type of data also will be available along with the spatial data, so etc. Okay, so usually what is done is that the non-spatial and the spatial data are sort of separated from each other. Okay, so that you can work on the non-spatial type separately and not the spatial type separately. So how is the spatial data represented? So you have the grid. Okay, the second one is what is called the vector. I'll tell you more about these. And then we have the graphs. Okay, so these are three methods of representing the spatial data. So for example, here we have a land where networks. Okay, and you can have different layers. Okay, so the one layer can give you the road network. The second layer can give you the rivers, how the river flows, etc. The third layer can give you the elevation. So that is what the topography, etc. Okay. So this is a way of storing this data in the form of layers, right? So you have the spatial data, which is stored in what is called a shape file, and you have the attribute data, which is stored in the database. So they are sort of stored in that way, basically. Okay. So here we can see the types, the way the layer is represented. Okay, so the first one, the top one is the raster method, where you have it represented in the form of pixels, right? So it is divided into a grid, and you have it in the form of pixels. And the second part is the vector format, where you have actually things like the angle and the lines, etc. Right? So something like taking the coordinates of points. Okay, so this is good in giving something like boundaries to things. For example, if you have a lake, the boundary of the lake will represent the lake, etc. Right? So this is the raster data, like I told you. Okay, so it is good for representing continuous features, whereas the vector data is good for representing the discrete data, right? So like I said, the vector is referenced by the XY coordinate. Okay. So let's, yeah. So here some spatial relationships are given. We know about the non-spatial relationships. So let's not talk about the non-spatial type of relationships. So in the spatial relationships, you have the data which is available to you, right? The topological data, whatever, right? You have the entire data available to you, and you can actually get out this information from that. So you have things like if you have two objects or two events, are they meeting, or is one within the other? Are they overlapping each other? And then the directional, okay, metrics, the slope, etc. So all these things are the spatial relationships which we have. Okay, so what do we mean by spatio-temporal modeling?
Excuse me, ma'am. Sorry for the
Get some
interruption.
meaningful.
Excuse me, ma'am. Sorry
Yeah.
for the interruption. Your voice is breaking in between, actually.
Okay, I don't know. It may be because of the internet. Is it okay now?
Yeah, now it's okay. Okay, thank you.
Okay. Right. So you're trying to find some unknown information from your spatio-temporal data. Are there any relationships, any patterns, any structures in the data that you have? Okay, so you use things like machine learning techniques, statistical techniques, forecasting techniques, etc. Okay, which are specifically tailored for spatio-temporal data. Okay, so the actual classical techniques will fail here. Firstly, because like we say, the spatial data is in continuous space. Secondly, because of the high dimension, okay. And also the data is not independent, just like the non-spatial data, right? And of course, we have space and time, which is there in that. Okay, so we have a lot of challenges here. Okay, I won't going to go through all the challenges, but we know that there is a complexity to this, right? Because of the continuous spatial data and discrete non-spatial data we have, okay? And then, you cannot use the non-spatial data, whatever techniques you use, you can't use them directly for the spatial data, okay? So there needs to be something done. And another thing is, like I said, it's very complex, and the complexity is very high. Okay, so your space complexity, time complexity will be very challenges, right? And another thing is visualization. How do you do visualization? So visualization actually is very important here, because when you do visualization of the spatio-temporal patterns, then the user gets an idea of what is going on. Okay, so all these are some challenges over here, and let us look at some of the spatio-temporal modeling tasks which are there. One is outlier detection, okay, which is spatio-temporal. Okay, we'll come to what we mean by spatio-temporal. Outlier detection is finding the anomalous pattern, or the pattern which is not normal, right? Second one is spatio-temporal forecasting. So you're trying to forecast the future data from the data up to this point in time. Then we have association rule mining, sequential pattern mining, clustering and classification, visualization. So these are some of the data mining tasks or the modeling tasks which we are going to be using. So first of all, if we come to outlier detection, we know outlier detection when we have applied it to non-spatio-temporal data, but in spatio-temporal data, what you mean is that you're trying to find objects which are, which is spatially and temporally close to each other, right? You're trying to find such data, and in that you're trying to take the non-spatio-temporal attributes and find out which is the outlier there. So that's the idea of outlier detection. Another thing is you have this terms like coupling. Okay, so if you have two objects which occur in close geographical and temporal proximity to each other, then you say they are sort of coupled. Okay, and telecoupling is when you have significant similarities between objects which are far away from each other, right? So that is known as the telecoupling. So then we come to prediction, spatio-temporal prediction. It can be done using classification, regression. Okay, so here this is an example where you have a city and you have the cab drivers going round, right? So here what you're trying to do is find the predict the driver's probabilistic destinations when he leaves from a place, right? So this will come under the spatio-temporal thing. Then of course we have spatio-temporal partitioning, which is so grouping similar spatio-temporal data items. Okay, so you are taking the points which are similar to each other in the spatio-temporal sense. Then summarization. So you find a compact representation. For example, here you have say something here which consists of a big document, right? So you're going to find the summary of a document. Okay, so that means you have a compact representation for the entire document. So that's the basic idea of summarization. Then spatio-temporal hotspots are regions where you have a large number of objects which are anomalous. Okay, so we know that this could be very useful. For example, if you're having a tsunami or something, and you find that there is something anomalous out there, you can go and you can see what is happening, right? So that is the thing. And like I said, visualization is very important over here. So you need to use some visualization techniques. Okay. So if you have a map or a photo, it allows the human analyst to perceive the spatial relationships among the patterns. Okay, so that will help. So here you have a map, and from the map you're finding out association rules between different variables, basically. Okay, so this is something with the support and the confidence. Okay, so it has a support of 5.9% and confidence of 55.7%, etc. So here in the spatial temporal data, you are finding the association between different variables, basically. So here, when you have spatial temporal data, when you have only spatial data, you'll be able to find the clusters, right? And these clusters actually move when you have the time taken into account. So the entire cluster will move, especially if you think of some clouds which are moving, etc. Right? So you have the question of moving clouds when you think of the spatio-temporal data. So then some of the predicates we should consider when you have objects is something like disjoint, meet, overlap, etc. Right? So here it's given like in 2D regions, this is what is disjoint, meet, etc. So you may have predicates which describe this when you're talking about spatial attributes, right? So in the topological thing, they're actually represented by a matrix of this kind, right? So if you have a matrix of this kind, so you're considering, say, object 1 and object 2, and you're saying that the boundary of object 1 and boundary of object 2 are not meeting each other, right? So that's why that will be phi, etc. So you can get a matrix like this. Okay, and if we consider a volume or a 3-dimensional thing, you'll get a matrix like this, right? So these are what are used. Okay? So you have things like during, at. So these are the temporal things during T4, T5, at T4, etc. Right? So then we have the spatio-temporal clustering which is done. So clustering is a standard technique which you're using. So usually spatial clustering is done using the dbScan algorithm, which is a density-based scanning algorithm, right? So I'll just leave it at that. And when you come to the artificial intelligence, you have logic, right? So you have logics which include time. So when you're including time, you have something like you will have one attribute here which will tell you something about the situation in which this occurs. Okay, so for example, occurs walk to John Station is between 1 p.m. and 1:15 p.m. right? So you have a time predicate which is there in every predicate. So that's the thing here. Then we have temporal modal operators, okay, tenses which will tell you what is present, what is over, past, what was in the future, etc. So these are the different logics that you have, right? And since and until, something like I will keep trying until I succeed. Okay, so these type of things also are some temporal thing. Okay, so there are ways of representing since and until, right? So they use S and U, etc. So when we come to, like I said, it's very vast, right? So scalability of your algorithms is very important. So we need to also consider the scalability, not only different ways of handling this thing, because if the data is extremely large, okay, so like we said, it's in the, it is in the like order of terabytes and petabytes, etc. So the algorithms have to be such that they have linear space and time, right? So that is very important for scalable algorithms. And what you find is that since most of the data is stored in secondary storage, the number of database scans have to be less. Okay. Another thing is that the algorithms for high dimensional data, okay, need to be different. Okay, so the algorithms which work for low dimensional data do not work for high dimensional data. So what you find is even the distance between points, if you use Euclidean distance, it doesn't work. So it's useful to do some type of feature reduction. Okay, so, or you extract whatever features are important, leave out the other features, etc. So doing these type of things is good, right? Feature selection, feature extraction should be done. So what are the possible solutions for the large data that you have and the type of algorithms you have to use? Okay, you can use an incremental clustering algorithm. Okay, example is Leader and Birch, which are some commercial packages which are there. So unlike k-means, you're not going to keep on going into the data, right? So as soon as a new point comes, you cluster it to either one existing cluster or you form a new cluster, depending on some threshold which you're going to set. Okay, then we can use a divide and conquer policy where you take all the data and divide it into blocks and use these blocks. Or you can use an intermediate representation of your data, okay, such that it's not so big, okay, and bring it down to a smaller size, which will fit in your main memory. So you have things like frequent pattern trees and other such things. And you can use parallel and distributed computation. Okay, so these are some solutions which we have for this problem, basically. Okay. So this is one method of the binary representation. If your data is in the form of binary, you can have a compressed way of representing that. And you have things like PC trees, FP trees, okay, pattern count trees, etc. Right? So these are methods of representation which is compact. It makes your data compact so that you don't have to store it in secondary storage. Okay, so Incremental clustering, I already spoke to you about, right? So it requires just a single database scan. Okay. And the time complexity is order of nk, and space complexity is order of k. Okay. In other words, you just store the k centroids which you're going to get, right? Of each of the clusters. You don't have to store the entire data. And time complexity is n times k. So this is actually much, much smaller than other clustering algorithms which we are seeing. And then we have what is called the single pass k-means algorithm, where you cluster patterns into, you just take a first block, okay, which consists of n1 patterns out of the total n patterns that you have, and find the centroids with that, okay, by using, say, k-means on that. And when you find the k centroids, you assign the other patterns to that. So you have things like Clara, which is again a package which is available for large data, and Cure. Okay, so these are some things which I just wanted to bring up. And divide and conquer means you just divide the entire data into blocks, right? So for each block, you carry out clustering, okay, and then the cluster representative. So you k representatives here, k representatives in each of these blocks, right? So if you take all these to the next higher level, okay, you're going to get k into p if you have p blocks, okay. So you have reduced the amount of data you have, and then you can carry out the clustering on that, right? So in this way, you're reducing your complexity. So that's the way of carrying this out. Okay. Next is feature selection. Okay, so feature selection means you're removing feature bottom. Okay, so there are three types: filter method, wrapper method, and embedded method. So the filter method actually looks at all the values in the training set itself and computes a score for that. Okay? So you have a number of methods like feature score, mutual information, etc. Right? Non-negative matrix decomposition, singular value decomposition. So all these are different methods of feature selection. Then we have the wrapper method, where you take the subset and you use the subset on a data set with the classification algorithm and see how well it does. Okay, so look at the efficiency of the subset or classification accuracy, try different subsets and choose the best subset. Okay, so for that, a number of methods are basically available. And we have the embedded method. So by the embedded method, what is meant is that the machine learning or data mining algorithm itself does the feature selection. For example, decision tree. So it leaves out all the relevant features. So you know that those have been weeded out and the others are the features which are selected. And neural network features which are going to be weeded out will have very small weights. Okay, so you can leave out those features. So these are called the embedded methods. Even things like random forest, etc. They use random forest to select the features. So for feature selection, you can choose by using random forest, because the links which are higher up will have more importance than the features which occur at the bottom of your tree. Okay. So this is just a sort of overview of the entire spatio-temporal work, right? Because of the very short time. Let me just summarize the whole thing, okay, which is important part. So we know that spatio-temporal data is very large, of the order of terabytes or petabytes. So we need to learn how to handle that large amount of data. Okay. And the second one is that the classical techniques which we have, that is all the classification techniques, clustering techniques, anomalous detection. We do have a lot of techniques which are available for non-spatial type of data. They need to be actually modified in some way to deal with the spatio-temporal data. And as of now, there are many applications. I showed you a few of them. Okay, and it's a very important area of research because it'll be very useful, especially things like looking at climate change, how the environment changes, trying to find the anomalous events like earthquakes or tsunamis, etc. Right? So if we are able to do these things, predict all these things, it's going to help. Okay. So there is a lot of work which can be done in this area. Okay, so it's a very open, active area, basically. So yeah, with this I will stop my talk. If there are any questions, I can take.
Thank you, ma'am. Participants are requested to post their queries in Q&A or raise their hands.
Thank you. Dr. Sushila ma'am, I have a quick short question.
Yeah.
Thank you first of all for presenting that very broad overview of all the techniques.
Yes.
That gives us a very good idea about what could be done in this area. But ma'am, could you also briefly tell us your own work that in this area and how can we deploy such, what are deployed systems or deployable systems that has impacted a lot of people and its application. So it'd be nice to hear from you. Yeah.
I think most of the yeah, could you introduce yourself? From where are you?
I'm a faculty in Amrita itself. My name is Rahul Krishnan. I'm a faculty at the center. Yes.
Okay. Yeah, so mostly I have tried to do a little bit on spatio-temporal data, not much, but I've worked a lot on time series data. So how do you classify time series data? How do you cluster time series data? And so a lot of work has been done on time series data, a little bit on spatio-temporal data, not much basically.
Okay. In time series data is very important, ma'am, because as part of a workshop, we are conducting this ML workshop for all the participants. So they are working on time series data and trying to model some very simple, create some very simple linear polynomial regression models, etc. So it'd be nice to hear some more details about time series.
The problem with the time series data is that it's a sequence. Okay, so you need to consider the entire sequence. It's not just single points like we have in other type of data. So you need to consider the entire sequence in that sequential way. And so what you find is that when you are trying to classify a time series, you need to compare that time series with the number of time series of different classes.
Hello? The voice audible or?
No, I think we have lost her. I'm sure, ma'am. Are we audible to you?
I think she may have to rejoin. Yeah.
Yes.
Hello, can you hear me?
Yes, ma'am. Now we can hear you.
Okay, actually I got disconnected for a minute.
Yeah, yes, ma'am. Yeah.
Okay, so what happens is that you try to see whether it's occurring above, how many times it crosses the, the average pattern of each class, whether it's occurring above the mean or below the mean. So number of such features are found. So what we have done is try to find some type of a fuzzy technique to classify a pattern as belonging to different classes, etc. And we have developed that further with some other. Another thing is that the usual type of distance between, time series does not work. For example, Euclidean distance. You cannot take the Euclidean distance because you're finding the distance between two curves, not 2 points, right? So you got to develop. You can find some. There are a number of different distance metrics which they use for this. So you need to consider those instead of using just the, Euclidean distance between points, etc. So this is just a very, a small introduction to what we have done, basically.
Okay. Thank you. Thank you.
Yeah.
Any more questions from the attendees? Okay, ma'am. I think we don't have much questions from the attendees. Thank you, ma'am. Thank you for joining us. Thank you for the wonderful topic
It
on
was my pleasure.
Okay, ma'am. Thank you.
Actually, it's a very short time, no? Like it's not enough to talk about it really. But anyway, I just gave an overview. That's it.
Okay, ma'am. Sure, ma'am. We will try to arrange another talk in some other sessions.
Okay.
Okay, ma'am. Thank you. Thank you for joining us. No, sure, ma'am. Okay, so let me invite again Dr. Rahul and Durga to take over the session to proceed with the MI workshop. Dr. Rahul.
Thank you, Deepthi. Yes. So, excuse me. Welcome back to all of you. So I hope all of you were able to run that code and get the output as expected. Can we get a raise of hands if you have completed that? You have uploaded and ran the program by yourself and got the output. Can we get a raise of hands? Can you please raise your hands if you have completed that? Just keep it raised for a minute so that we can understand. Okay, that's good. That's good. So many of you have been able to do that. You can lower your hands now. Thank you. Thank you so much. So now Durga will take it over from here and continue with the next part, next two parts of the code. Okay, over to you, Durga.
Thank you. So welcome back, everyone. Good afternoon to all. So I hope you're able to run the programs and is comfortable with whatever we have discussed till now. So let me share my screen. Okay, I hope you all can see my screen. Okay. So in the last section, we'll just have a quick recap of what we have done. So we had discussed about the data set. We looked into the CSV file of the data set. Then we later created a new Collab file, uploaded the data, and then accessed the data into the code using that CSV function. Then we have initialized two new variables that contain the output data as well as the input parameters. After that, we plotted the data to understand how each parameter is related to the to all other parameters, right? So that's where we left. Now, this, let's just so our problem was narrowed down initially. So we were going to see how CO2 or carbon dioxide concentration is related, or how its variance is affecting the temperature. So that was our initial question that we set out to program for, right? So now, just now what we'll do is we'll just take the this plot, that is CO2 temperature. So we'll just take these two, where CO2 will be your input variable and the temperature would be your output variable. Okay. Okay. So before we begin with anything, let's just plot the data. So this is also this also comes under the visualization of the data set. So let's just visualize the data, how the CO2 is changing over the year. So here we have taken a new variable which has the data, the year data from the data set. So this is another, this is where we use the matplotlib library that we initially discussed to plot the data. So this is where we are using that library. So this PLT is actually from the library matplotlib. So we are plotting a scatter plot. What is a scatter plot? A scatter plot is just plotting the every coordinates from the data, right? We are just plotting every coordinate as points in the graph. Okay, so we are doing a scatter plot where year is the x-axis and just the CO2 data is going to be the y-axis. Okay, so what we get from this is we see how the CO2 is varying, or how it is how its trend is over the years. Okay, that's what the first plot that you see here. Where, so here you can use while using matplotlib, you can use title to denote to give any title to your graph. You can use X label, which means labeling the x-axis. So when you label the x-axis, it is given here. Then you can also label your y-axis. Then to show that graph on your output console, you need something called plt.show. So this is the command that helps to output the data into this console, output console. Okay, so that is the components of plotting a graph, related to how you plot a graph. Okay, so here you can also use this data set here instead of giving it into another variable. So these are both ways in which you can plot. Okay, so in the first we plotted CO2 versus year, how it changes over the year. Now we'll also do this for the temperature. Okay, so we'll also do this for the output variable. So we'll plot year and y. So what did we have in y? We had the temperature, right? We had copied the temperature data from the data set into the variable y. So that we are plotting it across the years. Okay, so we can see that there are variation with respect to CO2 and temperature along the years from 1985 to 2008. Okay, now what we are doing next is visualizing how CO2 and temperature is changing. So here we saw how CO2 temperature is changing, but this was part of a larger plot, right? We had every feature against every other features. So just taking that plot of CO2 and temperature, again using the matplotlib, you can plot this figure also, where x-axis is the CO2, that is your input, and y-axis is the y variable, where you had the output variable or the target. Okay, and you can change the color. So this is for changing the colors. You can make it red, you can make it green. So there are a set of options of colors that is available with Python, and you can use them here with this library. And another thing is marker. So this is so in this plot you can see that the points is denoted by a star. So you can have different plot symbols. Maybe for this, if you give a O, small o, it will give you a point, a dot. If you use a upward sign, then you get it as a triangle. So there are many options for that. That's what is denoted by the marker. Okay? So here we are using the star markers and plotting the CO2 versus temperature. Okay, so this is the data set. So finally, this is the data set that we are going to train, fit, and do all the ML process with the CO2 input and the temperature output. Okay, I hope that is clear till now. Okay, now we go into the machine learning part of the coding. So first of all, machine learning part, we need another library called sklearn. So sklearn is a library made available in Python that supports the machine learning functions, building machine learning models, etc. So this is a library that is only for the machine learning commands and processes. Okay, so in this library you have a module called linear regression, which helps you to build the model. Okay, we'll go detail into what the model is doing there. Now, before we create a model and fit the data, before we do anything, so all of you must have used a function at some point, right? As coding any language, you should be familiar with functions, right? So in function, what do? You have to have the data in a particular format. Maybe you need a data in an integer format, or you need a data in the float format. So you need some format for your data while you are calling a function. Similarly, for doing with sklearn, you need the data to be in the NumPy array. So I believe you remember how we call the access the data. We used pd.readcsv, right? So PD is a pandas data frame. So from pandas data frame, we are converting it into a NumPy data frame so that it can be given as input into the model. Okay. Also, another thing I want you to see is here when we try to print the data set, when we categorize the data set into X and Y and copied the temperature and the other parameters into X and Y, we printed out the shape, right? We printed out what is the shape of X and what is the shape of Y. When we did this, we see here that for X data shape of the X, we had 308,7. So there are 308 rows and there are 7 columns, right? But when you see into the Y, you can see that there is a 308 comma. So we know that this is only temperature data and there are 308 columns, and this is just a single column. Sorry, 308 rows and just a single column, right? But at times it becomes a bit ambiguous to the model when we are training with just like this. So we'll have to reshape the data and say that this 308 comma blank is actually 308 comma 1. Okay, so these are the two things that we have to do. One is making the data into NumPy format, NumPy array format from the pandas format. And the second thing is shaping the array into a suitable format so that nothing is ambiguous or you don't land up with any error while making a okay. So that is what we are doing here. So with in this step, you are using y.numpy to make the data into numpy format, and then you are calling this within a reshape model np.reshape. So this is another function made available using numpy. So after the data is converted into numpy, we use a reshape function so that you get the data as 1, the row comma column as 1. Okay. So for y.array, when you run this, you get y.array as 308, 1. Okay, I hope that is clear. Please, if you have any questions, do put it in the Q&A. Okay, so this is this now the data is ready to be given as an input into the model. Okay, now we'll go into the model. What are we going to do with that? So the linear regression. So here we imported the linear regression model from sklearn library, and we are going to call that function, linear regression function, and save it into a parameter called regressor1, a variable called regressor1. Okay, so here we are just creating a model of linear regression. Okay, we are just creating a model of linear regression. Now, what are we doing? Trying to do here from the morning session? We understand that there is a line that we need to fit into the data set so that the line can give you the best possible fit, that it reduces the error, a line that can reduce your error to its best possible way. Right. So dot fit, what you're doing is you are fitting this line in the data that is given to you. So X array is the data set, X array is the input data. So the model has an input data X array. Now based on the Y array, that is what the output should look like. Based on the Y array, your linear regression model that you have just created is going to fit the line in the best possible way. That's what dot fit is doing. Okay. So first we imported the library linear regression, then we created the model, and then we are using it to fit into our data. Okay. Okay. So I hope it's clear till that. Now, after fitting the data, so after fitting the data, you will have a line that can fit the data in its best possible way. And now, after doing that, you're going to see how well can it predict after the model has learned this line. So the model learns means it has learned some parameters of or coefficients of this line that can help you to predict any new value. Okay, so using dot predict, what you're doing is you are getting an input, and with whatever the machine has learned, so with whatever the machine has learned, you are going to predict what the output will be. So here the data is considered as a new data where the model doesn't know what the Y will be, and with predict, you are going to predict the Y value for the given input. I hope that's clear. Okay, so now let's see how well the model has learned and how it is predicting. Okay, so for the plot, we have X array. So first we are plotting whatever is the given data. What are we training with? Whatever the data we have given into the model to train it. Okay, so X array and Y array were the variables that were given. So this black points shows the actual values, right? The actual values of temperature with respect to CO2. Now, so we have using the model, after letting the model learn, we are predicting the value for the variable X array, right? So now we are going to take that X array and see how well it is predicting. We are plotting the predictions against the actual values. Okay, so that is what this cyan color dots points are representing. So this cyan color points is your predicted value. So you can see that it's actually sitting well with the training data, the actual data, right? So this is how we visualize how the actual data and the predicted data, how well the actual predicted data follows the actual data. Okay. Now, so with this, we are able to see how well it is. It sits with the predicted value sits with the actual data, right? But just like the example that we discussed in the morning, where we discussed a scenario, right, where a person is trying to see whether he has gained weight or lost his weight. So he might go in front of a mirror and use it to evaluate himself. Seeing the mirror, you may say that, oh, I have gained the weight or I have lost the weight. But to get that actual value, to say how much weight you have lost or how much weight you have gained, you need some parameter to quantify that data, right? So that quantifying the data is what we are trying to do with the performance analysis. Okay. So visualizing is kind of saying with the mirror whether I have gained the weight or lost the weight. I am just getting an estimate of how well the what has happened and how well it fits. That's what visualization is helping us with. Okay, but to quantify, to say in a statistical method what the data is, how much error there is with respect to the actual and the predicted, we need some kind of performance analysis. Okay, so that analysis, it's what we are doing the next step. So here we are using mean absolute error. So what is mean absolute error? It is the so error is actual minus predicted. Right, error is actual minus predicted. Then we are figuring out the absolute value of that error. That is, if it is -3, then we take it as 3. If it is -6, we take it as 6. If it is 6, 6 itself. So we are taking the absolute value of each error computed, okay, and then calculating the mean of that. So that's mean average error. So we are calling the function. So this mean average error is available to you. Again, you say from the sklearn library, and you are calling to compute that. So you are calling the function mean absolute error to compute what is y-array. It's the true or the actual value that you have with your data set, from your data set. So you have the actual value and the predictions. Predictions is what you have got after the model predicts what its value will be. Okay. So you are calculating the error of actual and the predicted. Okay. So this round is just rounding of the whatever mean absolute error you get. You are just rounding it off to place of 3. Okay. So that's with the performance analysis part of the model that we have just built. So I hope you are clear with this. Just to give a quick recap. So first we take the linear regression, we import the linear regression model from the library. Then we reshape the data and make it ready to be given into the input into the model. And then we create a model called linear regression, and then we fit that model into the data x-array, y-array. So this becomes the input x-array, y-array. So we know what the input is and what the output should be. So with this, the model learns something, and we are going to see how well the model learned by just giving the input value. That is just giving the CO2. You are going to ask the model to predict what will be my temperature if this is my input. Okay. So now you have the actual value of temperature and what the model predicted for you. So you're going to plot this actual and the predicted, and that's what you see in this graph, where the actual is the black points and the predicted is the cyan colored points. Okay. So one more thing to get this line, actual, observed, predicted, you use something called plot.legend. So that's what you use to point out what each of the points means, what the colors, what the point means. Okay. Okay. And after this, after visualizing whether the fit is a good one, whether it's actually following the whether the predictions it's actually following whatever is in actual, whatever is given to you in the data set. After that, we quantify it and we say how much error there is by using a performance analysis. And here we are using mean absolute error. You can also use mean squared error, as we discussed in the morning session. And that code is also given. You can also run that. Okay. So this is the overall idea of how to create a model, build it, and predict with this. Okay. So I
Okay,
hope.
thank you, Durga.
Yeah.
There is a doubt. There are a few questions.
Yeah.
Selsha asked, why do we use square and absolute in the error part?
Okay. So here, I hope it means you're asking why you
Okay,
are
I think he got the answer. He says this is okay now.
Okay.
Another question is not clear on how the best fit is saved. Is that also clear, Selsha? Okay, I think that's okay.
Okay.
Yes, okay. Then Pooja Soni asks, which quantitative measure to use when?
Okay, so I think the question is, when do you use MAE and when do you use MSc?
Probably, yeah.
Okay. So to answer that, both of them are some kind of performance analysis. So what to use it depends on what kind of data set you use and how much error can you tolerate. So here, if you are presenting this model to someone, you'd say that the model is able to predict with an accuracy of, or with an error of 0.092 plus or minus 0.092. So what mean squared error does is it is squaring the error, right? So mean squared error means you're taking the error and squaring them, squaring the error and then calculating the mean. So when you square the error, even the smallest of the error gets amplified. The small errors will be taken up and amplified. So whenever so if you need your model to be very accurate and very specific, you can use MSc. It is based on how your data set, understanding of your data set and which scenario you are applying it. So that would be my answer.
Okay, and then Pooja is asking a follow-up question. Can this error be made zero? Can error become zero?
Ideally, yes, it can become zero. But like a rule of thumb with machine learning, it is very rare to get a 100% accurate machine learning model. You don't usually get a 100% accurate machine learning model. Yes, it is the ideal thing, but you don't. So there will be some kind of error with respect to any machine learning model. So yes, so there will be a kind of error. So that's what you say. So when you present a model, you say that this model has this much accuracy and it has a tolerance of, or it can vary within this range that we find out. It can vary with the 0.092 degrees plus or minus.
Okay. Another question from Arjun Dinesh. On what basis are we choosing different regression models? We didn't discuss different regression models yet, right? We only discussed linear, right?
Yeah. So this exercise is actually just to get you started with machine learning.
Yeah. So yes, Arjun. The answer is that it basically depends upon that plot. Durga, if you can scroll up a little bit and show Arjun. Yeah, see this plot, as you can see, it's not a good fit with the line. I mean, it's a okay fit with line, but it has a drop little later on. So you have to analyze based on the data and then figure out which regressor to use. But see, Arjun and all others, one of the major things that you had to note here is, in order to teach machine learning, this is just a first step, right? In order to do that, we selected a very simple problem with only one feature. One feature is CO2 concentration, right? Now, that's not how usually machine learning is applied on. We will be using multiple features. So in that case, if you have more than 3 features, you cannot really visualize it like this. If this is 2-dimensional. When it comes to 3-dimensional, we can visualize. But 4th dimension means 4th feature onwards, we won't be able to visualize it. So in that case, we cannot choose a regression model based on visual analysis. we have to depend upon the evaluation. Evaluation is what Durga mentioned, using mean absolute error, mean squared error, etc. I hope that question is kind of answered. Pooja Soni asked, what happens internally when regressor is called? I think, Pooja, what happens is what we discussed in the previous theory part before the lab started. It creates a primary line. Preliminary, it creates a line, and then it tries to change the m value and c values and figures out which line has the least cost. So that's what happens when you call regressor.fit initially. So I hope that answers that question also. Okay, Durga, I think that's it with the questions.
Okay.
They can go ahead and
yes.
do the.
So you can find this code, this part of the code, the linear regression, in that link given to you in the morning. Go to that, and there is the code is in part 2 of the codes available to you in that site. So take that part 2, and you can copy paste that code into whatever you have done previously. You can just plug the second part into whatever you have done in the morning and run the code and see whether you are able to get everything right and work it out for yourself.
So we will give 5-10 minutes for all of you, each of you. We really encourage all of you to actually do this exercise, because machine learning cannot be understood by just listening to theoretical lectures. So you have to definitely try this out and try out the code, run the code, at least get this first output, and then start playing around with the code. I request all of you, each of you, to do this. Durga, we have one more question from Danesh.
Okay.
This mean absolute error value is the minimum error, is the same as the loss function. Yes, Danesh, this mean absolute error that you are seeing as reported in the code is the minimum error. That is the best fit. The line is fit best on this data. And what is the error in that case? Is this the same as loss function? In this case, yes, it will be the same as a loss function, because modeling is to reduce the error in terms of temperature. So that will be the same as loss function. Okay, I think.
Okay, they can. I think now you can work with the second part of the code. And again, once you have finished, please raise your hands so that we get an idea.
Durga, can you share that website screen as well?
Screen, okay. Just a minute. Okay. This one, right?
Yeah.
Okay.
So any questions, please feel free to ask us on Q&A, or just raise your hands and please let us know any queries, any questions that you have while implementing this, while uploading this, etc. Okay, some of you have already done it. Those who have completed, can you do a raise of hands in Zoom? You can press raise hand at the bottom of the screen, and then we'll get to know. Okay, thank you for raising your hands. We have one more. We have one question. Durga, the question is, how do we interpret the MAE value? So, that mean absolute error value, how do you interpret it?
Okay, so mean absolute value error.
I think your screen is not yet shared. So
Okay, can you? I hope it is okay now. Okay, so mean absolute error, what it says is, you again let me just take the data set. So there that is given to you, right? For every CO2 value, for every CO2 value, there is a corresponding temperature that is given to you, right? So you know what the actual temperature is, right? So after you make a prediction using the model, so the model has learned something from the data that is given into it. Okay, so after the model learned from the data, it is going to predict points using just the input. So whatever predictions that we get is just based on the model. So it doesn't, so it is whatever the predictions is given is what the model learned from the data given. Okay, so what we do with MAE is we are calculating the error, that is how much the model was able to learn from the data that was given to it. So from the prediction, it would understand from the prediction and calculating how much prediction is deviating from the actual temperature value, how much the actual temperature value you have. So how much the predicted value is deviating from the actual, you are able to understand how well the model has actually learned. Okay, so in an ideal situation, the error would be 0. That is, the model has completely learned the data, learned a perfect model from the data, but that usually doesn't happen. So there will be a minor error. So with this error, what you try to do is, you are going to, so in some application, maybe a plus or minus 1 error will be okay. It will not mean too much. Okay, but in other application, even a 0.01 error would mean it would be very high error for that application. So the mean absolute error is also application dependent. So what you're actually trying to find out with this is how much of a deviation the prediction has from an actual value. And it also, yes, the mean absolute error, how far it can go or how much error can you tolerate, again depends on your application, whatever application that you're using it for. I hope this is.
Yes, that's a very good point that you told, Durga. Yeah, so it's very much application specific how to interpret it. So I think all of you who have done this has done a good job, and you have actually reached till the implementation of linear regression. Now, in the next part, let's go into polynomial regression, right? And its visualization. So let's next let us do that. Do a hands-on after that. Yeah. Over to you, Durga.
Okay. Okay. Thank you, Ata. So now we'll go into the polynomial regression. Okay. So we have in the morning session we have looked into what a polynomial regression is. So with a linear regression, you were trying to fit a line. So what is a line? A line is degree 1, right? In maths, we call a line of something a degree 1, right? So in the same way, if the polynomial is of a degree 2, how well will it fit the model? That is, you're trying by polynomial regression, what you're trying to do is you're finding which degree of a polynomial can help to fit better with your data. So let me just pull something. Okay. Here in the graph, you can see that a first degree, it's a line. A second degree, it's a parabola. So it can, if it is a negative value, then it will be an inverted parabola. And third degree, fourth degree on, as the degree increases, the curve also. So with the polynomial regression, what you're trying to do is, maybe the data, so in the CO2 itself, you saw that till a point as it is showing a linear trend. But after some point, it's showing a dip, right? So after this point, till this, it is okay. Till this point, okay, you can work with that, with a linear regression. But after that, you can see that there is a downward trend. So maybe another degree, introducing a curve or another degree of polynomial will help better to fit the data. Okay, the model into the data. Okay, so that's what we are trying to achieve with polynomial regression. We are trying to see if a curve or a increasing degree of a polynomial function can help to better fit the model into your data set. So that is what polynomial regression is about. Now, again, let's see line by line of how we do that. So again, from have something called polynomial features. We'll see why it is required. So what a polynomial feature does is, it takes a feature. Let's say x. X is a feature that you have. Okay, so if I say that I am going to fit a degree 3 polynomial, then it's what it means is you are going to find all the values between 0 to 3. That is x raised to 0, x raised to 1, x raised to 2, and x raised to 3. Okay, so from just one feature, you are generating more features. Okay, so polynomial features is actually generating the polynomial features corresponding to the value that you're giving. Okay, so that is what polynomial feature degree 3 does here. It generates more features depending on the degree that you gave, that is specified. Okay, now you have the features. Okay, if I have stated that you have to find x raised to 0, x raised to 1, x raised to 2, and x raised to 3. Okay, now how do I apply this polynomial features into the data set? That is, I have x that is CO2 data set here. So in the CO2 data set, how do I apply this? For that, you use something called fit_transform. So with this, you transform the data according to the features that you get by specifying the degree of the polynomial. Okay, once more, so by using transform, you are transforming the data X array, whatever you have given as input, based on the polynomial features that you got by specifying the degree of polynomial. Okay, so with this, So let's see how it transforms the data. So you know that X array is just CO2. So it should have a shape of 308,1. So we print this, we can see that X array has a shape of 308,1. Now let's see what is the shape of X array underscore polynomial transform data. What is the shape of that? So there you can see that it is 308,4. So where did this 4 come from? It came from transforming the data. That is, it is calculating every degree with just that one feature. Okay, so it has a 4 columns based on the transformation that we did with the polynomial features. Okay, I hope that's clear. So for a polynomial model, this will be our input. So we are working around, we are processing our data so that it can be given as an input into a specific model. So that's what we are doing till now. We are transforming the data and making it ready to be given as an input into the model. Okay. Now again, the function that we use for polynomial fit is the same. We use linear regression itself. The change is just that we are giving, while fitting, we are the data that has been transformed. So you transform X array and that transform data is given as input. Now you can see that we have not transformed Y array, right? Why do you think it is? Because Y array is what we are trying to predict, right? When you are trying to predict something, you don't change or mess up with that. What you want as output. You cannot change the output. You can just understand what input can give you that output. So for that matter, we don't touch the Y array. We don't transform Y array. We have to know what is needed or what should be the output. So the transformation is done only to the X array part. That is the X data set without the target, without the output variable, just to the input value. Okay. So here, while fitting, again we fit with the X array polynomial transform feature, and then comma the label. Okay. Now after that, again the step is the same. We predict what do we get with the model, how well the model has learned. We predict using the model, and again we visualize it. So visualizing, first we plot the training set, that is X array and Y array, and then we plot the predicted set, that is predictions, and we can again see that the CN curve, the points form a curve that better fits the data than what can be observed from the linear, right? So the linear did not consider this drop in the data, but when you fit a curve into that, you can see that it follows, the predictions follows the actual. So it is a better fit to the model than the linear, just fitting a line. Okay. So this is how by just increasing the degree, we can use to fit it on a non-linear data. Okay, so we can fit a curve here rather than just seeing the data as linear. We can work with this non-linear kind of data and fit a curve into that. Okay, so that would be the demo on polynomial regression. Again, we are printing the MAE, and with MAE, you can see that it is 0.085. And earlier it was 0.09, if I'm not wrong. Yeah, it was 0.092. So it has actually come down because the features are better represented using the polynomial model. I hope that is clear. So again, I will also let you do this part first. Just the polynomial. So since you have done the linear, this should not be much of a problem. You should be able to do this pretty quick. So we'll take 5 minutes and let you do this till this. So this would be the third part of the code in the site. Please copy paste and run for yourself and understand that.
Yeah, can you share the screen with the website?
Yeah. So yep, part 3, polynomial regression.
Yeah, part 3 polynomial regression. That's the code you had to do. Yeah. So Durga, there are two questions, or probably it can be clubbed into one.
Okay.
Vidya ma'am is asking, we have to choose the model based on data. Is it like that? How we will know which model we should select based on the data?
Okay.
So maybe I can give it a try.
Yeah.
And you can fill in if anything is missing.
Sure.
So the idea is that definitely we have to choose the model based on the data. So as you saw in the example that Durga was demonstrating, if the data is not following a linear trend, you will have to select a non-linear model like a polynomial regression. But as I told, we are only considering one feature here in this example, just to make things simple and clearer in terms of explanation. When you add more features, their relationship will definitely be non-linear. That we will have to. Sorry. So there is no particular rule that if you have this data, you apply this. We cannot 100% say like that. Primarily because some of these problems are very so you will have to try different models, different, if it's regression, not just polynomial and linear, maybe support vector regression and decision trees and things like that. We may have to try. So it's more or less trial and error when we start working on machine learning. But as we use multiple data sets, multiple models, we'll get a hang of it and we'll understand. Maybe something is not. That's how I would go about doing it. Mridula has a question. What do you mean by this error? Error is basically the difference between the predicted and the actual. So in the graph that Durga showed, the error is the distance, the y-axis distance between the cyan color line and the black dot. So if you take any point on the x-axis, if you draw a direct line directly to a cyan line, and then from cyan line you measure the distance on y-axis to the black points, perpendicular distances, that is the error.
Rahul?
Yeah.
Sorry to interrupt. I think she is pointing to a specific error which she got. She had posted that in the Q&A.
Okay. What correction should I do? Oh, okay, Mridula, we will come back to that. I think, yeah, you posted that error earlier and then we didn't address it before the lunch. We lost that question after we rejoined after lunch. I'll come back to that, Mridula. One of you, Tom or Lakshmi, one of you, can you take a look at Mridula's error?
Yes, sir.
Yeah, thanks. Pooja is asking, it's the Euclidean distance. Yes, it's the Euclidean distance. Basically, you are measuring the distance in the y-axis. Yeah, that's true.
Okay. So once
again,
more,
yeah.
Please go ahead. Please go ahead.
No, I was just encouraging everybody to try it out. The code, although it may look a lot, as Durga explained, once you run it and go through it line by line, few times, you will understand what's happening. That's how we learn coding and machine learning. Multiple times, only then we will learn.
Okay. Okay, so if you have completed till the polynomial regression, please again raise your hands so that we get to know.
Yeah, and please keep the hands raised till we say to lower, because we would like to know from among all the attendees, how much each of you are able to understand and able to do hands-on. So please keep it raised till we say to lower. Thank you so much. For some of you, I would like to reiterate one point. So every time, let's say you close the Google Collab and open it, or you're creating a new Google Collab or uploading a new Google Collab file, you'll have to upload that climate_change.csv file once again, because that file stays in the Google server only for some time till you close the tab, or if you're inactive and not doing much in Google Colab, that'll automatically get deleted. So some of you may be facing that error. So you'll have to upload the climate change.csv file if it's not present. Okay, one question from Pooja Soni. Polynomial features degree equal to 3. What does this degree mean? Pooja, it basically means that you are taking, so the only feature you are taking is the X, which is CO2, right? So CO2 values from 1983 to 2008. Now, those values, we are converting those values into its first degree, 0th degree. 0th degree means everything will be 1. First degree means the whatever value is currently there. The second degree and third degree. So you square it and then you cube it. So the idea is that the relationship between X and Y is not linear, as we saw in the graph. So maybe if you square the X, then it may be giving you a good relationship. So that's why it is, that degree equal to 3 is put there. As you said, yes, expression for fitting curve is cubic. Does this mean that? Pooja, yes, it means you're going to fit a cubic curve. That is true. But in this case, you are using all the 4 features. If you look at the code, you are fitting X array underscore polynomial, X underscore R underscore poly, which means you are using the entire that polynomial features, all the degrees. One thing, Pooja, what you can try, and others also what you can try is, just use the third degree alone or second degree alone. You can use .iloc and then do the same exercise. It'll be a nice way to explore the code also. Okay, once again, announcement. If you have finished doing this exercise, please raise your hands and keep it raised Okay, thank you all for raising your hands. I think a considerable number of people have done the exercise. Very happy to see you all participating so actively. So we'll take a 5-minute break. So it's 3:45 now. So we will meet at 3:50. Just 5-minute short break. Please take off from your PC and take a short break. Once we come back, we will cover one more lab on very important subject on train test splitting, very important in machine learning. And we will do we'll do 2 more lab exercises like this before we wrap. Okay. Thank you all. We'll take a 5-minute break. Please stay online. So thank you.
A university where future is driven by imagination. Experiential learning creates diverse opportunities, where industry exposure and international partnerships help you sail. Come, start your journey towards success with Amrita University.
Hey guys, are you still searching for the right master's courses? Then stop. Your search ends here. Center for Wireless Network and Application, Amrita Vishwavidyapeetham has opened its admission. You can be eligible for scholarship also. If interested, you can apply using the link in the description box.
Hi, I am Akshay Sadish, MTech Geoinformatics and Earth Observation student from Center for Wireless Networks and Application, Amrita Vishwavidyapeetham. My research area is in the coastal change detection using satellite imagery. Recently, in one of the symposium organized by the center, I could meet up delegates of ISRI India and discuss my research work with them. They were interested in my work and offered me an internship. Now, I am working with ISRI on GIS and remote sensing to estimate the coastal erosion rate. I am happy that I am contributing to some of the UN Sustainable Development Goals. I thank my faculty and staff members at Amrita WNA for supporting me. Thank you.
Center for Wireless Networks and Applications, a cutting-edge research center at Amrita Vishwavidyapeetham, offers MTech and PhD programs. The center has the following state-of-art laboratories for researchers and students. India's first landslide simulation laboratory, and our contributions have resulted in the design, development and deployment of the world's first wireless sensor network system for landslide monitoring and early warning. This lab serves as a test bed for developing and varying the conditions of the systems that we intend to deploy in the landslide-prone areas. These are the advanced equipments we use for testing soil and rock samples brought from the field. Their geotechnical properties are tested based on international standards. Keysight Technologies, a global leader in electronic measurement equipment and design tools, have collaborated to establish a state-of-the-art advanced wireless communications lab. This is one among the very few such labs found in Indian universities and has equipment valued at several crores of rupees. Smart Grid Lab targets distributed multi-scale smart networks which facilitate the integration of low-cost real-time monitoring and control devices into the grid. The lab serves as a test bed for students and researchers where they can plug in their modules and validate using the real-time data visualization tool. The lab also supports validation of renewable energy systems that are developed for rural electrification projects. This lab provides an experimentation platform for developing low-cost educational technology platforms. This lab hosts a variety of tools, including a host of specialized depth detection (PTZ) leap motion devices. A perfect platform for architecting a next-generation classroom system using computer vision algorithms such as gesture detection, participant localization, etc. This lab will provide students practical experience in designing, deploying, and implementing wireless sensor networks in both indoor and outdoor conditions. Remote users will have a permanent test bed for development and testing of concepts. This lab includes 12 experiments demonstrating these concepts by providing study materials, animations, interactive simulations, and a remote panel. Hardware lab of Amrita WNA serves the students and staff for their research and development. The lab has various types of tools from Weller, Taperia, Fluke, Freemans, Dremel, Bosch, Mecco, etc. Nearly 50 different tools can be found here. Our MTech programs.
Okay, welcome back everyone. So I hope you took a break. Okay, so I assume you have been able to do everything till now, the linear regression and the polynomial regression. I can see one hand raised. Is it a doubt? Okay. Okay, I think it's not any doubt. Okay, so now we'll continue with our session, with our demo session. Let me just share my screen. Okay, so we have seen a linear regression and logistic regression till now, right? So now let's take it one step further. Okay, let's just understand what we have done. So when we trained the data, when we created the model and trained the data, we trained it using, we trained it using X array and Y array, right? Let's just take the example of linear regression to keep it simple. Okay, so here when we train the model, we gave the input X array and Y array, right? So the model already takes the data X array and Y array. It learns from that data. Now, when I'm trying to predict, what I did here was we predicted it with X array itself. So X array is a data that the model has already seen. So model already was built and learned from the X array input. So when we try to predict using the same X array, it might create a bias. It might give you a good output. because the model already know that data and it know how the output is going to be like because of the Y array that you have given while training. Okay, so to avoid this, so it's kind of similar to the scenario of writing an exam. When you write an exam, what do? You prepare on a material. So you maybe you have a text of your own, and you have this text, and you learn from that. You learn your material. You learn from that text, and the exam paper, the exam questions is only given to you at that point on the examination day. At that point, right? It's not given to you prior or while you're preparing for the exam. It's only given to you at that point. It's the same kind of idea. It's a similar idea with what I'm talking about now. Okay, so here you have a data set which is used to learn, or build the model. Okay, now if I use the same data set to predict, it already knows the questions beforehand. So in this scenario, you have to give a new data set if you really want to analyze or evaluate the performance of how well the model that you built is. Okay, so to analyze the model better, to evaluate your model better, what the usual practice with ML is, we train with the data and we test with another set of data. Okay, so that's where we want this train and test separately, a train test split. Okay, now in our case, we only have one data set, right? We only have the data set called the climate change. We only have that data set. So without having another data set, with whatever we have, just with whatever we have, how do you split the data? So what you do is you take a major chunk of a data and use it to train. You just keep aside a small part. You just keep aside a small part from the data set that is available to you or that you are working with, and do not use it for training. Okay, you're just keeping aside a set of data from the master data set and keeping it aside. You're not using it to train your model. Okay, so this is achieved by a train test split. So you train with one set of data and you test with second set of data. One thing you have to be careful here is always the training data set should be of a higher size. The division must give you a majority of data in the training set and a minority in the testing set. Because if you don't have enough material to learn from, whatever question you give, you're not going to be able to answer it well, right? You can only answer it if the questions are within your syllabus. So you have to have data enough for training. So here what we have taken is, so again, there's a train test split function that is available with sklearn. So we are using that function, train test split, and you're giving what data should you split. So you have an X array that has a CO2 data in it. You have an X array, you have a Y array with the temperature value. Then you have test size equal to 1/3. So what is this? You are take from the entire set, 1/3 of its portion is going into a test set. So let's say 30% of the data you're setting aside to test, and the rest 70% of the total data you're going to train with. Okay, so that becomes your training set and this becomes your testing set. So always be careful that the training set is higher than the testing set. You can have a 60-40 or a 70-30 or a 80-20 split, but be careful of that. Okay, so now after we test, we keep data aside to test. You can also see that there are a few parameters here, right? So you are taking both X and Y and then splitting it into train and test. That's why there is X train and X test based on CO2 and Y train and Y test based on temperature. Okay, so I hope it's clear why we use a train test split, so that the model does not model is predicting a data that it has not seen before, so that we can accurately tell how well the model is performing. That's why we use a train test split, and we train test split. We use the function train test split with the input data. You give what are the data that you are going to work with, X array and Y array, and then you specify the test size. How much portion of the data are you assigning into as testing set? Okay. Now let's see how whether this has been successful or not. So you print out the shape of X-train, X-test, Y-train, and Y-test. So you can see that you had a total of 308. So 205 rows goes into the X-train, and its corresponding Y-train goes in corresponding Y value goes into Y-train. Similarly, you have 103 as test set, and the corresponding Y goes into the Y-test. Okay. So I hope the split is clear. What X-train, X-test, Y-train, Y-test is clear. A testing data set and a training data set. These terms are clear. Okay. With this, let's see how the data looks like. So you have CO2 versus temperature graph, right? So how does this X-train and X-test look like? So you can see here in the graph, the blue points are the testing data. So from the data, the testing points are random. Other is the training. The red belongs to the training data. Okay. Okay. Now that we have the test set and the train set differently, let's again see how do we predict, or how do we train our model with this new data set after train and test split is done. Okay. So here we'll again take the first example, the simple example of linear regression. So we have a model initiated as linear regression. Then we fit the model into the X-train and Y-train, not to the X-array and Y-array, but to the X-train and Y-train. Okay, this is where the change happens. So here the model only sees the training data set, X-train and Y-train. Now, after the model has been fit with this, you are using this model to predict X-test. So this X-test, the model has not seen before. So the new data X-test is given into the model and asked to predict the temperature corresponding to that. So that is saved into predictions. Okay. Now you can analyze how it looks like. You can visualize what it is. So you have plotted X-train and Y-test. That is actual value of the X-test. What is the actual temperature with regard to the X-test? So you have plotted that in black, and you plot what is the predictions corresponding to the X-test. So that you give in cyan color. The predictions are in cyan color. Okay. So one thing you can, and you again calculate the MA. So one thing you would notice here is the points are very few with respect to the modeling that we have done earlier, right? Actual and prediction. So if you think you'll get the answer, why? Why? Because you are splitting the data, right? X-test and X-train. So you are only predicting on X-test. You are not predicting for the entire data. So the data points are less. You are only going to predict for X-test. So that is only 103 point of the entire data set of 308 points. So you only have 103 points here. Okay. So only that many predictions would be done. Okay. I hope that is clear. Now we'll just also cover for the polynomial regression. So the idea is same. We are not created an X-test and Y-test. So yeah, you are going to use the same X-train, X-test, Y-train, and Y-test, and we are going to predict for the polynomial regression. So here one thing that you have to see is we are familiar with this polynomial feature. What does it do? It creates the polynomial features with respect to the degree that we have specified. So here we have given a degree of 3. So it creates, it generates the polynomial features with respect to that. And we have seen that we transform the input data using this polynomial features, right? So here one point that you must notice is for X-train, we have put a fit underscore transform. And for transforming the test data, we have used just. So a question my error is why this is different. Okay. So here, when you use the fit transform, the model actually learns from the transform, how the data is transformed, its statistics, its mean normal. So the model actually gets to learn when you're using a fit underscore transform. Okay. But by just using a transform, the model does not see into the X test. So don't use a fit underscore transform to X test, because again, the model will see the X test values then. So use a fit underscore transform to X train and just a transform to X test. Okay. So in that way, I have created two transformed X test and X train. Okay. So you have to transform X test, because the model has to have, the polynomial regression model has to have this many input, because it is trained on that data. So it's trained on a data that has 4 features or 4 columns. We saw, right, when we generate a degree 3 polynomial and fit it, we have seen earlier. Let me just take it. Yeah, we have seen earlier that this data is transformed into 308,4 belonging to x raised to 0, x raised to 1, x raised to 2, x raised to 3, right? So the model input data has to be in that format. So you need to transform the X test. You cannot just input the X test. It will give you error. You have to transform the X test. Okay. Okay. Then the rest of the procedure is the same. You fit just using the train. You use X train and Y train, the transformed X train and the Y train, and then predict using the X test, the transformed X test, and then analyze it, visualize it using X test and Y test. That is the actual value that has to be that what we are aiming for, the actual value of temperature with respect to the CO2. And then we have the predictions. That is what the model is able to predict from whatever it has learned from the training data set. Okay, that predictions are given here. Okay, so here again we have a lower accuracy, sorry, a lower error. We have a lower error, that is 0.085. Okay, but this ensures that there is no bias in the input value. When you are trying to predict it, the data set is not seen by the model beforehand. So this is a important concept of machine learning on how understanding on how to train and test a data. Okay, otherwise you might even get an accuracy of 100% if you are going to train and test on the same data set. So you have to get this split of train and test so that you are able to evaluate your model better. Okay, and again we are calculating the evaluating the model MSE and MV. Okay, so I leave this with that. So you can again go to your go to the site and you can see the part 4 of the code. I hope it is clear. You can go to the part 4 of the code and try to do whatever we have discussed till now.
Yeah, so I will I suggest that all of you try it out. Go to part 4 of the code in the website. Please run it from the start itself, because since it's an IPython notebook, all the outputs are already run and then kept. You can go to start, on the top menu, you can say run from start. So it'll basically refresh everything and then start, and make sure you get your own results.
Yeah, I'll just show that.
Yeah.
Okay, so you might, there might be a message that the session has timed out or something. So what you can do is, here in the runtime, you can see there is a file, edit, view, insert, there's a runtime there. So go to the runtime and just do a run all. That will, you need not go to each cell and run it again and again. You just, you can just do this, run all.
Okay, so all of you can try it out. We have few questions. Pooja is asking, what does random state equal to 0 mean? Pooja, I think Durga explained a little bit on that. when you are trying to pick out a train test split, when you're trying to make train test split, how do we select which should be in training, which should be in testing? So for that, the program internally uses a random number generator in order to pick out which of these should be selected. So to make sure that every time you do this selection, you are picking up the same same training or testing data, for replicability of this result, we use the same random state. So you can put any number there. Random state can be 7, 9, 99, whatever you want, but that is for replicability of the results. So if you want to display this result to somebody else, let's say you got an accuracy of or error of 0.1 when you ran once, and in another machine when you another time when you're running it, you're getting 0.8 as the error. Now the random state might have changed. So in order to fix the random state, you keep the that argument, random state equal to 0. I hope I answered that. And one more question, follow-up question. Didn't understand the need to transform from Pooja. Durga, I think the question is related to that fit and fit transform and transforming the test data set, if I'm not wrong.
Yeah. Let me just take it. So I think question is for, just like it told that it might be of X-train and X-test and why we need to transform both. Okay, first of all, why we need to transform if it is not just specifically to the X-train or X-test, why we need to transform is, we discussed it before, that is, once we have specified the degree, the features are generated in accordance to the degree that we specify, and the X-train, whatever the training data set has to be transformed, that is has to be fit with that features that is generated by specifying this degree. So that is the basic need of why we need to transform the data. This is just regarding polynomial regression. As you had seen with the linear regression, we did not need this transformation, but for polynomial regression, this is needed because we are working with a degree that is greater than 1. So we need that. That is basically why we need to transform. And if the question is specific to why we need to transform both X-train and X-test, well, X-train is what we have just explained. X-test is because the model has been trained on data that has 4 features, 4 columns of data. So if I just input a data of just 1 column, then the model has not seen that data. The input size that the model is familiar with is not that. So it will throw an error. You need to have the same size for your test data, whatever you had with the training data. Both the size of the test and train should be the same. Otherwise, you will end up with an error. That's why we need to transform the test. I hope that explains.
Okay, and one more question. Hridaya ma'am is asking, so before doing these steps done so far, that is in program, first we have to divide the training data and test data, then plot line or curve, etc. I think, I don't know if it's a question or a comment. Yes. So see, in this workshop, we want to cover step by step. That's why we covered it like this. Now that you know what is training set, testing set, etc. Whenever you're building a machine learning model, you have to do a train test split, and then come to model building and then testing it. So that's how you do it. Do you have to plot line or curves only on the train data set? No, you can do it on the entire data set, because you're basically trying to analyze the entire data set. So you can do it on the entire data set itself. Selsha is asking, is this a way of checking for skewed data? I didn't understand the first part. Is this a way? Probably you are talking about train test split. A train test split is not used to check for skewed data, because if you have a skewed data, you know about it, right? Skewed data means probably you are referring to let's say a classification data set where in example of, let's say, orange and apple, you have only out of 100 samples, you have 90 of them are apple and 10 are oranges. So the number of samples in one class, completely outweighs the number of samples in the other one. We don't use train test split to check if it's skew data. Skew data we'll already know. There is no need to check using this train test split. I hope I understood your question. I could have mistaken your question as well. Next question, what if we use split ratio as 50%? Will the accuracy decrease? Pooja, we should not be using a split ratio of 50 in order to increase or decrease the accuracy. So accuracy it should not be depending upon the train test split. First point. Generally, typically train test split has to be 70-30 or 80-20 or probably 90-10 is also fine in some cases when you have a lot of data. So train test split has to be in that ratio. The accuracy definitely should depend upon the internal relationship between X and Y. So here carbon dioxide and temperature is the variable. If the model is able to find out a relationship between both, then you will get a better accuracy. Otherwise you won't. So you cannot use train test split as a parameter to increase or decrease accuracy. That's not fair to do in machine learning. Yeah.
I would like to add one more point.
Go ahead.
For that train test split, another thing that might happen when you have 50%, it's not because the train test split is lower that your accuracy is low or your error is increasing. It might be because with just the limited amount of data that you're giving to train, the model might not have seen every range of data. It might have skipped on the lower range or higher range of the data that it has to learn from. So it's better you give a higher ratio for the train so that model sees every range of data.
I request all of you to kindly try out the this assignment, this code, and run it for themselves and see how far you're able to execute and do. One more question. Selsha, thank you for that continuation of that. I was asking more if this is a way of checking that data across the set is consistent with predictions. Yes, I think you understood it correctly. Yeah. Train test split is a method by which we can see if the predictions are consistent across the data set. That's true. Yeah. Jishnu is asking, what if there are multiple features instead of CO2 only? So Jishnu, that's what we are discussing in the polynomial features. If you have noticed, we took CO2 as the only feature, and then we formed multiple features out of CO2 itself, like CO2, CO2 square, CO2 cube, etc. Now, in this data set, you are given various other features also. It's up to you to try it out. We have a very interesting challenge that we wanted to present to you, all of you. In 2-3 minutes, we'll present that, where you can submit your submissions based on that. Okay, so I hope most of you are trying out that or are in the process of finishing it. So before we actually wrap up, I would just like to conclude with a few important announcements. Let me share my screen. All right. So I hope you're all in the process of using that code and trying it out for yourself. And if you look at the website, I would like to take your attention for some more time, just towards the end of this workshop. We are approaching the end of this workshop. So in this website, as you would have seen, there is presentations. All the 3 presentations on the theory and the applications are given. Data set and code. We covered till part 4. We couldn't cover part 5. It's a small addition to that. I encourage all of you to download that and see what we have done there. Explore the code for yourself. In the website, we have also given a few more interesting data sets that you can use to start your ML learning. So UC Irvine dataset, health dataset, and Kaggle dataset, some of them. We extensively use these datasets in our machine learning master's program here at the Center for Wireless Networks. And definitely, there are a lot of resources online. I would request you to take some of the courses like on Coursera or edX, etc. And if you are more into learning by going through different blogs, etc., Machine Learning Mastery is one of my favorites. No particular competing interest, but I would suggest that you can start that. So thank you all for joining this particular hands-on lab on the workshop. Before we hand over to the next session, there is a very interesting talk on data sciences coming up. But before that, I would like to present to you something very interesting. We come to know that many of you are really interested and really enthusiastic about machine learning, learning machine learning, etc. So we have given few challenges. So if you go to the homepage of this website, on the right top there is challenge submission here. If you click that, you'll be taken to this web page where we have a Padlet. I'm not sure if you have used this tool. This is a Padlet where we have posted some questions. Okay, you can click this icon to expand this in a bigger view also. So we have posted 3 challenge questions. It's completely up to you. It's voluntary. Challenge question number 1 is, instead of using just CO2 as the input feature, you need to use CH4 as the input feature. Plot a suitable figure to represent this model. Challenge question 2, please read this. Challenge question 3, again read this. You can read this and understand. And now what we want, it's a voluntary participation, but what we want is, if you are able to do one of these questions or all of these questions, whichever way, you can complete that. And then whatever plot you are getting, we have asked you to plot a suitable figure to represent this model and copy paste the figure in as your submission. So if you click here, the plus sign, you can create a new post here and you can upload your image, whatever plot you have. In Google Collab, each of the plot, you can actually right click the plot and then save as a figure. So you can just drag drop that figure here. You can copy that and put here. You can also upload documents, any answers, any links, etc. But for this, we want you to upload your plots and put your name and Gmail ID. Every time you post, it will appear to us and we will have to moderate and approve the post. So only we will know your submissions, and we will also rate them. And we have very exciting offers in terms of internships that may be given to best performing students in this workshop. So we request you to take a look at this, check this out. If you can solve this and put the plots, etc., in this Padlet, that will help us to understand how much you understood this workshop. Okay. So finally, before I wrap up, I would like to thank each of you. Thank you so much for being part of this workshop. We really hope that all of you had a good time, understood some of the basic concepts about this machine learning. I know that the very first step towards machine learning for many of you. I hope this inspired you a little bit for further. And I would like to thank the organizing committee of ISIM for making this available to the students, and the entire team at Amrita WNA who helped us conduct this machine learning workshop. And special thanks to the speakers. And one more talk is coming up, as I mentioned before, very exciting talk on data science. So thank you all for joining us. We'll be happy to receive your questions also in that Padlet. So in case you have more questions, please post it on the Padlet. We'll be happy to receive them and then answer them from there. Okay. So thank you all, and we wish you all the best. All the best for your future, and we really hope that all of you take care of your health, all of you staying safe, your family is safe, and all of you happy. So I would like to give a break for 5 minutes or 2-3 minutes before we start the next session. Okay, so thank you all for joining us for this workshop. It's been a really pleasant and very exciting experience for us as workshop handlers. And please leave your feedback on ML workshop in the link given in the chat before you go or leave the meeting. And I request all of you to stay back for the next talk as well. Thank you all. Thank you so much. Thank you.
Success. It's the buzzword today in all walks of life. In your journey towards success, the university you choose plays a major role. With top-class research infrastructure, PhD faculty, and high-quality education, Amrita plays a major role in its students' success stories. Come, join Amrita University, an institution of eminence by UGC, ranked as the top private university in India by Times Higher Education World University Rankings and the 4th best university in India by NIRF Rankings 2020. Through our specially designed Chancellor's Scholarship, we provide up to 100% fee waiver and help you learn from the best. Our dual degree program in association with top universities from US and Europe can get you ahead of the curve. Come, start your journey towards success. Visit www.amrita.edu. Success starts with Amrita.
Hey guys, are you still searching for the right master's courses? Then stop. Your search ends here. Center for Wireless Network and Application, Amrita Vishwavidyapeetham has opened its admission. You can be eligible for scholarship also. If interested, you can apply using the link in the description box.
Hi, I am Akshay Sadish, MTech Geoinformatics and Earth Observation student from Center for Wireless Networks and Application, Amrita Vishwavidyapeetham. My research area is in the coastal change detection using satellite imagery. Recently, in one of the symposium organized by the center, I could meet up delegates of ISRI India and discuss my research work with them. They were interested in my work and offered me an internship. Now I am working with ISRI on GIS and remote sensing to estimate the coastal erosion rate. I am happy that I am contributing to some of the UN Sustainable Development Goals. I thank my faculty and staff members at Amrita WNA for supporting me. Thank you.
Namshvaya. So as mentioned by Dr. Rahul in the previous session, we have an exciting talk coming over by Dr. Karthik Shankaranarayanan. So he is an associate professor, Faculty of Business and Information Technology, Ontario Tech University, Canada. So he is here to give you an overview of data science applications. So from the whole Amrita team, I welcome you, sir, and I hand over the session to you.
Thank you, Deepthi. I appreciate the introduction. Let me try to share the screen and see whether I can accomplish that. Can you see my screen?
Yes. Yes, sir.
Wonderful. Okay, so you can still hear me and see the screen, correct?
So the screen that's visible to us is the speaker's screen and not the full
speaker's screen. Is it okay? Is this better, or do you want me to change it?
Maybe full screen. Is it?
No, I try to do full screen because I have two screens to make sure that I'm looking at things. So that's why you see those two things.
Yeah.
If you
Which
cannot
one is comfortable,
see this,
sir? Which one is comfortable? This is good. Yeah.
I have Google as well. I can try to share there if that is better. So let's try that. And because it has good pointer, hence I wanted to use this. So let's try the other one. So is this better for all of you? Can you see the screen? Because I can't see the chat here when I'm trying to present.
Yes.
Okay, perfect. So again, thank you for the kind introduction. And you might be a bit baffled by what I've written here, data science for sustainable development, moving slightly away from, the overview of data science application. It's still the same. And I just wanted to set the stage here that I know you have gone through, the introduction to Python, introduction to machine learning. This is not a lecture. I'm not here to teach you. This talk is mainly to act as a food for thought for everyone who are interested in machine learning, who are interested in Python, who are interested in data science, who are interested in sustainable development, so that I can motivate you and push you towards these areas, because these are really important areas in the world that we live in. So just before I move on to the nitty-gritty details and provide you with some case studies, just to give you an idea of who I am and why am I here to talk about it, and what are the credentials I have to be here and to convey a message, right? A food for thought. So as Deepthi already mentioned, my name is Karthik. I am an associate professor of analytics and operations management at Ontario Tech University in Canada. As the name indicates, analytics, I use data a lot, which I will talk about in the next slide. And I have a very interdisciplinary background, and that's the reason why I've put that there, so that you understand that people from different areas can be data scientists as well. So I have an engineering, computer science, and then a management background. Okay, so that's who I am. And then the question is, why are you here to talk about data? What are the credentials you have in terms of talking about data, right? So I've pointed out a few projects that I have worked on or I'm currently working on. And as I've mentioned here, all of my projects have data in it, right? To start with, one of the projects that I worked with the government of Canada is on cybersecurity, wherein I use machine learning along with, of course, it's just not me, it was a team, and the team included a graduate student who worked on the usage of machine learning algorithms and also natural language processing for anomaly detection in network data, basically cybersecurity intrusion detection, so that we can mitigate, cyber attacks. So that's one of the projects that recently concluded in 2021. And the other two projects that I've listed here, machine learning for maintenance and outage planning and wrench time analysis, that is an ongoing project with power generation company here in Canada in the province of Ontario, wherein we are looking at maintenance and outage planning, right? And can we use machine learning algorithms on the data that is available? If the data is not available, can we look at examples of machine vision and use already coded data and bring it to machine readable format, which can then help decision makers come up with maintenance scheduling, outage scheduling, and things like that. And the third project is wrench time analysis. Wrench time is basically, in a nutshell, hands-on tools. So these power generation companies have contractors. So these contractors have crews coming in, and they work on 8 to 12-hour shifts, right? Are they actually doing their work? What is the productivity? What is the efficiency? So we send students to these plants and adopt what is called a job shadowing, and we collect both qualitative and quantitative data. So text data is there, and there is also numbers available. Right? So those are the two examples given here. The figures are given here. And the third figure is extremely crucial in that when we think about data, right? Gone are the days when it is just rows and columns in an Excel data sheet or something like that. But right now, the data is diverse. You will get text data, you will get video data, and I'm going to show you an example today as well. So this is how I use data on a day-to-day basis, both in research as well as for teaching. Now, the second part of this conversation is on sustainable development, and the question arises, what authority do you have to talk about in terms of sustainable development? And thanks to our beloved Amma, in 2019, I got the opportunity to, start working in the newly formed school, the School for Sustainable Development, and currently I am an adjunct faculty there, and that's where I started getting involved really deep into the areas of sustainable development, even though before, through my operations management and courses like that, I've been talking to students about, green supply chains, ethical procurement, sourcing, and things like that. But since 2019, I have been involved, and I have the opportunity of supervising and co-supervising graduate students, doctoral students, and I work on agricultural value chains. And then I also work on, disaster management, use of technology in disaster management, and so on. So there are multiple projects. So that's where my involvement and interest in sustainable development comes into picture, right? Now, before we move on to the case studies and show you how data science is being used, this is the definition that I use for sustainable development, and it comes from the report of the World Commission on Environment and Development, Our Common Future, way back in 1987, which says sustainable development is development that meets the need of the present without compromising the ability of future generations to meet their own needs. If you've been following Amma's satsang recently, she was teaching a child in the group about the need for trees. And because we are cutting down trees, we are causing soil erosion, landslides, and things like that. Right? So that's basically what this definition says, that what can we do to make sure that the future generations has a proper ecosystem to live in, right? So that's the definition I follow. And this definition has three pillars. And the pillars are coming from, the United Nations, and you would have heard multiple times through this symposium, there are 17 United Nations Sustainable Development Goals, but the three main pillars are the societal, environmental, and the economic features. All of these put together forms the core of sustainability as we are kind of envisioning it. So we are talking about preventing pollution, standard of living, gender equality. You might have heard in panels, you might have heard in workshops and presentations and things like that, right? So we need to be energy efficient, but at the same time, businesses need to make money. How do we go about doing that? So that's the core concept, and that's the foundation of this talk, right? How do I bring this data science and sustainability together so that we have a great life moving on, right? And that's the next part of this talk, wherein I'm going to bring two examples because I can go on for the next 8 hours talking about data science applications in various areas, but something that really resonated with me, I thought I will bring it to you and show how these researchers and how these foundations used data science for, for sustainable development. Okay, so that's the stage that I would like to set. And the first case study that I would like to, talk about is data science for food security. So if you look at the 17 United Nations Sustainable Development Goals, food security is a crucial one. And this study is coming from the Stanford Center on Food Security and Environment. Okay, and this case comprises of two papers which were published in PNAS and Science magazine. So I'm just aggregating this information for you. By the way, this is not my work. I just collated this information so that I can motivate people who are interested in data science and how they can also be involved in sustainable development goals. That's the idea here. Now, in terms of data science for food security, what the challenges that we face in terms of working in developing world or developing countries is that some of you might have experienced it in India as well. We have no information or no data, but even if data exists, it would be limited, insufficient data, and on top of it, it's unreliable. Right? Sometimes it's self-reporting and it is not accurate. And so there is a lot of problems involved in that. And then the other issue is also that when you're talking about developing world, there's a lot of aid that comes in from government agencies, the local government agencies, international organizations like the UN and things like that. But because of the non-availability of accurate data, mapping these goals to the progress of these countries, it becomes extremely critical. So now the researchers from Stanford started thinking, okay, how can we kind of use technology here in order to, mitigate this problem of lack of data, right? So two of the things that they looked at was on agriculture and then poverty. So those are the two cases that they had. And in terms of agriculture, they went into a region in Western Kenya and they used satellite images and especially the Terabella SkySat sensors, which is part of Google's Skybox for Good, in order to see whether the collection of data and the time-tested way to collect data, as all of you know, is through surveys and going into the field and collecting the data. But this takes a long time. As you can see here, it took the researchers 2 years, and they had to work with one of the clients, the few of the clients from the 1 Acre Foundation. And they went in and they tried to collect data using GPS mapping and things like that. So it was a 2-year process. And then they also used image processing using the sensor data, as you can see from here. So they used 8x8, 8 kilometer wide by 50 kilometer range, 8x8 for the sensor data. And they tried to look at these information and see whether these two data can be, compared. Is this accurate enough for policymakers to look at this data and say, what is the crop yield? So the goal here is the figure in the bottom talks about tons per acre. So how much is the yield? in each of these regions, because you're looking at small farmers, and sometimes these small farmers and small households, they are not going to be providing you with accurate data. So can we use satellite imagery and machine learning to train these algorithms with these kind of sensor data in order to come up with accurate information, which then the local bodies and the international organizations can use in order to help these local farmers to improve not only on the crop yield, but also receive aid. So this is one of the examples that I would like to wanted to discuss here today. And this is published in PNAS, and I will be providing you links for these. In the same set of researchers also looked at poverty in terms of acting as economic indicators. Right, so they went into 4 African countries: Nigeria, Uganda, Tanzania, and Malawi, and they, again, lack of data, lack of actual accurate data led to the use of Google static maps and the use of machine learning algorithms to see whether using these static maps can we train these machine learning algorithms to identify these economic indicators. Now, if you ask the question, what are these indicators that you're talking about, Karthik? So in order to understand the standard of living, you can look at the urban population, which is shown in the first column, 1 by 1 of this matrix. And then in the second column, you will see this, suburban regions. And then the third map will show you the rivers, the water bodies, and then the fourth one shows you the roadways. So we use this, the researchers use this data, the maps, to train the machine learning algorithms. And then the last row is where in pink, the machine learning algorithms tries to identify each of these regions. And you can see in the third one, it identifies the waterways. And in the fourth, it identifies the roadways. This tells the government and other international agencies that so there is some level of infrastructure development, there is some level of the standard of living happening in these regions, so that aid goes to the regions that need those kind of support, and it goes to the right group of people. So that's the goal of these two work. So using machine learning, data science, and also sensor data, these researchers were able to inform policymakers about what is going on, what is the status quo, and how can we improve these countries. So this is one set of examples that I wanted to give you. And again, I will be providing the link for everyone so that you can go and read about it, because I cannot give you a full account of this. As I said at the beginning, this is just to motivate everyone to venture into data science and also sustainable development. Now, the second project is also, it resonated really well with me, is the Ocean Cleanup Foundation, which is a kind of an NGO that operates out of Rotterdam in Netherlands. And their goal is to clean up the plastic pollution that human beings have induced into the ecosystem. And this is one of the research that came out of that group, which is on the automated river plastic monitoring using deep learning and cameras. Now, what are the problems here? Everyone knows about plastic pollution, and single-use plastic has been banned in many parts of the world, right? So now how can we solve this problem? How can we quantify? Right? Again, going back to the previous example, collection of manual data is extremely slow. So how can we use modern technology to mitigate that issue? So that's what they did. And again, they used this two sets of experimentation. One was the use of visual counting, manually looking at rivers, and this happened in Jakarta. I'll talk about it in a minute. They looked at rivers and started visually counting the amount of plastic in those rivers and waterways. And also then they set up cameras around these waterways, 5 locations, and then they collected it, and then they created an image data set, and then did object labeling. I know you have done introduction to machine learning and Python and so on. So this is supervised learning, wherein you have a structured data now, and then it was fed into the convolutional neural networks, and which then went on to segment and detect the plastic. So this is the methodology they adopted, and this is the setup of the cameras in those waterways as shown here in Jakarta, Indonesia. And as you can see, they had 5 locations rightly named A, B, C, D, and E. And this is the characteristics of the data set below, where they talk about the number of observation days, number of images, number of objects, and things like that. So they went and collected these information. And the thing that the neural network did, which is of interest for us because we're talking about machine learning, data science, and things like that, is on the left-hand side is the input image to these neural networks. And then the first stage would be the segmentation stage, wherein the neural network is kind of taught to segment the image into plastic or to find out objects. And then based on the segmentation, it will go on to detect whether it's plastic or non-plastic. So based on this information, they were able to, going back to the point that we started with, to quantify how much pollution was happening. And based on this information, think about it, cleaning the ocean is a Herculean task. But if we can capture these plastic waste, then we can do it at the waterways before it reaches the ocean. That's the goal of this project, right? And it will also help in interventions within the society. Say, this is the amount of plastic we found in our waterways. We need to be more clean, to be more environmentally aware. Right? So that was the goal of the project, and they achieved a precision of 65% through this work. So the more data that they use, the more data they feed into these kind of algorithms, the better it is going to get. Right. So again, this is available for you, the Ocean Cleanup Project. So I would recommend everyone to go and look at this. Now, these are some of the examples that I wanted to bring you to, and then kind of segue into this data science process. And as you have seen in today's lecture, I saw Rahul explaining a certain few things as well today in the introduction to machine learning, wherein you were doing the regression analysis and things like that, right? So data science goes through certain steps, and the first step obviously is the collection of relevant data, and then you kind of format this data so that the machine can understand, and then you can explore the data, which would be the next step, visualizing the data to see what you're dealing with, whether there are trends happening, and so that you understand the data really well. And then moving on, you construct the machine learning model, whatever statistical model or mathematical model you want to construct, so that you go ahead and predict and forecast using the data that you have received. And finally, the goal here is not just say, I am the best data scientist, I've created a really cool model. No, we have to make use of that model. And that's where the interpretation, like I said, using the data that I collect, I inform the senior vice presidents of these companies, saying that these are the best ways to solve your problem, the best way to reduce your costs and things like that. So data science goes through these steps, as many of you would already know. And then one of the questions that I generally get, and I really like this figure, is how do I get started with data science, right? I mean, everyone has an opinion. Oh, you need to know software engineering, you need to know data visualization, you need to know machine learning, you need to know storytelling. And I'm doing a kind of storytelling to everyone, right? I'm not lecturing, but I'm doing a storytelling to motivate you. So these are all important skill set, but I didn't acquire it in a fortnight. I acquired it over 10-year period, right? Looking at the data, spending time programming, understanding statistics and things like that. So you might be overwhelmed at the beginning, which is the state that everyone goes through. It is okay. right? So to start with, and to act as some food for thought, and this is one of my penultimate slides, and I'm not going to talk a lot so that I can answer a few questions. So these are some of the food for thought that I have based on the previous slides. And one of the important things I want everyone to take away here is that technology is just an enabler, not a solution. Do not be bogged down by technology, because you will be bombarded with technology, right? So why I say that is technology, you are coding these algorithms. If you have a garbage into this algorithm, you're going to get a garbage, right? It will not make sense. Garbage in, garbage out. So this is what I want all of you to take away, that technology is not everything, right? So you need to have that goal, you need to have that foundation, which takes me to the second point, that if you really aspire to be a data scientist, and again, I want to tell this, that you can be from any area. You can be from biology, biotechnology, you can be from ecological sciences, you can be from mathematics, you can be from engineering, does not matter. You can be a data scientist, but I want everyone to learn statistics and math, because all of these underlying things coming into machine learning and all the other hyped topics is statistics, is mathematics. So I would recommend everyone to start with understanding statistics, these regression analysis and things like that, to start with before even you start coding. Understand it, and you can use tools like R, Python, and then you can move on to relational databases, structured query languages, and things like that. Right, and challenges will exist, but there are so many opportunities that you can be a part of, like the ocean cleanup. They are looking for volunteers, volunteering. You can still be working at Google, you can still be working at Facebook. You want that 6-figure salary, go do that, but you can still contribute to the society by acting as volunteers, and data science is a great place to start. And tech for good is something that you might have heard, and that's what this data science for sustainable development is as well, right? You are using technology for the good of the society, and also to make sure that we have a world to live in for the future generations, right? And I'm going to leave everyone with this wonderful note that Albert Einstein made. I have no special talents. I am only passionately curious. Right, and that's so true. As long as you are very curious in what you do. I'm just checking to make sure that I am within the time limit. I'm just crossing 24 minutes. I'm going to wrap it up. So you just have to be curious in what you do, and as you proceed, as you learn, as you relearn, and then you put in time, you're going to master those things. So with that thought, I'm going to stop my talk here. I thank you all for your attention, and I hope I have succeeded in piquing your interest into data science and sustainable development, because these are really interesting areas to work on, whether it is through your bachelor's, your master's, your PhD, or whether you are at work and you want to contribute in some way or the other. So I hope that I have given you some points to think about. So with that, I'm going to stop here. I thank the organizers of ISIM for bringing everyone together over the last 3-4 days and organizing all these wonderful events. So I appreciate it, and thank you, and Namah Shivaya to all.
Thank you, sir. So questions from the attendees are welcome. Any questions?
I see Pooja Soni had written wonderful insights. Oh, thank you. I appreciate it. And that was the goal, right, Pooja? That the goal here was not to teach you. The goal here was to, kind of excite you about data science, even though many of you are worried about, oh my God, I'm not good at mathematics, I'm afraid of mathematics. Mathematics is not alien. We do use it on a day-to-day basis. There is a structure to it, and if we follow that structure, it is not difficult. And that's why I put Albert Einstein's quote at the end. Just be curious. That's what it is.
Sir, I think we have more questions here. So Pooja Soni is asking how to go about searching for better opportunities.
I believe in the field of data science. That's probably what Pooja is asking. So in terms of opportunities, like I said, in all the areas, data science is extremely important. If you are on LinkedIn, if you give data science as a keyword, you will have millions of jobs, like literally millions of jobs, because even with the recession, with the pandemic, guess which jobs are, useful, which jobs are, people are hiring these individual data science. Because we have troves of data. We went 20 years back, we didn't have data, and now we have tremendous amount of data, right? We need number crunchers. We need, people who can, visualize this data and say, oh, okay, this is how we could use it, right? So that's what we need. And the best way to start looking at LinkedIn, and then you can also look at, like, for example, Amrita already has data science programs, right? So if you're looking at academic side, there's a PhD program. There are lots of opportunities there in different departments. And I'm not talking just about School for Sustainable Development. In all the departments, there are opportunities. And workplace, if you look at Google, Facebook, and even in my, I am actually working with a student this summer, wherein we are looking at machine learning and data science for maintenance planning, as I mentioned. So, opportunities abound. It's everywhere. LinkedIn, all the job portals has it, so it's there. I hope I have, because probably it might be a vague answer, but the truth is that it is everywhere, and LinkedIn would be a great place to start.
So any more questions from our attendees? Maybe you can raise your hand. Yeah, I think we have got one more. Okay. Just thank you, sir.
And just to add, one of the questions Jishnu asked is, can you please send us this presentation? I will be sharing. As I said, I collected this information, and at the end, I also have, I think Rahul already showed it, in terms of, Kaggle is a great place, GitHub is a great place. Practice, practice, practice. That is the best answer for that, right? Just practice. Right. And for a beginner, like I mentioned, start with statistics. That was one other question that was asked here. Start with statistics. That is the best way to start one's journey into data science. And I would recommend either going for, statistics with R or statistics with Python. That would help you to not only learn programming, but also to understand the fundamentals of statistics, and then we can move on from there. Right. So thank you very much. I again say Namah Shivaya to all. Stay well wherever you are. Stay safe, and I hope all of you get the vaccine as soon as possible. Thank you very much. Namah Shivaya.
Thank you, sir. It was a really enriching and inspiring talk from your side. So I thank you very much for being in this workshop. And okay, for the attendees to know, let me tell you that Karthik sir is our adjunct faculty at the School of Sustainable Development. And also he's mentoring several students and enthusiastically engaged in shaping the research at School for Sustainable Development. So thank you again, sir.
Sure.
Thank you for joining. Thank you. I'm sure. So for the attendees, I have an exciting announcement for all of you. We will be soon having a part 2 for the machine learning session with more detailed informations in it. So stay tuned to the WNA website and FB pages. And we will be informing all of you via email, those who are participating today. So just keep in touch and look into it. So next, we are on to the next session of our workshop, which is for the geospatial. So I request the attendees to wait for 1 or 2 minutes. Thank you. Namah Shivaya again. So welcome to the last workshop of our symposium. That is Introduction to Geospatial Technology, and a hands-on workshop is coming on your way. So this is going to be an exciting tour for you. So I'm here, Deepti Rajmohan, and we have a geospatial team from Amrita Center for Wireless Network and Applications. And we are also joined by the Esri India team, who will be taking you through this 3-hour thrilling experience. So this includes demos, quizzes, polls, hands-on experiences, and much more. Now we have an exciting announcement to make here. So I call for our mentor, one of the mentors of this workshop, Bal Mukund, to convey that message to you. Over to you.
All. Thank you. Namaste all. I welcome you to the exciting workshop on geospatial technology. We have grouped up together with ISRI team to take you through this journey of another three hours. And also, as this workshop is also a part of this hackathon, so you will be evaluated in this workshop. So the hands-on exercises that you are doing, the quizzes that you will be given, all this will contribute to your assessment. And then you might win exciting prizes such as the 50,000 cash prize, or 1 year of ISRI software license, or admission in MTech or internship opportunities in Amrita Center.
Yeah. Thank you, Balmukund. So, are all of you set? Are you all excited? Well, remember, your performance will be evaluated not just by your prior knowledge of the subject, but also by your active participation throughout. Now, let me introduce one of our mentors who's from Esri India, Mr. Ajit Kumar Babar. So he's a senior analyst at S3 India and has over 6 years of experience in the field of GIS. Being an inquisitive individual and a GIS professional, Ajit Kumar Babar has interest in enterprise and mobile GIS. So I welcome Ajit sir.
Thank you, ma'am. Hello, everyone.
Thank you. Now I introduce our second mentor. Her name is Geetanjali. She's a senior engineer at S3 India, focusing on ArcGIS Enterprise and ArcGIS Pro. Geetanjali's background includes a master's in geoinformatics, MTech. So welcome Geetanjali to the workshop.
Thank you, ma'am.
Thank you. So before entering the workshop, let me tell you, unlike other workshops, here we have a little bit rules here to be followed. So the first rule will be, I want all of you to listen attentively. That is, when your name is called, you should unmute and talk for at least 5 seconds. This will be very random. Whatever answer comes first in your mind, just say that without worrying about it being correct or incorrect. And our second rule will be, check the chat box. There is a Google form. Enter your name, email, and unique workshop ID will be given to you through the mail. And then you will get an assignment after the end of the session, which you have to submit by tomorrow. Especially for those who are going ahead in the hackathon, this will be considered in evaluation. And all the queries will be handled through Q&A session. We'll post a Telegram link, as well as whoever has signing in or internet related issues can share their screenshots there. Our team will try to support you in the best possible way. So Ajit sir, the floor is yours. Thank you.
Thank you. So thank you, Dipti and Palmukul, for the introduction part. And hello, everyone. I am Ajit, and as a part of Introduction to Geospatial Technology, my colleagues and I are going to discuss about the capabilities and functionalities of ArcGIS Online, which is a cloud-based GIS platform. So without further ado, let me start with today's agenda. Today we're going to start with our session with the ArcGIS Online overview. Then we'll talk about discuss about ArcGIS Online components. Then we'll see what type of content can be used in ArcGIS Online. Then we'll see how we can use or work with web maps and the capabilities that ArcGIS offers to your ArcGIS Online organization. Then as an administrator, how can I configure and administrator my ArcGIS Online organization? And followed by that, we'll be having a 40 minutes hands-on session where you'll get one hands-on tutorial. So, and the data will be shared with you guys. And you'll be able to complete that exercise. You'll get a general idea how ArcGIS Online works. Then post that, so we'll discuss how we can share the data, basically the GIS content with ArcGIS Online. And once the data or the web map is ready, how we can create beautiful and meaningful web applications from those web maps, that to be without writing a single line of code. So we'll discuss and we'll see the various options available for that. So, and followed by that, we'll be having again our second hands-on, where the hands-on is basically on app creation part and also the new expression language called Arcade. Then my colleagues will demonstrate how we can perform multi-criteria analysis using GeoPlanner and suitability modeler tool, which is available in ArcGIS platform. And in the end, we'll be having QA session and along with the assignment for you everyone. So over to you, Geetanjali.
Thank you, Ajit. Hello, everyone. So let's start with the first question that might pop into our mind. What is ArcGIS Online? So ArcGIS Online is a cloud-based mapping and analysis solution. We can use it to make maps, analyze data, and to share and collaborate our work. It is a platform which will help us in getting access to workflow-specific apps, maps, and data from around the globe. Let's make it a bit simpler for you. For example, imagine that you are an agricultural official. Yeah. Part of your job is to identify areas near a commercial campground where a particular invasive weed or plant is a threat to campers due to fire hazard. Okay, so campers who come in contact with the weed during their recreational activities or camping, there is a possibility that they will take the seeds away with them when they leave, right? So, how to avoid the situation? You are being posed this question as an agricultural official. Imagine that fortunately you have a web map of commercial campgrounds with information about these invasive plants or weeds, these things, right? So you know about their distribution and you have data about the camping grounds as well. You also have a powerful set of analysis tools which will help you analyze these data, which is ArcGIS Online. So how to do this? How would you proceed? You can perform an analysis by creating buffers or proximity zones around these commercial campgrounds, which will help you understand which of these buffers contain these invasive plants or weeds, right? Finally, once you collate all the data, you can calculate the amount of weeds or these plants which can cause a fire threat. And accordingly, you can warn the campers who are coming into those camping grounds. It sounds interesting, right? So let me give you a sneak peek or a first glance of how ArcGIS Online is, or how does it look like. Once you hit this particular URL, which is www.arcgis.com, you will get into this particular web page where you'll have an option to sign in. Clicking this will take you to a page where you have to provide some credentials called username and password. Such credentials will be provided to you, right? Every organization who has an ArcGIS Online organizational account can provide username and password to their members who will be a part of this ArcGIS Online platform. And after signing in, you will come to somewhere like this. Yeah. So you will be redirected to your organization's ArcGIS Online account. So this is an example of your organization, that is Amrita Vishwa Vidyapeetam's ArcGIS Online platform. Signing in will get you here. What else can we achieve from this? Can you see that there are a lot of tabs over here, like gallery, map, organization, and so on? So every tab will help you achieve some kind of functionalities. For example, going to this organization tab will take me to the organizational details of ArcGIS platform, like which organization's ArcGIS platform is it, and what all are the activities that have been conducted, how many credits are available. What does credit mean? Whatever analysis that you do on ArcGIS Online is from credits. Like once you perform an analysis, some of the credits gets consumed. So basically, when you have credits, only then you can analyze or create applications and all in ArcGIS Online. You will get details about members of your ArcGIS Online platform through this. The
Yeah, I think
licenses.
you must have got an email which has this ArcGIS platform, and also I have posted a link in the chat box. So whoever doesn't have this, can you please fill this link immediately so that we make your account ready before the hands-on session. So please check your email if you have got. You all have got account with user ID and password. So you have to use that for the hands-on session. But whoever has not got, please fill this form. Thank you.
Thank you. So moving on. All these tabs, like I said, every tab will have subtabs which will provide you some or the other kind of information. Moving on, you can see that there are some tabs called gallery, maps, scenes, and all. So this is where your data is. So basically from map is where you'll add your data and try to create a web map. Gallery provides you the cloud hosted data that ArcGIS Online will provide you directly. So you can access different kinds of data here and you can perform your analysis. Now, to go further and to understand it better, let me leave the platform to Ajit. Ajit?
Thank you. Thank you. So coming to the next topic, where we are going to talk about ArcGIS online components, such as what exactly is that? Whether it's can we work without internet? Can we have what are the like sign-in options available, and how we can configure the ArcGIS online organization? So who are the stakeholders involved in that? Such as we do have a cloud platform available here in this particular diagram, as you can see it here. So there are different users or different groups, or you can see different devices are basically connected to this particular cloud. So that's why we call it, it's a web, it basically uses a web GIS technology, web technology, where the ArcGIS online communicates between a server and a client. So your client can be like your browser also, like Mozilla or Chrome, or it can be a mobile-based app, or it can be a desktop-based applications as well. And user will be able to sign in with their credentials there. They will be provided access, or the privileges or roles will be defined by the administrator, and they can sign in the users. They can be a part of particular groups, and they can start and work with the creation of maps phase. So let me show you the various sign-in options available here. So as you can see, we do have an application called ArcGIS Pro. And here you can see the sign-in page. So ArcGIS Pro as a desktop application, it's currently connected to your cloud-based platform, so which is Cloud GIS, which is ArcGIS Online. Or let's talk about this mobile application called Survey 123. This is also currently connected to your ArcGIS Online. So these applications, desktop or web-based applications, or the one that we just saw, which is from the browser-based application as a client. So we can connect from all these applications to your ArcGIS Online organization, and you can perform analysis, you can create map, you can author the maps. Then in the end, you can finally share that particular content with the users. So that sharing can be like, again, controlled. Suppose you want to keep it private, you can do that as well. So, or you want to create or share that particular with groups. So you can share that content with only few particular groups or one single group. Or if you want to host your application, let's say you have a web application created and you have authored the map, you created the web application, and in the end, you want to share or put it in the public domain. So you can do that from the ArcGIS Online. Over to you, Gitanjali.
Thank you, Ajit. Yeah. So I hope you have got a very basic idea of what ArcGIS Online is and how can you move about. Let's understand a bit more in detail, right? Let's start with the basics. So ArcGIS Online basically gives you access to a variety of geospatial content. ArcGIS Online is a collaborative web GIS, right? You have understood that, which allows you to use, create, and share maps. Also, 3D scenes, apps, layers, analytics, data, so on. So many privileges and functionalities are there. We are not done. You get access to content in ArcGIS Living Atlas of the world as well. Then there are ArcGIS apps, cloud infrastructure where you can add items, publish web layers, create maps, apps, and scenes. So there are a lot of privileges or functionalities that you can achieve with ArcGIS Online. Let's go through the basics by exploring its content. I'm taking you back to ArcGIS Online platform. Once you sign in, you can see, like I said, we have a lot of tabs which gives us different details. So every data that you add into your ArcGIS Online is available from your content. Please excuse me. Okay. So again, I hope you got a second idea of how to sign in, right? Once you access arcgis.com, you have to provide your credentials, which will take you into your ArcGIS online platform. Just brushing the contents again, the background again, right? After you sign in, like I said, what all data that you add into ArcGIS online will be available in your content. You can add item or add data by different types of methods. You can publish data directly from your computer. What all spatial data that you have with you, you can publish it. You can get it from a service URL. You can get it from a cloud drive and so on. There are data in ArcGIS Online which are hosted in the public cloud of ArcGIS Online, which are available. So I'll come to that later. So data can be added into ArcGIS map or map viewer, from where you can analyze it and understand and play with data more, basically. So once you take this particular map viewer, again I'm reiterating what I told. The different tabs that are available in ArcGIS Online each has different functionalities. We have taken map viewer now, the map tab. Accessing map tab has taken us into map viewer, and you can see that the page or the layer that is there by default is a map, right? So this is called a base map. Base map is something upon which we'll build our features and create a web map. So what all details that we add here are added above a base map. So we should have more choices for that, right? So ArcGIS Online is providing us with a base map gallery, which will help us in choosing the base map that we want according to the project that we do or the function that we want to achieve, right? So you have light gray canvas, street maps, topographic map, and so on. We have a default base map for now. If I want to change it, I'll go to base map gallery and select my base map. Other than this default base map that is available, what all data that I want, I will have to add it into my ArcGIS Online or map viewer. How to do that? You can see that there is a button called add here. Whatever data that we add will be available in this content, right? So I have selected content, I have highlighted content. So what all data that I have should be visible here. You can see that my base map or imagery is visible here. How to add more details? I have multiple choice for that as well. On clicking this add button, I'll get a variety of options like searching for layers, browse living atlas layers, add layer from a web, layer from file, and so on. Like I said, what all data that is there in your ArcGIS Online content or your machine, you can take it here. Other than that, you have something called ArcGIS Living Atlas, which is a public cloud where different data is hosted and are readily available for you for your analysis. So if I select ArcGIS Living Atlas, I can search data by search criteria. Suppose I want data regarding forest fire. Like normally how we run a search engine, we have to provide the criteria, and that will give us details of results. So for every result that is there, we'll get information on what that is, and we can add it to our map. This particular option help us to add the data to our map viewer. So basically we are building our data now, right? I have a base map and I'm adding more data into my map viewer. So what all data that I've added here should be visible here. According to the network, the status of your network and the heaviness of the data, it might take some time, like accordingly. Once that is added, like I said, it will be visible in the content. You can see that California Wildland Fire Direct project data has been loaded, which I have taken from Living Atlas. If I have some data within my content, I can search for that as well. So whatever data is there in my content, accordingly, I can search it and add it here. Yeah. I have different functions that are available in ArcGIS Online called analysis and all. We'll go in detail later on. We have a complete exercise regarding this. Just to brief you regarding this, what all data that I've added here, ArcGIS Online give us some tools to perform some kind of analysis over this, like summarizing the data or using proximity analysis, like creating buffers and so on. We'll come in detail for that and we'll understand it in a better way later on. Okay. Moving on, like I said, you have different types of tabs again called gallery. Like if I access the gallery over here, again, there is another, that is another method by how I can search for data from ArcGIS Online. This will take me to gallery page. I have an option of searching the gallery, and according to my search, results will appear. I can view it in application. I can add it to my map viewer and so on according to the data that is available here. I can view the item details accordingly as well. So what are item details? Coming to that. Yeah. If you access content of ArcGIS Online, like I said, what all data that we have added into our ArcGIS Online platform will be visible in content. And for every item or every data, some background information will be there, right? So these background information will be available in item details. To access that, yeah, so you can see that if I select any data from the content, it will redirect me to a page called item details, which provides me the summary of the data, who has created the data, if it is in a particular coordinate system, what is the coordinate system of the data, what are the sharing privileges, like is it allowed to be shared to others, and so on. Yeah. So this page is called item details, which gives us a description of the item that is there in my contents. Just rebrushing what I have told, we have accessed map first, and we understood that there is something called base map, which comes by default, and there are options for changing base map through base map gallery. ArcGIS Online also provides us with ArcGIS Online Living Atlas, through which we can take data from cloud hosted data that is readily available for us. You can add your own data. We have a gallery from which again you can search and select data. There is something called item details for every data, which will give us details regarding that, regarding who has created the data, on what date has it been created, if any coordinate systems are there, what are the coordinate systems, and so on. I hope the topics are clear. Moving on to Ajit for the next session.
Before that, just a small announcement. Guys, please join the Telegram group for the Q&A, and also whoever not registered or who has not got the history license, they should fill their details in the form so that our team can provide them. Thank you.
So, once you have now seen all the options available in ArcGIS Online, now let's go into little details and let's see how we can create web map, how we can present our story with the help of web map, how we can target specific audiences, and then how we can share that particular audience. So web map basically contains layers. So just now as shown by the Gitanjali, how we can add the data such as living atlas. So what are the sources? What are the sources, or what type of data sets can be added in web map, that we'll see. And once you create a web map, or once you author a map basically, so what you can do with that is you can apply symbology on the top of it. You can define symbology for the layers. You can enable pop-up. You can enable labels on the top of it, and you can work at different scales. And of course, you can add different types of layers such as operational layers or base map layers. As you know, base map is a static layer. You can add that in the background as a reference. And yes, you can work at different scales and you can create a beautiful app from those particular web maps. So web maps basically act as an input for all the type of web apps that we're going to see in the next session. So let me just start the demonstration part. Yes. So as you can see here, so we have created all, let's say this particular map, which is basically part of your hands-on exercise 1, where I have like certain data sets available. Let's say this is the web map name, cites a new hospital in Coimbatore. Then we do have like 4 layers, as you can see. So these are basically feature services. Since we are accessing in the web client, so, and this is particularly, this particular layer is, as I said, feature service. So we do have like hospital data, road data, urban area, and Coimbatore, 4 different types of layers. And from here, we can change the base map and you can perform the analysis from it. So this is called web map. So once it can contain 1 or many layers. So those layer can be, as I said, operational as well as this particular here called base map layer. I can go ahead and create a separate new base map for me for this particular exercise. Let's give some name here. And you can define the tags here, right? And you can decide, you can define the summary and you can save or store in a particular folder. Now, suppose if you're going to host this application or if you want to share this this particular web map in like public domain so that all the citizens or public can see it. So you have to decide the tags properly so that they can search from their, let's say, web browsers or like any devices, mobile browser, web browser, or let's say on any custom application which has or can access the ArcGIS Online, the cloud component. So I'm going to hit save it. And there are some capabilities, right? You can see here what we can do with those layers in web map. So you can see the legend, right? You can click on this legend button to see all the legend properties. Or you can go ahead and check the attribute table also in the web app. Like attribute table or the information is nothing but the details about this particular feature. Let's say all about these roads. So I can see all the details, the road length and the ID and the name of that particular road in the attribute information. Then I can go ahead and set the cartography, such as changing the symbology. So we will be providing you all the options that whatever we provide as part of the cartography. So you can define the transparency, you can define the scale at which it will be visible, and you can use this slider to set the transparency level. And even you can also configure smart mapping from this particular option. Then comes, you can set the filter also. Like what we do in GIS is query, right? So you can define one SQL query expression, you can write that, such as, I don't want to see all the roads. I just want to see the national highways. So you can set the filter right here. And then we will have this perform analysis button here, same as here. And these 3 dots here will give you more options to, let's say zoom in, like this. Then the transparency, scale, visibility scale range, you can rename it, move the layer up and down. You can like turn on off layers from these boxes here. So these are the capabilities of web map. So you can do all this stuff only web map. Then the pop-up part. So as soon as I click, let's say on this part called urban areas, you get a pop-up window. So that's basically nothing but your attribute information getting displayed as a pop-up. So that can be also configured from here. Then create labels. Let's say I want to create a label for this hospital, as you can see. Name. I want to keep it as a name only, like Max Hospital. I can do that. And I can go ahead and increase the font size like this. Then I can further go ahead and set the refresh interval. Suppose you are getting some real-time data. So you can set the refresh interval. Let's say like every minute data should get updated. Then item details, as Gitanjali has already covered, it's kind of a metadata. It's like describes, it's like a data about data. And from this save button, you can further create, it's like a save as layer. So you can just copy and create another set of layer. Then this share button, which basically will help you to create a web app without writing a single line of code. So we will discuss more on this shared part in the second session of our training. You can go ahead and take a print with legend, or just take a map print. You can set the directions here. You can perform basically routing analysis here. So let me show that small example. So you can define point A and let's say point B here, and you can get the directions also like this. So it's like routing that we used to do in mobile apps, right? So that's the routing part. You can perform analysis such as like area measurement or the distance calculation from like this. So you can set the units here. Or if you want to get the area, you just draw polygon and define it in square kilometer like this. So this is the area of that particular polygon. You can also create a bookmark here. So bookmarks, as you know, we normally use it in web browsers, right? So here bookmark is like saving the extent of your map. Let's say my interest currently is this particular part like Max. So I'll just go ahead and add a bookmark here. Let's say Max Hospital, which is basically an existing super specialty hospital in Coimbatore. So let's say you are right now rendering at Kozhikode area and you want to quickly visit to that Max Hospital area. So what you do is just click on the bookmarks and click on Max like this. So you'll be automatically zoned to that particular area. Then you can create a presentation. So once you have access to the web map, you can create a presentation from that particular web app. So it's like taking a screenshot of this particular area wise, and then you can add description, add a title, like those options. You can do it from there. And apart from that, we do have like sign in option here. You can see here. And since if you're an administrator, you'll be able to see, you'll be able to manage all the stuff from the organization page. So this was all about web. So let's see what is web scene. So you must have seen this option available here. All the tabs that Tanji was talking about. One of them was C. So web map is basically for 2D data. So what if you have like elevation related data? What to do with that? And I want to visualize it in 3D. Right? So for that, you just have to click on that scene button, and we do provide some samples, and you can directly add that in your web browser, as you can see, like this one. So this is called 3D data, 3D GIS. Here also you can perform lots of analysis, like let me show you here, like daylight, shadow analysis, you can do that here. Then say height measurement, suppose you want to measure the height of this particular building, you can do that stuff here. So once you have access to the RGS online content, basically, so the one that Gitanjali covered. So if you have a 3D data, elevation data, you have to access WebC, just add the data and perform analysis, or just use it for visualization. So over to you, Gitanjali.
Moving on. I hope we are holding your interest and you are excited to see what all are the remaining capabilities and all. For ArcGIS Online, for organization, there are a lot of capabilities. Some of the important ones include smart mapping, analysis, sharing and collaboration, groups and all. So smart mapping, first and foremost, it's a functionality of ArcGIS which let us explore, understand, and find meaning. So basically, it helps us to find patterns in a more intelligent way, according to what the data is that we have. Like, is it a point data or line data or polygon data? Say we have some mountain peak information, some watchtower information, or some road network. So according to what data we have, a particular kind of suggestion is made by ArcGIS Online to display it in such a way that it becomes easier for us to understand the patterns and find answers, right? Then there is analysis. Analysis helps us in performing different types of analytical work using different tools like how I said in the last slide. We'll go through that again here. Then there is sharing and collaboration. If you have some kind of data with you, how can you make it available for others in your organization, or to anyone in your team, or maybe to public itself? How to do that? All these capabilities are there in ArcGIS Online, and there is something called groups as well, which we'll know in detail in coming slides. To take you through all these capabilities, let's go back to ArcGIS Online platform. So, like I said, the data that we add into ArcGIS Online is available in content, right? So, I can access a data by selecting the web map that I've created, or the feature layer that I have created. Accessing a particular web map will take me to map viewer, right? We are just taking you through these access functionalities again and again, so that you'll understand, you'll have a better understanding of how you can proceed in ArcGIS Online. Once I access or click on my web map, it will take me to map viewer. Like I said, what all feature layers or spatial data layers that I have in my web map will be displayed in my content. I'll get the list from the content section. And now, what all I have to do, I have to work with the data that I have, right? I'll have a base map. Again, I can change base map from base map gallery, and I have the feature layers here. To move forward and understand smart mapping, like I said, ArcGIS Online suggests us a change of style, or a pattern, or a particular style, which will help us to identify the pattern in our data. Now, this depends upon what type my data is, right? Like point data, line data, or polygon data. Let's take this example. This is the data from a San Juan National Park, and I have point data of mountain peaks here. If you come below, you can see that there are some kind of options here, like showing legend, the attribute information, the data value behind this data that is displayed. Then there is something called change style. On clicking that, ArcGIS Online gives me some options. There is one option where I can choose which attribute is to be shown. Every data will have multiple attributes or multiple information behind it, right? For every point on earth, multiple information will be there, which we can incorporate onto that spatial data and create it a spatial data. I can select which attribute is to be shown, right? And I have different drawing styles. ArcGIS is recommending different drawing styles, which will help me identify the patterns in a better way. One is selecting a drawing style directly for symbology, right? I can select the symbol I want, the shape I want for my point data. I can provide fill or outline, whatever customization I want for that. Or ArcGIS Online also helps me to generate heat maps for a point data, which means it will help us understand the concentration of these particular points. Now, this will be more efficient if you're working with fire sports, right? You have locations where fire hazards have happened over a period of time. So to understand the heat map on which area maximum fire has happened, you can use a heat map. Rather than understanding or visualizing it directly, a heat map might provide us more information about the concentration of that activity, right? So this is a smart behavior that ArcGIS Online is helping us to understand. It helps us to understand the hidden patterns that are not directly visible to our eyes, right? When we are talking about roads, again, the options that are given will be different. You can see that the drawing styles are different. I can provide unique symbol drawing styles for each line that is there, or I can change it directly. I can change the group symbol as such through this option, that is a location option. For whole of the symbology, or for every symbology for road network that is there, I can change it directly. Again, if you would observe, the options that ArcGIS Online provided me were different for point data, where heat maps were provided, and location wise symbology format was provided. Whereas for roads, again, it was different, right? They gave me unique symbology for line data or group symbology or similar type of symbology for a particular feature class. This is the same case for polygon features as well, which means according to the type of data that we have, say point, line, or polygon, ArcGIS Online gives us some smart mapping options which help us to understand or help us to identify the hidden patterns that are there in our data. So this is about smart mapping. Again, one more important functionality that is there or capability that ArcGIS Online provides for organizational account is analysis privilege. Like I have already told in the last slide, there is a button called analysis over here, which help us to analyze the data we have. One more thing, we can perform analysis for each individual feature layer that we have put in our web map. You can see that for every feature layer, there is an option for perform analysis. Now, to go in detail, I have selected perform analysis for this particular San Juan National Park mountain peaks data, which is a point data. You can see that there are a lot of options here, like summarizing data. Because it is point, I can have an aggregate point data to understand the aggregate of the detail over a place, right? Similarly, there is like summarizing nearby. You can summarize the details nearby a particular point, right? And so on. You have options for find location, data enrichment, proximity, and all. Proximity is one of the common analysis that we normally perform for data types, right? Be it site suitability analysis or land use land cover planning. This is something that always comes in handy, the proximity analysis. What does it mean? Proximity means finding the nearness of something, right? So like I said, for the example that I've quoted earlier, suppose you want to create a buffer around the camping grounds. You can use a proximity analysis for creating buffers. Or for example, in this case, if I want to create some watchtowers over some place for understanding or watching out fire hazards, again I can create buffers around the fire sport that have happened, or use various layers and understand the existing watch towers that are there, so that no two towers are nearby each other, and so on. So how to use these particular tools? You will basically click on it, which will take you to the analysis page where you have to provide the data, right? For buffer, you have to provide a buffer size. The data will be already added. You have to provide a buffer size like 1 kilometer or 0.5 miles or whatever, according to your project or the question that you have, right? It will give us additional options as well for buffer overlap. Like when multiple buffers are created around a point or line, there are possibilities that the buffers might get overlapped. So how do we want it? Do we want the buffers to be overlapped like this, or do you want the edges to be dissolved wherever the buffers are overlapped? So we have an option to understand that. So once we set the criteria and parameters and provide the result name, the analysis will be run and you will get a result. Similarly, there are many other tools as well, like create drive time areas, finding nearest, and all. There is something called overlay analysis. Yeah. uh, some of you might be familiar with overlay analysis, which means when you have multiple data set with you and you have to come to a geospatial solution for a problem, you will analyze these multiple data sets and you will overlay it with different data sets to come to a conclusion, right? So this overlay layers tool is also given here in the manage data perform analysis tool, where you can put an input layer and choose an overlay layer. What does it mean? You're keeping one layer over the other and finding something out of it. Just as simple as that, right? You will provide an input layer and you'll put another layer above it, right? And you will choose overlay method here. We all are familiar with the Venn diagram, which we studied long back in our school days, right? Same thing is applied here. Like we can intersect these two layers because we are keeping one above the other. We can intersect and take the common ground, common area of interest. We can combine these two and provide a union and get the whole data out of it. You can also erase the unnecessary parts, like you have two different outcomes from two different analysis. You're overlaying the data. You just want some part of it. You will keep the part that you want, and you can erase the part that you are not no longer needed for you. So you can choose different overlay method here. Again, you will run analysis and you will get a result. So ArcGIS Online is basically providing you with so many tools that will help you to come to a conclusion for a spatial problem. Yeah. So once we do some kind of analysis, what is the next step? We have to share the data to someone, right? It could be that you want to share it with your teammate or with your lecturer or with anyone who is on the same project. You can either you can keep the data as private, or you can share it with your teammate with the help of this particular option. Like I think Ajit has already mentioned it. You can share the data with everyone, or within your organization, or within a particular group. We have a detailed session on this from where I'll explain you how to create group and what are the difference when you're sending it to a group or sending it to organization, etc. Again, we have options for creating web app and all, and like Ajit has already suggested, we'll be going in detail with these exercises as well. So moving on to next part, I would like to hand it over to Ajit.
So coming for the next slide or the concept here, we're going to talk about how we can, as an administrator, how we can configure or administrator an ArcGIS online organization. Suppose, what does that mean basically? If you're basically administrator, what it means? So basically with administrator, you'll be giving all the privileges. Let's say, suppose you want to put like you want to design, let's say design a homepage for your organization. Let's say here, this one here. Second, you want to define the gallery or configure the gallery for the public. Let's say what's visible for the public users and what's not visible. So what information you want to hide it. So that can be.
Can you delete this message? Can you delete this message? What? Can you delete this message? Delete that. What are those?
Okay, sorry for that. And then how we can create groups, how we can manage groups, and finally defining the security also, whether to allow access to the anonymous users or not. So it can be defined by the administrator. So he can basically, yeah, and definitely he can add the members as well. So you must have received the email with all the details of your credentials. So that was basically done by the administrator. So let me just show you all the functionalities available for the administrator. So as you know, we do have this homepage now with us. Once you access and once you sign in, you'll be able to go to that homepage. Then under this organization tab, we can manage all those settings that we are talking about. So let me just go to the organization here. In that, as you can see, we do have something called this members tab, where I can see all my members. Those are part of this organization called this one here. You can see all the members have been added. Then you can check their role here, last login information, user type, and the role. Roles are basically what? So admin, as I said, can do literally anything, like creating groups, adding members, managing content, most important, and how that can be shared with the users. Data editor, they can basically do the editing. Like suppose, let's say you have seen the data for the Coimbatore city. Suppose the data, if you have given the role called data editor, means you'll be able to change this role, edit those data basically. Then we do have facilitator, then publisher who can actually publish the data, user, and finally viewer. Viewer means you can just visualize the geospatial content. So they cannot create new content, they cannot perform analysis, just visualization. That's for the member part. So they can go ahead, the administrator can go ahead and add the members here. They can also manage the licenses, and under the settings tab here, we can perform the, we can set the security also, like designing the organization profile, like this one. So this page is basically configured from that particular option. Here, you can upload the logo, the image part. You can define the home page, the gallery, what could be the visible to the like public. You can define the map, or do you want to start with different types of viewers, let's say beta or classic viewer. Then you can define default base map also, whether do you want to use imagery, like satellite imagery, or some vector map based, or such as light or dark gray canvas. Then units can be decided here. And web styles, analysis layers can be configured here. Groups, most important one. Like groups are basically like, let's say you are a part of an organization called Coimbatore Municipal Corporation. And in that, there will be having multiple groups. Let's say one for the water supply, second, let's say for the fire department. So not all the users are basically part of two groups, right? So the few users or few like workers will be part of one group. So, and the content, like limited content, or the content which is basically related only to water supply, let's say water connectivity, water network. So only that particular network will be shared with them. And there will be like certain things which should be common in, let's say, fire brigade team or even the water supply team, so that they can work in collaboration. So that content will be basically shared in between these two groups. So that can be again managed from the administrative content. So like managing roles, then collaborations. Let's say there are like two organizations in Coimbatore or any city. Let's say one is central government, again another run by the state, and they want to collaborate. So they can create a collaboration. So by creating a collaboration, you can basically, you will be going to give access to the access of your data to the other organization. So that's the collaboration. Like there are two ArcGIS online organizations, and you can build the collaboration. You can share the content in between them, and they can work together. Security, here we can check it out, whether to allow anonymous access. You can define it from here. Like then members can share content publicly. So all this stuff, such as the password policy, whether social media links and groups, those links should be displayed or not. All these stuffs can be configured here. And the logins also. Login with the Facebook credentials, whether we should allow it or not. That's basically part of your organization policy. Then comes multi-factor authentication, such as you know, once you sign in particular, let's say some apps, let's say the same app, COVID app, right? Once you sign in, once you give your number, you receive an OTP. So you have to put that as a OTP as well to sign in. So that's basically multi-factor authentication. So your password as well as another OTP, that's multi-factor. So you can, all the security thing can be configured here. So, and the open data, if you want to enable it so that it can be accessed. And if you have any other further organization settings. Now coming to the gallery, so which all we showcased by Gitanjali. So I can define which content can be shared in public and which should be behind just for the members of the organization. So that can be configured here. And coming to the groups now, we can add groups here like this. You can go ahead, create a group, let's say for, as I said, with the same example called Coimbatore Municipal Corporation. You can create group from here and invite the members inside this particular group. So that is the administration part of a ArcGIS online. So over to you.
Thank you so much. Thank you so much, Adi sir. And students, so after this warm introduction to the ArcGIS platform, I think you will be ready to do a hands-on, to just try your hands on the software. So our team is helping you through Telegram app and in the chat window. Whoever has not yet got login, please please post the messages and try to get the login. And also we have posted the hands-on exercise. Now I call the team to show the hands-on.
So before you guys start, let me just give you a small introduction on this exercise basically. So here we have a scenario. So let's say the scenario is about the Coimbatore Municipal Corporation is looking for a second specialty hospital location for that basically. And they do have some criteria such as that new location should be within 1 kilometer of urban areas. As you can see in the screenshot here, urban area data we have like light pink color. Then the second criteria is what? It should be like more than 10-minute car drive from the current hospital, so that it should not be basically close to that current hospital, right? It will be like unnecessary thing. Then third is like it should be within 0.5 kilometer of main roads, like for better accessibility. So by they have these 3 spatial criteria, and by using these spatial criteria, they want to get locations for a or to set up a new specialty hospital within this particular city boundary. So that's the scenario for this exercise. So you'll be giving 40 minutes of time, and everything is explained and covered in that particular tutorial. So we will be showcasing or we'll be putting that particular information here as well on this screen so that we can do it together.
Thank you. So students, whoever have got the license, start working immediately and try to follow it. But whoever has not yet got the license or have some issues, don't worry. You will have the license for the entire day. So after, like, once it gets resolved, you can still practice. So keep following.
So you can see my screen, right? So I have shared the exercise here. So currently it's 6:05. So kindly complete the exercise by 6:40 at least. Or 6:45. Yeah, we'll make it to 6:45. And as you can see, we do have like the same criteria is covered here. And this is the map link. So once you click it, you will be asked to sign in with your account. And once you sign in, you'll be able to see the exercise web map. So I'll just go to like I'll cover a few steps here. I'll give you some time. So by that way, we'll be going together. And as you can see, once you get the access to the map, just save the map and save with this site a new hospital in Coimbatore. And don't forget to give your name in there, something like this. So if you have any issues related to the exercise, you can use this Telegram app. You can share the screenshots there as well. So those who have access to the account and hope you are able to save the map with this particular name. So you can go ahead with the next session, which is on the creating a buffer urban areas. So like this. So you can refer the screenshots here. So this is the first tool that we are going to use here called buffer. And as you can see, here we have to keep the distance. So it's like a typical tool, how it looks like. So you have to define you have to give the input. Then we're going to choose the size, the options, whether it will be overlap or dissolve. So finally, it will be looking something like this. Give the result layer name, followed by your name or initials, and then click run analysis. So once you run that analysis, you'll be able to result something like this. So it's buffered around the urban areas. So that's like one of the criteria.
Just an announcement, those who are not able to have the login, or those who have internet issues, don't worry, the license will remain with you till you finish the assignment. We will give 2 days till 11 June. The license will be there with you, so you can do it, and the recording will also be available. So the team is working on it, and you will get it.
So once you create once you done the first tool, so we're going to create or use another tool called drive time areas. So as one of the criteria was like the new locations should be like away, 10 minutes away from the current hospital. So for that, we are going to use another tool set called, it's again under the proximity only, and it's called drive time. So it basically uses network analysis in the backend. It's a network service basically that we have seen in the demonstration part, where we created routing, right, point between point A and point B. So should be able to fill the details for the two parameters like this. Take input as a hospital, then drive time, and 10 minutes here. So that's the parameter. So as you can see here, we do have an option called use traffic. So we can also incorporate or call live traffic service. And in the end, you have to select travel direction, which should be towards facility. It should not be away from the facility. And don't forget to dissolve all your areas and give the drive resultant layer name. That's the output. Specifically, as you must have observed now, it's going to create another layer. So once you perform any analysis, it takes the input, you define the parameters, and then it's going to create another layer, or basically it's new output. So that's why we call this a geoprocessing. And to do that drive time analysis, you'll be able to see this result. Select buffer around that particular hospital, as you can see here in the purple color. So once you do that drive time analysis, we're going to run the buffer two again. And this time we're going to use input as a main rules. So let's see. So as you know, the special criteria was what the new location for the new hospital, specialty hospital, basically should be like within a distance of 0.5 kilometers from the main road. So it's quite simple. Take road as input here, as you can see. Then define 0.5, enter the buffer size, define the unit as kilometers. Then in the end, make sure that you're going to select dissolve. All the buffers will get dissolved. It will be like one seamless buffer. And then give the resultant the output name as this one, buffer roads, 0.5 kilometer, and followed by your name. So the output name is quite important because you should be able to see what that layer is about. And for all the tools, please do not use this option called use current map extension. Just make it unchecked. And then hit run analysis. So as you know, so far we have ran like buffer first, drive time analysis, and third again buffer for the main roads layer. Once we do that, now we're going to start with our next tool. It's not analysis basically, but we're going to change the like symbology of it. It's like fun. It will be like new learning for you. So as I said, it's not analysis. It just, as you can see, map is looking very cluttered, right? I don't know exactly what is what. So what we are going to do is we are going to use this option called change style here. So I will also show you parallel like this here. So whatever buffer you have, you just have to use this option called change style. And so make sure that you're selecting this layer only, buffer of roads. That should be your input, like this one. So whatever you have, buffer layer should be there. And here it should be show location only. And then you have to click on this options button, click symbols, this symbol here, and go for the screenshot here. And then you have to give this value for the color, like this one here. It's basically code for this dark gray color. Just you can enter it here, or you can select the box also, as you can see here. And that was basically for the polygon, right? Since buffer is a polygon, we're going to use this fill button. And for the second, which is the outline, we are going to use this particular color, and we are going to define the line width like this. You can try for this screenshot again. Select this particular color, make it, set it to 1.33, the line width. Once you do that, you will be able to see like this. You can see this gray area. It's basically buffer of a road network. And you can see this color system, that line color or line width. So once now we have covered, done with the buffer two, the drive time analysis. Again, buffer for the road. First buffer, as you know, was for urban areas. The one in the blue color here. The purple area basically indicates drive time, 10 minute walk, drive basically. And the gray polygons is basically what? 0.5 kilometer of a buffer for major roads. So the next is what? So we're going to do overlay analysis. So we are going to combine buffers and drive time areas. So basically this area should be avoided, right? The one in the purple. I mean, it should not be within the zone of a 10-minute drive time. So that area should be excluded. Otherwise, the new hospital should not be in that zone. Like it should not be nearby to the existing. So we're going to run now tool called overlay analysis. And as you know, to do that, we have to turn some of the layers, such as buffer routes, not needed right now. Just turn off the layers, specialty hospital, the routes, as well as the urban areas. Once you do that, you'll be able to see only those two required layers, such as the buffer of urban area and the drive time. Then review your map, and we are going to perform analysis on those two layers. Let's do that here. Now, since Gitanjali has already covered that part, so let me just show you here. So for the input layer, you can see here we have to give two inputs. So first is like buffer of a urban areas, and second input is drive time, the result from the drive time analysis, right? So first, make sure that you are giving compulsory this buffer of urban areas and drive time. And we are going to use this erase tool because the area, which is basically inside the drive time area from the 10 minutes or from the existing hospital, we are going to remove it. Since we're not going to build the new hospital near to the existing one, so we are going to use erase this time, the overlay, and give the name as a suitable one followed by your name or initials. So overlay, we're going to basically overlay two analysis, and we are going to erase the common area between these two polygons. So once you run the analysis, you'll be able to see the result like this, right? Okay. Now, next thing, we're trying to remove those areas which are not basically, which doesn't fulfill the or not part of our criteria. Next, as you can see, we're going to turn off the drive time, the hospital buffer area, and the urban area, since these two were basically part of this particular analysis. Now, since we got the result and the resultant layer name is suitable one, we just need to turn off those two things. Like this. So we got this area. So this is basically now fulfilling one criteria. Like the criteria is what? It should be 0.05 kilometer from the urban area. So you can see this, observe carefully here. Wherever the purple part and the blue part was overlapping, we erased it using the overlay analysis tool. Please go as per the screenshot that we have. That might be a small mistake here. So go as per the criteria zone. Don't select 2 miles. Okay. Like 1 kilometer for the urban area. Yes, 1 kilometer, not 2 miles. So as you can see here, this particular screenshot as well, like this one. Urban area, 1 kilometer. So here. choose distance 1 kilometer for a group. Okay, so let's continue with these overlay analysis again, where we're going to talk about, we're going to use that tool once again to include the common areas. So we have excluded the areas which were part of the drive time. So yes, we use this erase method. Now, coming for the last criteria, which was like it should be within a buffer of what 0.5 kilometer from the route. So let's do that. So I'm going to show directly the screenshot here, as you can see here. Okay, thank you, Mr. Diaz, for confirmation that you have completed the exercise. Please let us know. We are here to answer your queries. You can put it in chat box or use Telegram app. And coming for the next overlay analysis, what we are going to do is we are going to use the result of the last overlay analysis tool, where we use this erase option that's basically suitable one area, and we're going to choose another input like buffer of a route 0.5. Now in that case, we are going to use this intersect. Means I'm going to keep the common area, not merge, like not the union, not the erase, but now we have to keep it like the hospital should be an area where it's just away from the like 0.5 kilometer away. Then output should be the areas, of course, and don't select this option called use. Let it be unchecked. Use current matrix. So once you do this analysis, you'll be getting the final result here. Okay. So to get like the final output, just turn off the suitable one and the buffer routes of 0.5. Those layers. And you'll be left with this option. I mean, these layers or the web map, where you'll be able to see few pockets of areas which are basically suitable for the new specialty hospital in Coimbatore city. So by like using all those criteria, by considering those criteria, using tools such as buffer analysis, then we use change style where we dealt or we learned about how we can change the symbology. Then third, we used overlay analysis with erase method. Again, we used overlay analysis with intersect method. So you'll be able to see results similar to this. So I can see some of you have completed the exercise.
So we will be moving ahead with a small quiz. In 6:40, you will get a quiz and you will get 5 minutes to answer the questions. Okay, so whoever has done the hands-on or whoever has not done the hands-on, all of you are requested to answer it. And then we will also show the results.
The quiz has been sent in the chat. You will be given 5 minutes exactly, after which we will close the responses. The workshop ID is the username for your ArcGIS license.
So I hope you must have got the answers also. Now we have a short break, like just for 2-3 minutes, and then from 6:50 we'll again start the next session.
Where future is driven by imagination. Experiential learning creates diverse opportunities, where industry exposure and international partnerships help you sail. Come, start your journey towards success with Amrita University.
Hey guys, are you still searching for the right master's courses? Then stop. Your search ends here. Center for Wireless Network and Application, Amrita Vishwavidyapeetham has opened its admission. You can be eligible for scholarship also. If interested, you can apply using the link in the description box.
Hi, I am Akshay Sadish, MTech Geoinformatics and Earth Observation student from Center for Wireless Networks and Application, Amrita Vishwavidyapeetham. My research area is in the coastal change detection using satellite imagery. Recently, in one of the symposium organized by the center, I could meet up delegates of ISRI India and discuss my research work with them. They were interested in my work and offered me an internship. Now I am working with ISRI on GIS and remote sensing to estimate the coastal erosion rate. I am happy that I am contributing to some of the UN Sustainable Development Goals. I thank my faculty and staff members at Amrita WNA for supporting me. Thank you.
So here are the results. We can see most of you have correctly answered, so it's good. We are going in a good shape. Okay, let's move to the next section. So
Yep, sure. So, Gitanjali.
Yes, Ajit. Thank you, everyone. So welcome back. I hope the session is interesting and like you're looking forward to more sessions like this. Okay, moving forward. Till now, we have understood the user interface of ArcGIS Online, the various capabilities, starting with adding data, base map, how to perform analysis, and so on. What is the next step? It is to share the data, right? So ArcGIS Online provides us several options for sharing content. It is easy to share relevant, authoritative, and compelling content to the person within our team or to the public who are in need of these results upon which we have been working, right? But first and foremost, the basic step will be to add data to ArcGIS Online. You add data to ArcGIS Online, you perform the analysis required, and once you have the result, next will be to share the data. There are various methods for that, starting with keeping the data private. The capability is always there where you can keep your data private without sharing it to anyone. There are other functionalities where you can share it to organization or with everyone, or make it a public data or share it to specific groups. We have touched these topics in a very brief way till now. So what I'll do is I'll take you to ArcGIS platform again, and I'll let you know how to understand whether the data is publicly shared or is it a private data, how to share the data in groups, and so on. Starting with the basic platform of ArcGIS Online, we are in the contents page of ArcGIS Online, and you can see the data that I have shared right now. If you will have a closer look at these data that has been shared, you can see that particular icons are there for all data that has been shared, right? You can see a person's icon here and a globe icon here. So what does it mean? This is a feature, this is a dashboard that I've created. Some data, okay, we'll just keep it like that. Some application that I've created, we'll come into it, what exactly is a dashboard, and we'll understand it in detail later on. So this particular item in my content has not been shared. If I put my cursor upon this, you can see that sharing level is honor, which means the data is private. I have not shared it with anyone. Whereas if you come to the below application of hospital data of Coimbatore, you can see that the sharing level is public, which is denoted by a globe's icon. Similarly, for every data that is there in your ArcGIS Online content, you can update the sharing level, you can restrict the sharing access, or you can provide sharing access at any time. Once you click on this particular sharing, you are given a choice to update the sharing criteria. You can remove the sharing access for team, or you can upgrade it into more people so that more people will be able to access the data. Look at this. Now the sharing level is set at honor, which means data is private. There are other options like keeping it in organization. What does that mean? Your account for Amrita Vidyapitham. So for your organization, Amrita organization, who all members are available, which all member has an access to your organizational platform, the data will be shared into that. That is the meaning of sharing data within the organization. So any person within your organization will be able to access the data that you share with organization. Then comes sharing data in public, which means you're making it accessible to any person who has access to ArcGIS Online. Not just within your organization, anyone, any member, maybe from any other organization or personal credential, whoever, you are making your data available to everyone. Now this happens when you are doing some kind of analysis and the result has to be shared with public, right? The earlier option for organization comes in such data which is restricted to your organization, right? For example, some confidential data of a government agency. That particular government agency can share it within their organization, which means anyone outside their organization will not be able to access that data. Then comes another interesting privilege called group sharing, wherein you create a group. Like Ajit has already mentioned it in his previous slide. Just to go deeper into it, in group sharing, what you do is you create a group, or you're asked to be a part of a group, right? You're doing, suppose you're doing a project in your organization or university. 5 of you are doing the project. There will be a supervisor for you, an instructor, right? So all 6 of you are within this project, and what all analysis that you're doing should be shared only within this particular group of your friends or classmates or colleagues. What to do in such a situation? You don't want to share it with whole of Amrita team. You just want to restrict the access to those people who are there in your project. What you do is you create a group with all these members who are there in your project and share the data in this particular group. In that situation, what happens is we can set group sharing, and if I select this edit group sharing, the groups that are available within my organization will be available, and I can select the group accordingly. I can select it and then click OK to share it only within this group. I hope it is clear. What all are the other options? Like I said, if you could recollect our earlier sessions, if we go to the item detail from content, that is, if I access any item in my content, be it a feature layer or be it a web map or anything, it will have the background information. The item detail will have the background information over here, like how Ajit has quoted the word metadata. That is an apt word for it, because all the background information that is required, the data of the data is provided in your item detail. And you can see that there is a share option here as well in your item item detail page. The same privileges are there. You can set it to honor, make the data private, keep it within your organization, or share it with everyone in public, or provide it to only those group within your team of project. Now, how to do that? Let's go into that. So when we started learning about ArcGIS Online, I told you that there are a number of tabs over here. Each has different functionalities. So we are going to understand the functionality of this thing called groups. What will happen if I select it? If I select the group tab, it takes me to the functionalities of creating group, adding data, managing group, and so on. So this is how it looks like. We have, there will be the number of groups in your organization will be displayed over here. So how to create a new group for your project? You go here and you click on this and you create a new group. You provide all these parameters like name of the group, summary, and so on. You provide the group membership information, like who can be in this group, which is restricted to your organization members only if you're going to create a group of your classmates or colleagues, right? And then there is a parameter like how can people join this group. You can provide this criteria that you can invite someone to join this group, or a person in your organization can request to be joined into your group, right? So this is upon you. Like when you create a group, you have to provide these criteria how a member can be added into this particular group, or they can add themselves. Now there are parameters like who can view this group, like is it visible to everyone or only your organizational members, or only a group member, a particular group member, right? Again, contributing a data, can everyone contribute data to this particular group or item to this particular group? And like who all can see the member list of the group, so on, has to be added here. Once you do that and save this, your group will be created, which is when you go for group sharing here, that is when you go to share option and go to edit group sharing, your group will be visible here. You'll select the particular group and you will click OK. So this is basically about sharing data. So again, let me brush the whole thing. You can either keep the data private within yourself, or you can keep the data within your organization. See, either it is one thing is keeping the data private within yourself. You don't want to share it to anyone else. You can give it within your organization. right? So every member in your organization will be able to access this data, or you can keep it open for public. So everyone who has access to ArcGIS platform within or outside your organization will be able to access the data. Or you can keep it in a particular group according to, like how I said, a particular group of people who are doing the same project. So that is about sharing GIS content. I hope it is clear. So over to Ajit for next session.
Thank you. So I'm going to talk about the next topic, which is on the arcade expression language. So arcade is basically a scripting language. So it's like a portable, lightweight, and secure expression language written for using ArcGIS platform. So the applications such as the ArcGIS Pro, the ArcGIS Runtime, ArcGIS Online, or the ArcGIS API for JavaScript can, like this, in this application you can write, share, and execute these arcade expressions. So why arcade is important? So basically, arcade is basically designed specifically for the creation of custom visualizations and labeling. So it will basically help you to configure your pop-ups, the labeling part, and since, as you know, since it's like an expression language, it has its own like mathematical calculation. So with this arcade language, you can perform mathematical calculations, then you can manipulate text, then you can evaluate logical statements in your data. So using this simple expression. So you can see here one example here. So since I have a data of, let's say, population, and that to be I have data of 2000 and 2010, a total population data. I want to get the change in population in percentage. And since I don't have that calculation or the information available with me, I'm just going to use this simple custom function of an arcade, which will give me the percentage of change from change in population from 2000 to 2010. As you can see, this is the expression. Quite simple, right? Like the feature total population of 2010, right, minus population of 2000 divided by the total population of 2000 into 100. So this simple expression will give you the data. So basically, you're going to use the existing data, and you're going to use mathematical functions, and you get to get the exact new information. So by using mathematical operations. Or here you can see at the bottom, we have configured the pop-up using arcade expression, which gives you the again, population, the ethnicity of a population, whether it's German, English, or Irish, and you can see here the functions available. So these are like few of them. There are like hundreds of functions available, like angle, average, area, which you can configure in ArcGIS platform. So let me quickly show you one demonstration. So as you can see here, I'm going to use the same data that you're going to use in your hands-on exercise 2A basically. So let's see here. So as you can see, we have this site, a new hospital. Now you must be familiar with it. So I'm just going to turn off the Coimbatore data, and I'm going to click on those areas here, urban areas. As soon as I click, I get the information called population of that particular area and the area in square kilometer. What I'm looking for is, I don't have, since I'm looking for the population density parameter or the information. So as you know, population density is what? Population divided by the area, right? Since I don't have that here, let's check that information whether we have any table also. So if you see the urban areas and click on this table options, and you can see it here, no, we don't have that population density. So let's use the arcade expression to mathematical expression and calculate the population density. So for that, I'm just going to use this 3 dots here, more options for the urban area. Then we do have option called configure pop-up here. That's it. So you'll get this window here. Slide down, you'll see this option called attribute expressions. So in that, I'm going to click this add button and enter this simple formula. So what's that? So these fields are already with me, right? The population and the area as it is. And in Arcade, we use this something called dollar feature and then charge followed by the attribute field. So you can see this area attribute field right here. Let me show under the globals. You can see these are the fields. Check it here. Globals. The current layer called the urban area have 3 fields inside that: object ID, population, and area. So we are going to use these 2 fields. So as you can see, those are correctly included here. Population divided by area. That's it. Give some name here, custom. Let's say density, or population density like this, and test it. Don't forget to test your expression. That's it. Can you see the result here? So for that particular urban area, 697 is the population density. So I'm just going to hit OK. And again, click OK here to save that. Now you can see the table also got automatically updated. Can you see here at the bottom? Population density, we got it. Let's check the pop-up as well. So click on any one of the, let's say, urban area. You'll see the population in area was already there, but we were able to get new information now from the existing data. So earlier what we used to do is you have to create another column in your this attribute table, then do the calculation separately in calculator or any other formula. But with this expression, with the Arcade expressions, you can manipulate your data in just using simple expressions. So over to you.
Thank you, Ajit. Next comes a very interesting part. So you know how to add content, you know how to create web map, you know how to share it. Now, how can we further play with the data that we have? We can create apps from maps. You heard me right. It is possible to create a web app with a map using a variety of app builders. You can choose any app template that is available within ArcGIS Online with minimal to no configuration required or no coding required. You will customize your app before publishing. You have multiple templates to work with, multiple methods to work with, right? Either you can download a template and use it, or you can use ArcGIS Hub to create a website and so on. So the capabilities are endless. So I'd like to directly take you to the demo so that you'll be able to appreciate more. Going back to ArcGIS online platform, again, we are back on the contents pane. You can see that I have a web map here. So what we are going to do is we are going to create applications from the web map that we have created. We have added data and we have created a web map. So we are using that to configure an application now. You can see that I've created sample application. So once you have created application, this is how it will look like in your content. If it is a dashboard, you will understand it by it. If it is a mapping application, again, the details will be given like that. Okay, to go forward, what I'll do is I'll try to access this particular web map. So opening this will take me to this page, again, item details page. So, okay, to go further, if you observe this item description page or item details page, you can see that there is something called create a web app here. So there is a button which is telling you that you can create a web app through this. How to do that? Drop it down. You can see that there are multiple options or choices given to you for creating different types of applications, starting with configurable apps, web app builder, story maps, dashboards, and so on. So myself and Ajit, we both will try to, demonstrate as many applications as possible for you so that you will be interested to create your own. Before I proceed, again, I would like to tell you that ArcGIS Online is a very big platform with a lot of capabilities. Please explore it as much as you can because there are a lot of functions and it is not easy to cover it within a short duration, right? So, okay, moving forward, you can see that when I select this create web app, I get a number of options, starting with the first type of app, that is configurable apps. ArcGIS Online includes configurable apps, which provides a suite of app templates. You are given ready-made app templates, including stories. So you can directly access the template, add your data in it, and make your stories come alive. To do that, what I'll do is, let me start with configurable apps itself first. I'll access the first option of configurable apps, which will take me to a dialog box, which is asking me what you want to do. So the dialog box is interacting with us, or the configurable app is interacting with us to understand our criteria, according to which it will be able to suggest us what type of application template we can use. You can see that there are a lot of choices, like using instant apps. So there is attachment viewer app, where you can provide attachments, imagery viewer app for your imagery based applications, or applications with interactive legend. So you can interact with the legend. You can click on the legend and get more information out of it. Then there are collect, edit data, and so on. So many types of templates are there. This one, collect or edit data, is a basic template for a configurable app. You will have even more templates, like for summarizing data, for social media, and so on. So what if I have to just create a basic app for collection or editing data? I can use this particular basic viewer template, or I can go with any template that you want. On selecting this particular template, I get an option that it tells me what this does. Basic viewer basically is a general purpose app with a collection of essential tools in it, including edit and print. So if that is what I have to do, then I can select it, or I can go back and select any other template that is available for me. To start, I can click on create web app, or I can download the template and do it as well. Let me try to do it online itself. Moving forward, once I go for creating a web app, it will ask me to provide a few informations and parameters, like tags, the tags that can be used to search my app, the title for my app, and so on. So once I provide these parameters and click on done, what happens is it takes me further so that I can configure my app. So I have selected a template. I have given the parameters for the background information or metadata or item details. I have provided the heading. I have provided information regarding the tag so that anyone can search my app, and so on. So once this gets loaded, again, what I'll do is I'll provide further information as to what can be the base map that I want, or I can basically configure my app. I can, make it look the way I want it to be. Let's wait for a few seconds for it to load. Meanwhile, let me show you how the app will look like. I'll show you a configurable app that I've created. So once you, go forward, yeah. So you get all these options where you can provide title for your application. You can select the theme of your, app. You can provide header color. You can basically customize your app, right? So once you provide all these options, like base map gallery, the things that you want, the details that you want, you basically save your app according to the changes, changes that you make from the default type. You save your app and you launch it. On launching the app, you will be taken to your configurable application, which is accessible in your desktop or in your tab or phone or anywhere. You can use these apps, which are directly readily customed with the templates. It will give you the privileges that has been there in the template, like print privileges, basic editing, base map changing, and so on. You can see the layers of the data, layers of the map from these particular options. So this is as simple as that. Configurable apps is so simple. All you have to do is select a template, select the data, go for configurable app, select a template, and launch, do the customization and launch it. As simple as that. No coding is required. Also, you get a variety of templates according to your choice. So that was the first type of app, configurable app. I hope you got interested, and maybe I hope you will be trying it out. Going forward, there are other types of apps as well. Like I said, we have a web app builder. What does this mean? Like if you wish to build a more powerful GIS app that run on any device without any coding requirement. Again, the other one, configurable app, was directly through a template. Web app builder is a powerful GIS app tool which will help you to build a more powerful application, right? You will have more choices. You can put widgets or tools that you want into your app. You can make your application more interesting. And to do that, we'll launch the web app builder. Again, you have to provide the title, tags, summary, details, and so on. You can save it in a folder inside your content directly, in all contents, or you can create a folder and save it there according to your wish. So once we click it and try to launch web app builder, again, web app builder will take you to the customization page where a variety of options are given to you. You can select a theme for your app. Again, you can select the base map that you want to add for your map. You can go with the one that is there in your web map, or if you want to use a different one, a different imagery, you can use that. And the most important thing, you can add widgets here. Widgets are basically tools that that are useful for your application, the tools that you want in your application, like direction tool or editing tool or analysis tool. All that can be configured from here. So to start with, we can select the theme. Again, there are a lot of themes that are given here, which are kind of similar to the template. What happens is, according to this theme, your application will be configured. So you will have a rough idea of how your application will look like, an outside idea of how it will, it will be displayed. So accordingly, you can select the theme. Every theme will have different types of appearances, different numbers of widgets. Like for example, the foldable theme, which has been selected here, has this type of appearance. You can see some numbers over here from 1 to 5. These are spaces where I can load my widget. We'll come to that. So first and foremost, you will select a theme, right? Yeah, so I just changed my theme from foldable to billboard. Moving on, I can, configure my map. So what base map do I want to give? Can it be the original one which is there in my web map, or do I want to choose a different one? It's up to me. I can set extent, initial extent. It can be either current map view, which is displayed over here, or web maps default extent. Like, it is upon me. Again, I can customize it. I can customize scales as well, like in what scale, which layer should be, in what scale the map should be limited, in what scale it should be visible. You can set, refresh interval layer as well. I hope Ajit has already explained this. Moving on to the important part, that is widget. Widgets are tools, like I already said. So you can configure widgets over here. To start with, if I select on, you can see that when I am moving my cursor to this number one, the number one in the application template gets highlighted, which means whatever widget I'm configuring here will go and land over here. Selecting this particular widget option, you can see that a lot of tools get popped up. So it is up to me which tool I want, or which widget. This is what we call, each of these are widgets. So it's upon me which one I have to configure in my application. Suppose I want to, go for an attribute table or base map gallery, the most important one. If I want to configure a base map gallery into my application, I'll select this and I'll click OK. It will take me to this particular, page where I can configure custom base maps, or I can go with the default ones that are available here. Custom base maps according to your need can be also added here. On clicking OK, you can see that the first page got filled with the base map gallery widget. The same thing can be applied for other widgets as well. I can select the next one and say I want an analysis tool in my application. I can go and select the analysis that are preferred in my particular web map application, or I can go for everyone. I can either select the particular function that I want, or I can go for all the analysis that are available. On clicking OK, again, the analysis widget gets added here. Similarly, I can customize my widgets for the remaining spaces as well. I can create my application and customize it according to my need. Once we do that, we go and save the particular application, and on launching it, it takes me to my web application. So this is one such sample application that I've created for the same data. You can see that what we have configured, the base map gallery is visible, from where we can change the base map, right? It gives us all the base map options that are available, which we can change it. We can go for analysis, wherein all the analysis tools that I have selected while configuring the widget are available here, and so on. So you can see it. So again, web app builder is another powerful tool of ArcGIS Online, or powerful platform of sub platform of ArcGIS Online, which will help you to create very powerful applications without without any coding as well. So we have learned about configurable apps, which was through templates, configuring apps through templates, very easy, right? Moving on, we understood how to configure apps through web app builder. There are other interesting applications as well. Moving forward, if you would remember, while I was taking the last session, you saw something called dashboard, right? That is another configurable app. So dashboard is basically a view of geographic information and data that allows you to monitor the events, make decisions, link to details together to come to a conclusion, see trends, understand the data in a beautifully visualized manner, and so on. Now, how to do that? Again, if I click on create web app and scroll down, you can see that there is something called dashboard. Selecting this will take us to the same item details page, where we have to provide title, tags, summary, and so on. On clicking OK, it will take me to launch page of creation page of ArcGIS dashboard, where I'll start adding elements to my ArcGIS dashboard. Now, so this is what the first look of ArcGIS dashboard is. So according to which web map I have selected, it has incorporated that particular web map and details, and a heading is there. Now there is something called theme here, which is very interesting, because we can work on more than one type of theme. The theme or the background that is shown is of light theme or light background, which I can change it to dark first and foremost. It just makes it interesting. I mean, it is a personal preference actually. According to how you wish it, you can take a dark theme or light theme. Moving ahead, you can add different types of components here. This is a bit different from what we have seen now for configurable apps and web app builder. So this is basically for relating data. I would say you will be able to visualize your data in a better way, and you will be able to relate different types of data in your web map in an application format. So starting with header, you can provide a header for your header panel for your dashboard, with the header for what exactly the data is that we are loading in ArcGIS dashboard. You can configure it according to your will, like according to size and color, background color, and so on. You can configure header margin as well. Once you are done that, you click OK, you can see that a header got created into your ArcGIS dashboard. Many elements are there which you can incorporate into your ArcGIS dashboard, like side panel, map. Map is already available here. Map legend, all these details that are there, you can have a legend of that. You can add pie chart, indicator, list, and so on. Let's start with list. Let me try to configure something. I can select which detail of the data that I want to visualize. I had mountain data here, road data here, stream, and so on. Like if I want to work with the road data here, I can configure it. You can do multiple, you can add multiple elements as well here. No issues. Again, Now the roads layer has been shown here. You can add a field here. You can have a list of like what all are there. You can have you have a general option of, again, customizing the visualization part of this. If you want to show the title and so on, you can add this particular element here. So if you observe, whatever elements that I'm selecting and configuring gets added on this particular panel or workspace. I have the control to space it or position my elements accordingly. I can move it from here as well. Like, that is completely upon me. On adding more elements, maybe I'll be able to make you understand more. You can add pie chart according to the data that you have. For example, like forest, you can basically select the category field according to what your this thing pie chart should be configured. So adding these particular data, you will be able to position it in a much better way so that you will be able to visualize it better. You might want your this thing map to be on the center and all the sub elements on either side of your map so that you'll be able to interact with it. Coming to the very interesting part, like I said, you can position it. So if you had observed how I positioned it, when I'm dragging it out, you can see that I'm getting, different types of anchors on every area, like in every corner, on the middle, I'm getting anchors. So all I have to do is bring it to that anchor where I have to position this particular data, and that particular element gets positioned over there. Also, another important thing is you can basically link two displays or two elements in your ArcGIS dashboard. What does that mean? If you go to configuration option of any element, you can see that there is something called actions, wherein I can basically command my ArcGIS dashboard that when I'm selecting a particular list here, what will happen. So when selection changes, I can add an action like flash or pop-up or anything. Let's go with flash here. What you'll have to do is you'll have to select a target over here, which means when I am selecting anything from this list, I want a flash to be happened on any target, say map. So whenever I'm selecting a road from this list, the particular road from map should get flashed. That is the action that I'm doing by linking these two. So I have configured the action right now. Let's see what will happen when I'm selecting this. Okay, you can see that the lines are getting flashed over here. I'll show you a better example over here and the map that I have configured for the data that you have worked upon. Again, we have some names of roads here, some pie chart, and I have configured an action between the list of roads and the data over here. If I select a Palkad main road, what I want to happen is I want that particular road to get zoomed here in the map. Let's see if that happens. I'm selecting this main road, and you can see that that particular road got highlighted and zoomed into the map area, right? Again, I can add multiple action here. I can make it flash, I can zoom it, I can light it, like so many actions are available. So I hope this was interesting. We are not done. Again, many more applications are there, and let me hand it over to Ajit to make you understand the next set of applications, or make you get you through the next set of applications.
Thank you, Deependra. So for the next apps, I'm going to talk about the story map. Then I'm going to cover experience builder, and there's some instance apps which are available. So first, let's start with the story map example that we have here. Yes, here. So as you can see, we do have a story map available. Again, it's kind of a template only, where it's all about nature-based climate solutions. So all of us, we have a story. Like suppose you went on a hike, you collected photographs, then you know the path that you followed, and then you want to convert that into a story. So you can use story map for that. Let's see here. So this is the like title slide we have here, followed by some of the screenshots and some of the information. And then we do have map incorporated here, right here, in our story, in this particular story. Then we can also incorporate videos and all this stuff. Let me show you how that can be created easily. So from accessing the app launcher, you can directly jump to the story map page. Then you'll be able to see this story maps template available. Then you can go ahead and start it from either from scratch. You can select some of the templates also available, like sidecar, guided map tool, or explore map tool. So I'm going to start from scratch. Like this. And I'll just show you the widgets available. And as a part of the assignment, you can decide which will be the best one as per your the data that will be provided to you. So you can see we have this option called add cover image or video. If you go down, you will get these options available, like map, image gallery, video, audio, embed particular website or link, swipe option that we just saw, so that you can use it web map here. And you can also add a 3D web scene also here. So both your 2D web map as well as your 3D web map. And you can build a beautiful story out of your the story that you have. Coming for the next app, which is Experience Builder. So you can see from the app launcher right here, Experience Builder, which is again a template available where without writing a single line of code, you can create beautiful web application. So I'm just going to start with the link. Let's see which are the options available for us right here. So like a blank scrolling page, a blank full screen, or let's say general, reveal, journal. So these are the templates which are available. So I'm going to start with this foldable template. Then we'll be getting this particular option here. I'm just going to use this tool at the bottom, fit. As you can see, we got the map here, and I can go ahead, select that widget. So we call this widget basically. And I'm going to select the map. Then I'm going to add new data. And let's add the same example that we just saw in the first exercise. That's it. So you can see the map will get added right here in our map window. Like this. So this is how you work with your Experience Builder with the available templates or the pages. You can start with the blank page, then you can go ahead, check it in live view, or how it's going to look like on various devices, tab or your mobile device, and you can save it and publish it, and then share with public use, or you can share that internally. So that is configured app called Experience Builder. Apart from that, we do have something called instant apps, which will basically help you to create like mobile specific surveys or apps. So you can access this particular this link called Survey 123 web page. You can create surveys here. The one that uses quiz, right? So that particular such questions or quiz can be also configured here, and that can be shared with the users. They will be able to fill all the questions, and the administrator or the data owner will be able to visualize the data sets here. So it can be, as I said, it can be accessed in the mobile browser or mobile apps also. It's the mobile apps. So as in the form of web maps or the surveys. So that's all from our side on the configure apps part. So I guess we do have.
Thank you, Ajit sir and Gitanjali ma'am. And it was a wonderful presentation, and a lot of potential we can see by when we say we are moving from map to app. There was a time when geographers used to carry big maps, and then they used to do analysis by overlapping different maps on it. Now we can see that the multiple maps are coming in our hands, and then it has multiple application, like from various industry. If we see from transportation to disaster management, everywhere we can use it. Thank you. It was a wonderful session. So now for the team, we have a quiz, and the link of the quiz is already posted in the chat window. We will get another 5 minutes to answer the questions. So 7:41, we will be back. 1 more minute to go, guys. Please submit your responses fast. Yes, so the response accepting is now closed. We'll see what the result is there. And then the next session is a hands-on where you will be actually building an app. I hope you're enjoying the sessions. So here we have the results. Okay, nice. So 58% have correctly answered question number 2. Very good. Oh, 88% have correctly answered question 3. Then question 4. No, more than 50% have wrongly answered. And question number 5, 33% have correctly answered. Okay, nice, good. Now we move ahead with the hands-on session where you will be actually building the app. And I think all of you must have got the license configured, or if you have any network issue, don't worry, you will have the licenses to work on it, and then you can submit the answers. You will have proper 2 days time. After this also you will get an assignment that you have to submit, and all this will be considered for your evaluation. And whoever is going ahead in hackathon, these exercises will be very useful for them particularly. Also, we will be evaluating you for giving you another opportunities like internship opportunities or even MTech opportunities in the center. So we go ahead with hands-on now.
So let me just explain about the assignment. Sorry, hands-on. So this particular assignment, hands-on 2 is all about, yes, as Valmukund said, so you're going to create one app basically by using the web map which is available, and you're also going to use this arcade expression, and you're going to configure it with the particular urban areas. So for that, I guess I have already demonstrated that functionality. So you can just go ahead and do it yourself. So, and the duration for that is about 30 minutes. So I'll be also parallelly showing step by step, so I'll be explaining it. So, and for the web app creation, we're going to use ArcGIS Experience Builder. Okay, so this is the handout. You can see about the information about the arcade expression, and we're going to start configuring it from this table. So we're having time till 8:50. So let's start with the first step. I hope you have access to this material. And we're going to start with we're going to continue with the exercise 1. If not an issue, you can use the original link from the exercise 1. So if you were unable to continue and save as a new map with your own name, you can use the original map as well. So we're going to turn off all the layers here, like this, you can see here. Next, we're going to first explore the attribute information that we have, basically tabular data that we have, like this here. So once you click on that layer, you'll be able to see this option, the table list. So once you see the table or see the attribute information, you'll be able to notice that we do not have that population density field available. So using arcade expressions and the available data that we have, we're going to configure and get the information about population density. So you can see the formula here. Population density, as you know, it's like number of people or total population divided by area. Next, after we have accessed this table button, we are going to go ahead and click on this more options, and then we are going to click on this configure pop-up window. Once you click that, you'll be able to see this option here, this particular window, configure pop-up window. In that, you'll be able to see the list of attributes that are part of the that are getting displayed. Then under this attribute expressions, we're going to click this add button, and once you click add, you'll be able to get this arcade expression window. Just copy this particular expression to area and paste it. then don't forget to test it. So it's basically verification stage where if there are issues with your expression, let's say you just you have a typo here instead of population, you just missed one n or something. So this will help you with debug. You'll be able to get the result in this window here below. Once you do that, so right now, as you can see, the name is custom, right? So click on this edit button, small button, and just type population density and hit save. So as I mentioned in the demonstration part, so as you know, this population and the area, these are like the data that you already have. These are basically fields in the attribute table. So that's why this expression is going to read the data from those fields and perform the calculation. Whether division, multiplication, this is a simple one, so you can basically configure complex expressions as well. So let's see, OK here, you'll be able to back to this window, the position, configure pop-up window. And in that, you'll be able to see this here, right? Population density under this add attribute expressions, and this add. That's one expression is configured successfully. So when to do that, click OK. And just observe the table as well as click on any one of the urban area to get the pop-up information. So you'll be able to see this population density. That's it. So that was exercise 2A, configuring arcade expression to get the population density. Okay, so let's start with exercise 2B. So first we are going to start with creating a map-centric experience using the template that we saw in the demonstration part, which is ArcGIS Experience Builder. So it's readily available template. And we're going to use that to build a very good and beautiful and meaningful web application. So first, you can directly click on this link here, or you can do it from, you can launch this application even from the app launcher. So let me just show that. So if you go to your organization and content tab, you'll see this app launcher where basically you can launch all the apps available with the ArcGIS Online. Like the Server 123 instant app, story map that we talked about, the ArcGIS dashboard, or the experience builder that we're going to use with the success result. So once you click it, you'll be routed to this page. Then you have to click create new, that you will see at the bottom, so top right. Then select the foldable template as shown in the screenshot. So create new, foldable template. So you can see this is a default templates available. Pocket based. So I'm just going to start with folder program. Okay. You can go ahead and explore all those templates which are available. Then at the bottom right, you'll see this option called fit width to the current window. So press that like this one. So you'll be able to see this map widget properly. So you can see this is a page 1. You can see here, right? So you can build multiple pages. Then you can like switch from one to another page, like the what we do in websites. So you can see all this information here, like text widget is available here. Let's go back. Like this. Here we have subtitle, title. Then we do have like map layer tab, the legend tab, and then add widgets. So that one, the widgets that we have already seen, a few of the widgets during this ArcGIS dashboards or web admin, like the legend, map, bookmark, table, filter, query, chart, stuff, including the widgets. So next, we are going to define the input. Since we do not have any, we have just only the base map. We are going to configure the map that we just used in exercise 1. So just select the widget, the map window, and you'll be able to see this map option here. And at the bottom, you'll see this add new data. You can see right here. Everything is explained here as well. Add data. And select the map that you just created. Or you can check another map as well. So let's go back. Add data. Then site news hospital. I'm just going to select this. And at the bottom right, you'll see this option called done. Once you select it, you click on done. So you can see these are the ones that we just used, created earlier. That's it. So after a few seconds, it will be added in the select data tab here. Like this. You can see this for the arrow also for indication. Once you do that, close the select data tab here, select it. You'll be able to see the map here and close it. Next, we are going to configure the legend widget. So you'll see it right here, legend. Just click on that. You'll be able to see like H, as you know, this particular symbol is what? Hospital, then the roads, the urban areas. That's it. So legend is like by default it's configured. If you have to change it, you can just click on the widget and then edit, something like this. Delete. Fine. Or you'll see this widget controller properties right here. Right. You can select this time. You can just explore the various possibilities here which are available. Select free change. Once you do that, once you're done with the configuration part of legends, then we go ahead and modify the title and subtitle text results. So let's do that as well. So this should be the name of the app. So since I don't need the subtitle, I'm just going to delete it. So to do that, just first, make sure that you are not in lock mode. So just check this box. And you'll be able to see selected title and then select the title, main title, edit it, paste the content, the name basically, Control A. You'll be able to see or manage the color, font, size, everything. That's it. It's done. So this is your title. Map, title, legend widget, is everything's complete. So if you want, you can go ahead and like at least query or everything that you do. And as you know, everything is happening on this page 1. So you can go ahead, add multiple pages here. Like full screen, scroll the page, custom page, you can wait it for you. So once you do that, like once you define the title, you can refer it, go ahead and save it, preview it, and then finally publish it. So let's do that as well. So put it in log mode. Check how it's going to look on multiple devices like this. Or you can change the custom size also here. Let's say this is the device size. So for like better experience. So these are like responsive apps. So once you like change the display size, the app will get responsive. Then I'm going to save it here and run it, preview it. So before publishing, publishing or making available to other users, preview that, like launching. That's so this is the simple experience builder foldable app that we just created. You'll see the legend here, the layer list here, and the title that we just designed. You can give the like logo also here, university logo. And this can be shared with users. So once you do that, I'm just going to refresh my content page. Content is like, as you know, inbox, right? Everything, all the content will be stored here. This is the one that we just created. I can go ahead and share it everywhere so that anyone outside the organization can also access it. So that's all about this exercise. So you should be able to get this in the end, like the locations, the basically web application showing the locations, new locations for setting up the new hospital, specialty hospital in Coimbatore city.
Participants, I hope you're enjoying the hands-on session. And if you have any doubts, you post in the question answers and the Telegram window. You can share your screenshots and our team will be able to help you.
So I'm just going back to the first step. Let us know if you have any issues in accessing and configuring the arcade expression. Okay, so we do have something. Okay, step 2, we do have like some questions. So can you just go through it? I'll just share the web map as well. So as you can see here, since right now I'm in the web app, so just as I said, turn off all the layers except the urban areas, and just click in the map here for the AD area. You'll be able to see currently these three, like the object ID, population, and AD. Make sure that you're turning off all other layers. Step 2 of which exercise we're talking about here? Okay, second. It's all about like just clicking on this particular link here. Which you're talking about the experience builder. Click on the step 1, sign. Step 2, create a new. That's it. Just click on this link. You'll be taken to this page and sign in. That's all. Please can you let me the page number as well where you're facing solutions? Because in exercise 2, we do not have anything called create new map. We are just going to create new web application, not map. That. So if you're referring this particular exercise, this one here, create new, refer the screenshot right here. So let me just go back, create new right here, top right here. And you'll be able to take into this page. Just refer this this URL, experience.arcgis.com. Then, if required, sign in. Something like this. This page. So once you go to that page, you'll be able to see this option called Create New, and then select the foldable template, this one here, and start clicking. So we still have like 3 more minutes to complete the exercise. Then we'll start with the next session. So once you create new, since as you know, like a web map is basically like input for all the web apps. So next is about that. So selecting the right web app. So here it will be like considering the client or the like audience specific with whom you want to share the data and what type of data that you want to share. So it will be something like this, create it. Use this button to fit it. Then, as you know, select this window, the map window. So you'll be able to see this options, properties option or configuration page on your right hand side. Once you do that, click on the select map option. And then at the bottom, you'll be able to see this option called add data, add new data. Select the appropriate web map, as you know. And done. Again, button right. So within few seconds, map will be loaded here, and then we have to select it. Otherwise, it won't come here, appear in the map widget, something like this. Then close this window. Then we are going to turn on the lockout mode, and we'll check one by one the widgets that we already have here. Let's say the legend widgets already there. Since we do not want to have subtitle, we need to delete it. And we are going to modify the title. So just refer the document handouts, just copy it there. Let's increase the size to size to 20. Change the color, let's say to yellow. Click anywhere in the map and just try to extend, adjust the widget like this. Same functionality we have seen even in ArcGIS dashboards as well. So it's as simple as you have noticed now with just simple configuration. So no customization. So without writing a single line of code, you can just select the template and use any one of the web app which is available with the ArcGIS Online. Let's say, let me just show those apps again, like this here. Like Web App Builder, Experience Builder, or the one that we saw, Story Map, quite interesting. Then the dashboard, like you must have seen COVID-related dashboards, right? So you can build it from here. And once you select it, select the map like this. Then you can go ahead, check it how it will look like on various devices. Don't forget to turn on the lock mode, lock layout mode, save it. And before publishing, as I said earlier, preview it, like how it will look like before you share it with public or organization. Just cross check all the widgets. You can see the title here, your list, and your legend. So you can further like you can add other widgets as well, like base map switcher or layouts. You can see it here. Multiple pages, or let's say table query feature, or just one click. Okay, so the time's up, I guess. So yes, over to like what do you do?
So we will now start with the last session. for today's workshop. I'd like to introduce Ms. Sharanya M., Senior Engineer in Esri India Technologies. Her interests, specialization lies in using GIS solutions for railways, roadways and highways and mining industries. Her interests include exploring the potential of GIS in improving the organization's efficiency and day-to-day life of individuals. She will be giving a demonstration of multi-criteria analysis using GeoPlanner and Suitability Modeler, which will then be followed by a brief question answer session. So floor is yours, Ms. Sharanya.
Sir, am I audible?
You are right.
Okay. I will. Can you just confirm if my
The audio is not very good, Ms. Sharanya.
Yes.
is this better now?
There's a little bit of a feedback, but please go ahead.
How is it now?
That's good. Yeah, thank you.
Thank you so much. Sorry about that. So thank you everyone for joining today, and thank you for the wonderful introduction, Chandana. It's very kind of you. And thank you everyone for your patience for sticking this long. I know it's a long session, but I really appreciate your patience. So in this part of the session, we will be talking about ArcGIS GeoPlanner. So Geetanjali and Ajit showed a lot of web applications we have within ArcGIS Online. GeoPlanner is another application which is JavaScript based. And this is also very easy to use, where you can gain a lot of insights about your data. GeoPlanner was basically created to help planners, especially town planners, urban planners, landscape architects, to compare various scenarios, because there is no one right design when it comes to a town or a city. So we need to have several alternatives, and we need a place where we can play around with them without spending too much time or money. So in GeoPlanner, you can create several scenarios, compare one scenario with the other, include few data about financials if you have any, and you will be able to evaluate all the models you create and come out at a very good decision. So in GeoPlanner, we have a lot of options, just like other applications. We have rich content of imagery and base map. We have user content, which means that you can publish your own data in ArcGIS Online, and you can utilize them in the GeoPlanner, because GeoPlanner leverages ArcGIS Online to the fullest. It also has the geo-enrichment tools and cloud-based spatial analysis tools, which Geetanjali showed earlier, which we will also see in the GeoPlanner window. And one of the USP of the key thing that differentiates GeoPlanner from the other applications you saw is the weighted overlay analysis. So if you are a civil engineer, you must be familiar with the concept of finding the suitable site for any upcoming constructions. Let us say you're trying to build a new school, or you're trying to build a new cyclone shelter, or you want to find a new center for vaccination. There are so many decisions. There are so many decision-making factors that goes into consideration. Example, you need to understand if the new piece of land has good connectivity with our roads. Is it close to hospitals, so on and so forth. Depending upon the entity you're going to construct, these decision-making factors change a lot, right? So in weighted overlay analysis, we can stack up all these decision-making layer and bring it in GeoPlanner and assign weightages to every layer and come up with a suitable model. you will understand it better in the demonstration part. So what GeoPlanner allows you to do is it encompasses all the tools that is necessary for a complete planning process. You can create your projects, publish data, or put all the data together in a single place from which you can access them, assess them, create scenarios, create various alternatives, evaluate these alternatives, compare them, and create a report. This you can share it with your colleagues or others in your organization, or even to your boss who will decide on which goes further. So similar to other applications we saw, GeoPlanner can also be used in desktop, tablets, and several other devices, and it runs on several operating systems as well. So when you create a new project in GeoPlanner, you will be given access to several templates that are predefined. As I said earlier, GeoPlanner was developed for planning scenarios, but these planning can be of any industry. If you're planning for special events, public safety, land use planning, military base planning, we have templates for all of these different things. Let us say you are a unique industry and you want to have a template of your own. Such user-defined templates can also be created. So why do we go for GeoPlanner? Because it helps you assess your project qualitatively, quantitatively, and also visually. So you can make decisions quicker. You can leverage any data. You can leverage the data that is available on ArcGIS Online, or you can leverage the data that you have collected on your field and share it with the GeoPlanner. It is usable by everyone. You don't need to have a coding background or a better understanding of the software to run this. This is very user friendly, so it can be used by everyone, and it can perform several spatial analysis, and all these spatial analysis are cloud-based. So you need not worry about if you have a desktop solution, do I have a good GIS software? You need not worry about all this. It's completely cloud-based. So you're set, you can do your spatial analysis easily. And you can get immediate feedback. What any designer wants is, if I change this percentage by 5, if I increase it by 5%, what will be the outcome? If I decrease it by 10%, what will be the outcome? The feedback is very immediate and it is very dynamic. So it's really easy to use. And since it is cloud-based, you can use it anywhere, anytime, and from any device. Now let's move on to the demonstration part. So just like how you accessed other applications, you can use this icon here and you can go to GeoPlanner. Here we have GeoPlanner, and the same credentials you use for ArcGIS Online works here as well. And once you go to the main page, you will be given options for the template. As I said earlier, we have a template that is predefined for economic development, green infrastructure planning, military mobility, so on and so forth. So you can review any template just to get a feel of what are all the polygons or options available there. For example, if I say I wanted to plan for military, you already have some of the features predefined, like where is my air control point, where do I have the double fence, what do I have area of operation, what is the extraction zone, landing zone. So all these features are already predefined, so it is easy for you to start your planning process very easily. So for today's demonstration, I have created a basic template. So if you have watched ArcGIS Online videos so far, you will be able to understand most of the tools we have here. It is very self-explanatory. You can save your project, open, create new. If you have any attachment that is related to your project, let us say you have a PDF document of your design files, you can attach here. If you want to export it as a web map, once you have finished your analysis, you want to make it a web map and share it or use it in further application creation, we can do it. You can collaborate with others in your organization and also print whatever the results you get in the format you want and in the layout you want. in addition to that, you can also see we have options to add data. So you can add your own content or from your organization, or you can just select all to see what are all the layers that are accessible to you. So you will be able to notice that we have access to maps, features, imageries, analysis, and weighted overlay models. So this weighted overlay model is what will help us in doing our site suitability analysis. As I said earlier, we also have the spatial analytical capabilities. Whatever you had in ArcGIS Online, like summarize data, find location, data enrichment, all the options are available within GeoPlanner as well. So this is where we will be discussing today. This is a modeler. So you can create your new model here. If you're going to find a suitable site for, let us say, school or college, you need to have a weighted overlay service first. And I'm just going to call from my content here. So I'll just open my project. So in addition to site suitability, it also has other options. Just as I said earlier, you can compare two scenarios, create reports. So I'll just close here. You can compare two different scenarios. Let us say these are the two locations you have finalized in scenario A. Here I have scenario B. I can compare these two and find out which site is suitable for my construction. You can also have small dashboards which will show you key features like what is the distribution of land use in that particular area, what is the area
I think she's missing connectivity. Gitanjali, can you? Oh, sorry.
Yeah.
Suddenly unmute yourself.
I think we lost connection for a while. So.
Yeah, sure. Continue.
Yeah. So where were we? Yeah. So once you go to the GeoPlanner window, we have an option to create a new model where any weighted overlay service you have published, you can call it here directly. Here I'm just calling my service that I have created. So if you are interested in seeing what lies within this weighted overlay service, you can take a look at all the layers. So if we are constructing, let us say, a university campus, there are certain things we need to take into consideration. Example, elevation will affect the accessibility, or a slope will affect how much cost goes into construction. Because if the land is has high slope, it will be difficult to perform construction there very easily. And another one is land use. We should not encroach upon forest land or any other private property. We need to be considerate about what are all the, let us say, rainfall patterns, etc. So we can bring all of them in a single screen. Let me just remove this and call the model again. Yeah. So here you can select which layer you would like to use for your further analysis. And once you have selected the layer, let us say I would like to work upon elevation, aspect, and slope. I can design my model here. Here you can assign weightages for each of these models. So this weightages will depend upon your decision-making criteria. Let us say I want to give all these equal weightages, you can give. Or let us say aspect is not that important to me. for me, elevation is more important. You can change your weightages here. You can also give your preferences, like whether you would like to have the campus in a low elevation area or in a high elevation area. So you can change these weights very dynamically. And once you save the model, it will be reflected automatically. Once the model is saved, you just have to give the title and save it here. And you can also download the model. So once the model is run, you can use this icon here to download the maps. You will get two files. You can download the TIFF files and the color maps. This you can open it in ArcGIS Desktop or Pro, or you can also use it in the future further web map creations. So in addition to this, we also have options for designing. Let us say you want to add some attributes here, or you want to edit few or add more polygons here. Let us say I would like to add another land use. I can do it here, and this will become a part of my scenario A. And if I want to create the scenario, you can create from here, or you can shift between two scenarios. So, and at the same time, if you want to evaluate two of them side by side, you just have to call them here. I'll call scenario B here. So once this is done, you can configure your dashboards. In addition to that, you can also perform more analysis here. Let us say you want to find nearby locations, or you want to find what are all the hazards in that particular area. You can just add those information and do the analysis here. So here I have created a model in India, and in here, the same model, I'm calling it in a web app builder. So if you have watched my colleague's presentation earlier, they showed you how to use web app builder. So once that GeoPlanner has given me a model output, I'm calling the same TIFF file here. I'm using my capabilities to add or configure applications, and I'm using that model here. Once this model is called, you can use it for finding optimal routes. So here I have integrated a geoprocessing tool which can find the optimal route between 2 points. So the output from the GeoPlanner is now used for further analysis. Example, finding the optimal route. You can give your source and destination, and you will get an output like this. This you can create road buffers and export to others. Or if you want to find what are all the roads that are intersecting with drainage lines, you can do it. So all this is limited only by your imagination, and all depends upon the objective of your project. All combinations are possible. You can move from one app to another. The output from one application can be used as input in the second application. So these are some of the possibilities we have. In addition to creating this model, you can, whatever outputs you get. So here, let us say I have changed my model values and created a new model. This legend shows us which is the highly suitable area and which is the least suitable area. So you can share this map with others using our sharing option. So in this part, I have tried to integrate two applications, web app and GeoPlanner. The same, you can embed it in a experience builder, just like the second exercise you guys did now. So here what I have done is I have called my site suitability analysis and optimal route generation in the same experience builder. So when I select from here, this will take me to the GeoPlanner website, and this will take me to the optimal route generation part. So this way you can experiment with different apps, and you can link one app with the other so that you get a very good output. In addition to these two, you can also create your own dashboards and put them all together in a single place. So it is easy for you to access and present your result to others. That is all from my side. Now we can open the session for question answers. Thank you so much.
So, thank you everyone for this for giving this opportunity. And so we're now open to the question and answer session. So please do let us know if you have any queries or any questions related to today's topics and exercises.
So whoever has any question, they can raise hand.
You can put it in chat box as well. So in chat box, or you can also put it in Telegram.
Yes, please post your questions either in the chat or in the Q&A.
So we have one question from Mansa. So is this application based on AHP concepts? So can you tell us more about AHP?
Yes, Manasa. Like you're talking about analytical hierarchical process, right? This is also similar to that. There we give the weights. You use that ratio to give the weights. Here we are giving the weights dynamically. So the concept is very similar. That is also one type of multiple criteria analysis.
There's another question in the Q&A box. How did you use this methodology in your work?
Okay. Just like I said, it depends upon what project you're doing. Let us say you're trying to find, or if you are a civil engineer, you're trying to build a new construction in any area. Let us say you're building a university. You need to find a suitable location, right? So whatever or the decision-making layers, I will bring it together in a single place. I publish it as a weighted overlay service, do a site suitability analysis. Once I get the pixels that are suitable, I can narrow it down the whole area into those few pixels which are now suitable. Now, based upon a land acquisition process, you can just take it further. So this is just useful in the pre-construction phase when you're doing site selection. I hope that answers the question. Arya? Thank you, you're most welcome.
So regarding the ArcGIS license, you'll have it for the next 2 days. So you can work on the assignment, which will be announced soon.
Yes, so Arya, we do use both, like GIS as well as like we do analysis, like we do perform like such as like what you can say field survey, and we collect data from field survey, we bring it and we perform GIS analysis on the top. So the like field survey is like one type of way we can collect the GIS data. One of them, as you know, like satellite imagery. So you can take that data. You can just look for available data sets, or you can do field surveys and collect the data. It's like you combine all the data sets and you do the data management and then perform analysis. So ground truthing is also part of basically field survey. And analysis in the field can be, yes, performed directly. So if you have like mobile devices nowadays, you must be aware of mobile GIS part. So you can directly go into the field, you can use your location and perform analysis there. So with your like current location, like real-time data, if you have, you can use it as a input.
Just to add to the licenses question, whoever is participating for hackathon will get an extended license. If there are no more questions, we will then proceed to the announcement of the assignment.
So thank you team. And now we have came to the final part where whatever you have learned, you will put it together and do assignment. And the assignment is already posted in the teams, in the chats. So you can do that assignment. Along with the assignment, the final output is also posted for you to compare, and you will get time till Friday. We will send you the form in the team where you have to submit the assignment, and also there will be a small quiz based on the assignment, so that will all be considered for evaluation. In your assignment, you should also enter your name in the map itself, so that it can be like your thing.
So yes, assignment deadline is Friday, that is the 11th, 11:55 p.m. The instructions have been sent to you. We will circulate a form through which you will submit, and please name your map so it's easy for us to identify, and there will also be a quiz based on the map. If there are any questions, we will be available. That is, the Amrita team for the workshop will be available until the deadline of that is Friday, 11:55 p.m., 11th June. We will be available to answer your questions in the Telegram group.
Yes, and from here you can continue thinking about whatever you have learned, not only in this workshop but other workshops also, and how you can build your hackathon project. You can consider these workshops and the symposium as a starting point for that, and then based on that you can move forward. Now I request all the panelists to switch on their video for a group photo.
Thank you. It's taken.
Thank you.
Thank you, everybody. And I'd like to take this opportunity to sincerely thank the Esri team, to Mr. Ajit, Ms. Geetanjali, and Ms. Sharanya for conducting this excellent workshop, as well as the Amrita team, Rahul, Aparna, Srinidhi, and Nandita, for helping us in the background support to help run this smoothly. Thank you very much.
Thank you.
Thank you, everyone.
Thank you,
It's really
everyone.
nice connecting.
Thank you so much.
So please be on to have the validity session after this, and I hope you enjoyed the workshop, and I hope you will be able to carry forward the ways of making map into app and to using different applications, freely available tools, and how you can embed it into different sectors, how useful it can be. You can think about it and then come up with your ideas for the project. Also, based on your performance in the hackathon and in the workshop, you will be offered for internships. So stay tuned with us. And if you have any questions, you can always reach us. Telegram group is active. You finish the assignment, and further also directly contact us. So thank you very much. Thank you all. And please stay available for the validity session. So it will be starting in few minutes. And yes, there is a feedback form in the chat, so please leave your valuable feedback on this GIS workshop. I hope we were able to give you some thing which you expected. And for issues, I apologize from my side. So we'll be able to fix it. And you can definitely work on the exercises. The videos are all available in YouTube, so you can follow it. And the instruction hands-on is given to you. Exercises are given to you. You can submit us. We will consider that also for evaluation.
Shouldn't she?
Yeah.